அன்பு கிரில்லன். Hi everyone. We feel delighted to welcome you all for the AZConf 2021 on behalf of the community and the MVPs. Thanks for joining again, and a special thanks to various speakers and organizers from the different time zones. There are around 200 sessions planned for today, 2 days in 10 different tracks. Definitely, it will be a very good learning experience for all of us, and everyone is very eager or awaiting for that moment. And I hope all the attendees might have read the code of conduct, and we request to follow the same for the benefit of everyone. That's one of the humble requests from the organizing team. And well, I'm not going to take much time of like we'll start in another 1 minute. I cordially invite Mr. Rohan to present the keynote, and Rohan is the corporate vice president for Microsoft Data Platform. And thanks. Hi, Rohan. The stage
Hi,
is yours.
thank you. Thank you for having me.
Thanks, Rohan.
All right, so can we start?
Yeah, of course.
So, namaste, everyone. I hope you all are doing great. I have with me Kirill and Lani, who basically, were the brainchilds of sort of creating this. Kirill, who leads our, as a partner director, leads our Cosmos DB team, and Lani, who manages all our communications, are helping me with this keynote. So I did want to sort of thank them at the offset. So I'm really excited to be here for the, India's largest Azure Community Conference and share and recognize the efforts of, the MVP community in India and the community experts who've created this amazing 3-day conference. So today, I'm told you'll hear from more than 200 plus speakers presenting over 200 sessions, 3 exclusive workshops, overall covering almost all the cloud services that can help you learn and love Microsoft Azure and be efficient at your current and future roles. But before we begin, I want to take a moment and say it's a pleasure to join you for today's event. Across Microsoft, if there's one thing we truly appreciate, it's the value these connections with the community and the personal touch, brings to the table. I know I look forward to, joining you maybe in person. With this global pandemic, things have been a little hard for all of us, but hopefully we'll get to meet sometime in person in the future. Now let's get started as I take you over the next, several minutes here on a journey around Azure for developers. Let's build an app together. Next slide, Carl. Over the last 2 years, businesses all over the world were challenged to operate in new ways. All of us needed to meet customers where they are, where they were increasingly in digital space, accelerating transformation for businesses big and small. At the end of the day, businesses turn to developers like yourselves to drive this innovation. And developers had to confront these challenges at a rapid pace. Like in our experience working with developers over the last couple of years here, you need to build smarter and faster. You need to move from idea to code to cloud seamlessly. Developers need new applications to be resilient in the face of failures, scale dynamically based on load. So if your load grows, the application should just scale. And finally, developers need amazing security. So features like intelligent threat protection in near real time and fine-grained security at each layer. And all these have to be solved at scale. This requires a new approach to building applications. Next slide, please. Whether your goal is to modernize existing applications, build cloud-native applications, collaborate and contribute to open source, or rapidly build applications with low-code platforms, Azure is here to support you with the right tool for your job to increase velocity and enable you and your team to build on your own terms. You can bring your existing applications as is on virtual machines. Modernize them with Azure Kubernetes Service if you want, or rebuild or build completely new cloud-native applications with our PaaS and serverless offerings. You can leverage our low-code offerings, our Power Platform, which is literally the #1 low-code platform today, to bring productivity to your business. You can choose the database of your preference. That's something very, very close to my heart, being a part of the data team at Microsoft, with all the popular databases available. So not just SQL Server, Postgres, MySQL, MongoDB, Cassandra, Graph APIs, anything you name it. We offer them as managed services and serverless options which scale limitlessly. Finally, you can use these frameworks and tools of your choice within familiar GitHub and VS Code environment integrated with Azure to automate your developer inner loops. Next slide, please. To help us explore how Azure gives you the velocity, the reliability, and security you need, let's go on a journey of a startup. Let's take an example startup getting started on Azure. We'll follow the life cycle of a developer team and application on Azure, all through the lens of the journey of that startup, from zero to billions of users with their application, right? Even though it's hypothetical, if you go to the next slide, on our story, the startup is Adatum, looking to gauge interest in their proposed new product. It's a new ride-sharing application. And my hope is with this, you get a sense of how to build these things in Azure. So first of all, it's a startup, right? They don't have a lot of money. They basically just plan to build a landing and a sign-up page for their application to help gauge the product market fit and excite their potential investors. Next slide. They don't have months and a lot of money to spend, right? I mean, it's a startup with a couple of developers, so they don't have that kind of money to spend. So get started, they create a Next.js project using their favorite Node.js framework and generate a landing page with it. They push their code to GitHub. Next. With their whole team now can contribute using the familiar interface of GitHub, as you see. Next. To deploy the site on GitHub repo to Azure, on the GitHub repo, they use static web apps and connect it to their GitHub site. Now, Azure Static Web Apps is a great service for building single-page applications, which is what they have to do right now. Azure Static Web Apps will help add the right GitHub actions and settings needed to automate publishing to Azure on new commits on any branch that they need. Next. To store data, the team decides to use Flexible Server for PostgreSQL. PostgreSQL is one of the most popular relational databases, especially in the open source community. For storing, and they use PostgreSQL to store the signups that they get and they receive when they actually go public. Now, Flexible Server comes with the benefit of being able to efficiently handle bursts of traffic to the site if their site hits the top of Hacker News. Next. Azure Static Web Apps also has support for publishing Azure functions, which means we can use API routes in Next.js to securely access our database. That's important. Security is super important. With just these few simple pieces, they have everything they need for their soft launch. Remember, very few developers just trying to put a landing page together to gauge interest in the product that they're imagining or they're envisioning. So as we just saw, our team at Adatum was able to take advantage of the tools that they're familiar with, right? Like the development environment, GitHub, open source databases, etc., that they're all familiar with in a very, very simple manner. They're able to use their favorite languages, frameworks, and databases. And everything you see here can dynamically scale, right? So if your load grows, your application can dynamically scale with the load from low to high demand as they launch their site. Now, here's the best part. The best of all is that they're able to build all of this on Azure's free tier. The services they use, all of them have forever free tiers. So they'll only have to start paying if their site ends up being very successful with their launch. Till then, they don't have to pay anything, $0. If you're curious to learn more, you can check out what's available in free Azure. The next, please. As you can see here, you get more than 25 services free always on Azure, and more free services free for a year, and a handsome credit to start with. So with the combination of all of these, if you have a brilliant idea along with your friends, you can develop something very quickly, do all the signal testing you want very, very easily. All right. Now, coming back to our story. With a huge interest demonstrated for their soft launch, they basically looked at the signals, and the demand's been amazing. Of course, ride sharing will be popular. They secured funding from their venture capitalists, and now they're building their V1 ready for a full launch. Next. Their goal is to launch in Mumbai first. And why Mumbai? Because the second test of India versus New Zealand cricket series is coming up in the start of December. They want to use that event, that cricket match, to drive the bus for their launch, as they're confident India was going to win that test match. With that ambitious deadline in mind, they need to be able to build something fast, but have rock solid quality and scaling, right? I mean, with the growth, they don't have a lot of time, but they have to build something super fast and scale. Now, thinking for their initial launch, they again reach for Azure's Developer Cloud and their favorite tech. Since this is their V1, and the timeline is tight, they need to avoid over-engineering their system. A classic problem that all developers face. You can very easily over-engineer systems, but they don't have the time to do that. But if they succeed, they also know that they'll have to scale out fast and capitalize on that success, right? That's the important piece over here. As developers, I'm sure all of you have, tight deadlines to meet, but you don't want to cut corners because eventually, if things are not designed right, they'll come to hurt you. And this is the challenge Additum, our startup here, faces. They have a tight deadline to meet, so they really want to avoid over engineering, but they at the same time invest in building something that can scale. So what do? They basically decide to go with a microservices architecture, which is, as I'm sure many of you are familiar with, it's effectively in cloud. When you think about building cloud native applications, that's really the core essence. How do you design the architecture with loosely coupled components that can work together in ways that your system becomes inherently a lot more reliable? So if something fails, you can quickly bring it back up, and it's a lot more scalable because as your system is built out of microservices, it can scale significantly based on load. But then, and in this case, our developers in the story here are essentially leveraging various cloud native services than managing their own infra. The last thing you want to do as a developer is spend all your time and resources in managing infrastructure. You really want to make sure that you work with managed services that do all of that for you, so you can focus on basically the business logic that's needed in your applications, right? That's really where you want to be spending time. Now, for the actual API layer, the developers of Datum decide to use Apollo's GraphQL plugin for Azure Functions and connect that to Cosmos DB. So next, similar to our previous example, Azure Functions will handle the scaling in or out to meet your demand. Azure Functions can also run in Kubernetes if you decide to use that later on. That's important because Kubernetes and containers have sort of become the de facto standard for a lot of new and scalable workloads. Azure Functions also has support for WebSockets, thanks to Azure Signal R service, which makes real-time location sharing in their app a breeze. It's very easy for them to track things in locations in real time, which, as you can imagine, for a ride-sharing app, is very core to the experience of their application. So that is important. Now, our team at Datum also takes advantage of durable functions to handle the orchestration of rides themselves. Durable functions make it easy to write durable workflows so we can easily track when we are waiting for a driver to be assigned, monitor a driver, and use where the driver is during a trip, and react to the ride to get done to handle things like billing, giving feedback, getting feedback from the rider on the trip, and things like that. So all those durable workflows can be done using durable functions. Next, please. Now, Azure Cosmos DB. It's. I mean, for those of you who've already used it, it's pretty amazing. I think some of you may know that Walmart.com, the number 2 e-commerce site in the world, essentially completely runs on Cosmos DB. It's a pretty phenomenal story of how they basically reimagined the future of the world of their e-commerce platform on Cosmos DB. Now, it's perfect for this application. Cosmos DB is designed to scale horizontally. It auto scales automatically, right? So with your load, it basically an auto scale by itself, and will work with both their V1 and their V100 as their business scales and they become like the most popular ride-sharing application in India. Cosmos DB can handle that scale, starting with very, very small workloads. They also decided to leverage the change feed capability of Cosmos DB. It's very, very popular for microservices architectures to trigger microservices as implemented in Azure Functions, right? To allow for that event-driven architecture. If some event happens, it's captured as a change feed event inside Cosmos DB, and then based on that, you can trigger an action using Azure Functions, and that's the foundations how event-driven programming comes into play. So this will also come in handy later on, and I'll when I get to the analytics part of what they're trying to do. So we'll wait on that. So if we move to the next slide here, Kirill, to recap the architecture, Datum uses services that are all serverless. So everything that the Datum team or the developers have used is all serverless, essentially, which is the foundation of how microservices architectures get built. And they all have limited horizontal scaling. So Cosmos DB functions and others. They use GraphQL Apollo module for Azure Functions as their API layer, use durable functions for orchestration. Remember when I said keeping track of where the driver is and all those events that, feedback from the driver, etc. All that's using durable functions. They use Azure Cosmos DB to be prepared for any amount of traffic. Now, Cosmos DB offers serverless mode, which means a data will not pay anything when the application is idle, which is great. And Cosmos DB also happens to be the only database across all the hyperscale clouds, by the way, on this planet that doesn't just guarantee you a financially backed SLA on availability, but it guarantees you a financially backed SLAs on throughput and latency as well. So upwards of 99% of all your queries will complete in 10 milliseconds. Like pretty much, if you look at Microsoft Teams, Xbox Live, Azure Portal itself, I mean, all of Microsoft's critical services, run on Cosmos DB, which is really why it was designed to sort of, support that scale. So Anything also uses real-time messaging services like Event Hub and Signal R to bring those real-time experiences into their app powered by Cosmos DB change feed. So the change feed inside Cosmos DB is very, very critical. If you haven't checked it out, please do, because it's really going to be amazing for you as you're thinking about building out these event-driven architectures. And finally, we believe developers are best when they can focus on code, right? Their business logic, whatever you're trying to get out of the app, not managing infrastructure, like you said. This is often best achieved by taking advantage of cloud-based services. So if you only use VMs, well, you have to manage infrastructure, right? So when you use a database like Cosmos DB as an example, which is a managed service, high availability, disaster recovery, performance best practices, security best practices are all handled for you, right? Essentially, you're guided through. So all those things are taken care of from an infrastructure management standpoint. Scaling is taken care of for you. And all you do is focus on the business logic of your application. And when, often you want to plan for horizontally scaling architecture that can react to growing demands at growing different speeds, is really where this impact lands up being a lot more. So using services like Azure Cosmos DB, Azure Functions, Event Hubs are perfect in these scenarios, because you want to scale reliably, you want to scale horizontally as your workload grows without having to manage infrastructure. We also want things to just work, right? Like as developers, you don't want to worry about, hey, the uptime and this and that. Like so using services that have built-in integration can save time to figure out how to glue and stitch these pieces together, right? So we've already made integration between functions and Cosmos DB through our change feed architecture extremely reliable. So you basically can just use that capability without having to worry about, hey, will this work? Are these things going to be reliable or not? And so these principles and architecture patterns aren't just advice that I'm sort of presenting here, right? This is literally, we bet our business on it. So Microsoft itself uses these patterns, and thanks to these services, Microsoft Teams is an example, which is our flagship service for communicated, sharing, having teams, meeting people, etc. Was able to scale to more than 7 trillion transactions per day, believe it or not, 7 trillion transactions per day with their multiple petabyte scale database on Cosmos DB, right? So all of Microsoft Teams runs on Cosmos DB to meet the demand of the business growing at digital space. So if we move to the next slide, Kirill, you see the usage of Cosmos DB, right? I mean, it's actually pretty phenomenal to see in the pandemic, since so many of us basically started working remotely, the usage of tools like Microsoft Teams significantly grew. I mean, just overnight, we went, the scale grew several tens of X, right? And it was pretty amazing to see. Our biggest challenge, frankly, was to ensure that we have enough capacity that we are able to provision. But Microsoft Cosmos DB was able to scale with no problems to support that growth. It's pretty phenomenal. All right, next, if we move to the next slide, Carol, plenty of startups, so it's not just Microsoft, have also leveraged these patterns with Azure and Azure Cosmos DB. For example, in Mobi, which many of you may be familiar with, it's a leading mobile advertising space, uses Cosmos DB for their customer data platform, handling more than 1 million transactions per second. Now, Tanla uses Cosmos DB to serve OTP communications, handling millions of messages per second. So these are just a few examples of very successful cases. Like I said, Walmart, Coca-Cola, several others are using Cosmos DB for their success. Now, finally, let's take a look into the future of our startup that is Embed. They successfully launched in Mumbai. It turns out everything went smooth in December and they've hit success. So they basically are on this hockey stick growth right now. Now, while their app has handled the dynamic scale of the traffic well, they did find a business problem. They found that they struggle with always having enough drivers, and sometimes users start to complain about wait times. Hey, I requested a cab and it's been too long, sometimes hours, and that's creating a lot of dissatisfaction. So since their launch, they added a data scientist to their dev team, and they have some ideas on ways to identify the problems. The team starts to explore using search pricing to tackle the problem. Can they ask some customers to pay more if they want the guaranteed SLA? Now, one of the easiest ways to process a lot of data in Azure for analytics is using this service called Azure Synapse. It's a flagship service for doing real-time analytics at really, really high scale and concurrency. And the most amazing part is using this capability called Synapse Link. They can connect their production Azure Cosmos DB to Synapse in no time with just a single click. Now, one amazing thing about Synapse Link for Cosmos DB is you can use it to provide real-time analytical insights into your operational data with no impact on your production. So your operational database sees no impact on their performance. So you can safely run real-time analytic queries. And what we guarantee is that within 30 seconds of your transaction committing in Cosmos DB, we'll make it available in a columnar format to Synapse, so you can do your analytics in them. So you don't have to worry about ETL and other headaches that come with sort of maintaining that infrastructure. Synapse just does all of that for you. With the next slide, please. With Azure Synapse Link for Cosmos DB, now you're able to extract insights from the production Cosmos DB database in real time. And they can also leverage Power BI, which is the industry-leading BI platform, to visualize places with their biggest pain, which places have the most traffic when it comes to people questioning. They can start by manually adjusting search prices, right? So they can say, hey, look, this place in Mumbai, as an example, suddenly has a lot of people, your customers, and can we ask them to pay a little bit more to get a guaranteed SLA? They start by manually adjusting it, which visibly helps improve rider performance. But as they add more cities, they can't do this manually, right? Like they have to scale. Fortunately, their new talented data scientists develops a model which can run in Synapse, their analytics platform, using Apache Spark interface to recommend what pricing model to use in which area, right? So imagine, based on the area, based on the traffic, your machine learning model is built in Spark, in Synapse, is able to basically create that thing in real time. Now combine that with the low latency from Cosmos DB's analytical store. They can react in near real time to surges in demand, like a cricket match finishing up and everybody wants to go home. So everyone's sort of calling, using their app and calling, cabs. They can basically handle that through search pricing, determine these events as they happen in real time through the model that they've built out. So, the combination of Azure Functions, Cosmos DB, Synapse Link from Cosmos DB, Synapse effectively has given them this amazing, application with backend analytics and machine learning models in Spark to adjust in real time, to handle their business. Now, users can sometimes opt in for a search price and pay more for a faster pickup. That's key. So it basically helps drivers. Basically in situations like these, the customers are happy because they get guaranteed SLAs, and they're able to sort of create this marketplace or be a broker with the application. With this, now riders can see a slightly higher price, but get picked up faster. This also helps bring in more drivers into the overall pool, keeping pickup times down for everyone. Now, thanks to their hard work, the ability to extract key insights from their data, Adatum goes on to be a huge success and launch in almost cities around the world. Now, as we just saw, Azure Synapse acts as an analytical hub to extract and visualize, and then put them in action to improve outcomes for your users. For us developers, we saved a ton of time and effort by having turnkey integration of our database and not having to worry in setting up these complex ETL pipelines or having a negative impact on the performance of our operations store. All that's taken care of by Synapse Link. Now, with low latency, you don't have to worry about the extra overhead of creating separate warm and cold paths, right? You can also leverage our favorite tools and empower our data scientists with Apache Spark, SQL, and other tools just in one spot, scaling serverlessly. Now, this also plugs in very well with services like logic applications. So imagine, based on some analytics and insights that you got out of Synapse from the data that came from Cosmos DB using Synapse Link, you want to take some action. You can use that to logic apps, or you can use that to Power Automate if you want to use the low-code environment. All these things are integrated very well. And the advantage with this, with Logic Apps and Power Automate deeply integrated with the insights that are coming out, is you can have automation of your workflow. So there's no manual human that's actually taking the action. All your workflows are triggered automatically in your apps, in your business applications to react to these insights. And finally, we're able to make better decisions when you visualize your data using like an excellent platform like Power BI to help your whole team understand what the application and the users are doing. Now, with that, while the company we discussed today isn't real, of course, but the journey that they followed very much is. This is really how startups start and grow and scale. Thousands of teams are building on these patterns. Like I said, Microsoft itself has built on these patterns and are accelerating the future of their businesses. Developers are a driving force in this change. Like I mentioned, in this digital transformation that we're going through, you as developers are the key foundation of the changing force. And our Microsoft Cloud, Azure, and others tools are here to help you build faster and the right tools for your job. Using cloud native services, developers are building more sophisticated applications in faster times with lower overhead. For development maintenance, meaning developers can deliver more innovation than ever before. And data is the lifeblood of applications today, right? The easier you can unlock insights and improve your experience in near real time as you get data, the more users you'll help and the greater impact you'll achieve. This change may be the most transformative change we see in app development teams, where app development and data science are not silos anymore. Your app developers and your data science are just one team. And Synapse Link, which ties Cosmos DB to Synapse, is the key ingredient that breaks down the silos. If you and your team are looking to build the next application, we hope to build it on Azure. We have fantastic capabilities like I described. We're here for you with whatever you need, and we truly believe your success is our success. To get started, you can visit the link that I shared here to get started for free. We hope you enjoyed learning a little bit about what Microsoft offers for developers, and I really enjoyed spending this time with you, and I hope you basically take this opportunity to learn a little bit more about the various capabilities that I spoke about. And as a closing note, I want to thank our hosts in a phenomenal job creating this community and setting this event up. We hope to continue to tune into the event throughout the day and learn from the experts from all over the world virtually. We encourage you to participate in the free Azure certification drives and the hackathon that's organized. And I'm told you'll have an awesome chance. You may have a chance to make some really awesome giveaways. And thank you for the time. And I believe we are maybe at time, but I'm happy to take a couple of questions.
Yeah, thanks a lot, Rohan. Thanks for excellent speech. And Rohan, we have only one question. We have 4 minutes. I just wanted to utilize. Can we hear some words about NoSQL versus Azure Cosmos DB? It's from one of the audience.
Yeah.
Yeah.
No, I mean, and Kirill over here, I mean, is a leader who actually built Cosmos DB and leads it. So let me start, Kirill, and please feel free to chime in if you have any. So Cosmos DB obviously started off as a NoSQL store, right? If you look at foundationally, we built it to have guaranteed, it's a scaled out architecture, right? And it's globally distributed. So effectively, which means your single database can span multiple Azure regions inside the world, and we guarantee that the data is replicated in near real time, right? So you make a change somewhere, and the other big part is the way the database is architected is your data gets partitioned, and in ways where we are able to guarantee that on every node on which a query gets executed, a certain amount of resources are given to ensure that your query completes in a certain amount of time. Now, our ambitions with Cosmos DB, of course, are a lot more, right? So we support Mongo today, we support Cassandra, we support our variant of SQL, we support Graph. But just given the success we've seen and the value, when you think about this new SQL moment where there is a marriage between what used to be relational databases and what used to be NoSQL is coming together, Our approach is to essentially take Cosmos DB in that direction, right? So this is a little bit more of a vision and a roadmap statement. It's fantastic what we already have, but you'll see us greatly advance that in that direction.
Thank you,
Okay.
Rohan. Yeah, absolutely. I think the basic Cosmos DB is your fast distributed database, and we will offer the APIs no matter which API you prefer and love. You will have it as applications, as we saw in this example. Applications are betting on scale out architecture, and Cosmos DB is there to help you, so that you don't have to build it yourself and charge yourself.
Okay. Thanks a lot, Rohan. Thanks, Krill. And I request audience to please fill the feedback form. It's a gentle reminder I'll be giving at the end of every session. Please bear with me. Thank you. Thanks, Rohan.
Hey, thank you, Satish. Thank you, Carol. Thank you, Lani.
Thank you.
Thanks, Krill. Thanks, Lenny. Yeah. So let me welcome Munaver for the next session. So, Munawar Hafiz is going to talk about on the wasted DevOps cycles caused by the false positive bug reports for the next 60 minutes. And the interesting question Munawar is, will be keep on asking himself is, why do bug detection tools stop at detection? What if there were services that not only detect the bugs, but also fix the code automatically? So the question itself, it was very interesting, and I hope we'll be enjoying that. So Munawar?
So can you, hi, can you see my screen?
Not yet. We were able to see your picture, but not actually. Yep, now it is.
Okay,
Now I moved it.
okay, sure. So hi, I'm Munawar Hafiz. I'm the founder and CEO of a Bay Area startup called Open Refactory. I will make a seamless transition, almost too seamless transition from the previous talk, which was an excellent talk by Rohan, to my talk. And so, in his final on his final slide, he was talking about developer velocity, and all software development teams, we want to operate with high release velocity, but there are these problems that come in our way, bugs for that matter, which impede our velocity, prevents our software from achieving high quality, and therefore we are sometimes forced to release the software without even like reaching the quality goals that we initially intended ourselves to be. So in my talk, I'll be talking about bugs in general. Why are we still spending 80% of our time as developers chasing bugs? Why aren't there tools there that are helping us? So I will look into the fundamental problems that actually prevent the tools from helping us, and also look into what can be done like specifically in order to improve these particular scenarios. So software developers are human beings. Even the best of us make uh, mistakes when we write code, and the rate at which bugs are created outpaces the rate at which they can be fixed, because right now the bugs are fixed. All the bugs that are fixed, they are fixed manually. So the bugs that are detected, we use various kind of bug detection tools, we use testing tools, etc. uh, Even after this, all the bugs that are detected, about half of them, they remain unfixed for over a year, and each one of them on average takes about 90 days to close, from the time that they were reported to the time that they were closed. And as such, every 1000 lines of released code, and I repeat, released code, contains 15 bugs on average. And when an attacker is able to exploit one of those, on average it costs about $4 million. And actually, you'd be happy if one of these bugs are exposed and you get by at just spending $4 million. At that point, $4 million is not a lot, because bugs like, for example, the heartbleed bug, it cost the industry about over $1 billion. So bugs can be as detrimental as that. And what was interesting is, specifically in that case of the heartbleed bug, the actual bug was introduced in the code in 2012. Heartbleed bug was detected in 2014. So the problem was there in the source code for about 2 years. And there were a lot of testing, I'm sure, that has been done. This is OpenSSL. I'm talking about very, very highly visible software, a very vibrant community that is developing it. And probably there were a lot of like bug detection tools, etc., that were also used in order to find those bugs. But the bugs were not detected in time, in 2 years, 2 years of time. And then eventually, when it was detected, the mitigation cost over $1 billion. So that's our life. We want to operate with high release velocity. We want to build a world of software we can trust, but that's not what the reality is. So I will focus on how we address bugs in source code, and my talk will be specifically focusing on static analysis tools. So this is different from testing, which we are all familiar with. Basically, when we are writing tests, we know about a behavior, we codify that behavior, and if our code fails to demonstrate that same behavior, the test fails, and we fix that behavior, we move on. The critical thing is we have to get a grip on what is that behavior that we intend to be. So we have to somehow codify that behavior. We have to create an oracle that defines what is right, and then then the testing just identifies whether your software is doing the right thing or not. But in the case of bug detection tools, when you're using these bug detection tools, it looks into unknown things. So things that you may not know exist in your software, the things that could be buggy, and therefore these tools are highly valuable because they would be able to find these things. There are two important classes of these bug detection tools. There's the static analysis tools, and also there's the dynamic analysis tools. The static analysis tools, they do not execute the underlying program. What they do is they create a mathematical model of the underlying software and try to identify the bugs from there. The dynamic analysis, on the other hand, executes the program, monitors certain behavior, and when it identifies a deviation from the normal behavior, then it flags a bug. The advantage of static analysis tools is it finds more bugs. So because it creates a model of all possible paths in the code, it reasons about all the paths that can be taken in a program, or it tries to reason as much as possible, and makes a best case of bugs that can appear in some path that was not necessarily intended in runtime normally, or that is not shown in runtime in normal times. However, the problem with the static analysis tools is the false positives. As it is creating a mathematical model, the mathematical model quickly becomes imprecise. And at that imprecision, when that imprecision is coming in, the bugs that are detected, many of them could be actually a false warning. It is not a bug. The dynamic analysis tools have the advantage that they do not have any false positive. Whatever they have detected is an actual deviation from normal. But then it is also similar to the testing, that the code has to follow that path. So somehow you have to be serendipitous that your code path has followed into some erroneous path, and at that time the dynamic analysis tool identifies that deviation. So if your code, for some reason, you give it some input which is not exercising that particular path, then you will not be able to detect those bugs. So the dynamic analysis tools, they will have zero false positive, but on the other hand, they may miss a lot of bugs. So my talk will be focusing on static analysis tools, on which I've been working on over 15 years, and in the academia, in the industry, and now as the leader of a startup, in identifying basically what are the problems that the static analysis tools have, and that I will try to characterize, and at the end of this talk you will be also have an idea of why these static analysis tools have a lot of false warnings, and how can those aspects be improved. So first of all, as we mentioned, the main problem of static analysis tools are false positive. And believe it or not, the typical static analysis tools that are out there, the state of the art ones, the best out there, they operate between 50 to 90% false positives. 10 bugs that they identify, 9 of them could be a false warning. So developers have to waste a lot of time. That's the waste that happens in the DevOps cycle. Developers have to waste a lot of time in order to triage the bugs in the first place, the reported bugs in the first place. It's almost like you are cleaning after the mistakes that the tool has made. The tool was there supposed to be helping you, but instead it is spewing a lot of garbage, and you are cleaning after the tool in order to first determine which bugs to fix in the first place. And then you have to go and manually fix the bugs. The existing static analysis tools also miss critical bugs. As I mentioned, in the case of Heartbleed problem, the buffer underrun problem, which was there for Heartbleed, it was undetected for over 2 years before some hacker detected it and created an exploit, and all hell break loose. Then the third problem is, even after all the bugs are detected, the fixing remains a manual process. So when the fixing remains a manual process, there are two problems that can also happen. Number one is, the developer who introduced the problem or the bug in the first place may well be the one who is entrusted the duty of fixing that problem, and he may not be well versed of what caused the problem in the first place. So he may make the same mistakes or similar mistakes as he is fixing the bug. Or, which is something that is more common, is when you are making changes in the code, oftentimes if you're making a hasty surgery, if you don't have a proper context, or if you don't understand the bug to start with in the first place, you may end up making new mistakes. So it is also very, very common in the industry that the same bug that was fixed or claimed to be fixed actually is not fixed in one time. Then you basically create one patch, and then that creates another problem. You create another patch, and it takes 2 or 3 times before you make it right. And all of these times, there are no tools that are available that can help you out to actually automatically automatically fix these problems. And that's one of the other problems that we're coming in. So as such, we feel in this precarious situation as if we are in a race, a losing race for that matter, a losing race against bugs. And we are creating bugs at a faster pace than we can fix them. And as such, like all of these bugs, they are causing missing deadlines, they're causing budget overruns, they're recurring security breaches. But most often than not, it creates a lot of burden on the developers, which we don't intend to be. I mean, we're talking about AI and this or that, but the simplest case that the developers would want, that when they're writing code, how can they write code more efficiently? How can the teams operate with high release velocity? These problems are not solved yet to a proper satisfactory level. So I'll give you an example of how the existing bug detection tools fare against real problems. So assuming you're a developer, and I choose a very popular tool or popular application in order to demonstrate as a test subject. So we use Jenkins, very well known automation server. Everybody is familiar with that. It is written in Java, about 320,000 lines of code. So we applied a very well-known bug detection tool, a static analysis bug detection tool. I will not name it. I will call it Tool 1. And this was applied on Jenkins, on a latest version of Jenkins, to identify bugs in the code. And it identified 10,000 problems in 300,000 lines of code. And Jenkins is a fairly mature software. Clearly, you believe that it cannot have 10,000 problems in it. But as the tool detected 10,000 problems, if you look carefully in that, if you manually triage them, you'll identify that over 95% of them are false positive. So what would you do with it? You're a developer, you'd suddenly get 10,000 bugs, and you know that 9,500 of them are false positives. I mean, wouldn't you be very annoyed with the tool? This is just what our life is. So the bug detection tools, they tell you that, okay, yeah, we will detect all sorts of bugs for you, but you should tune the tool so that you are only looking into the major bugs. Okay, so let's tune the tool. And when we tune the tool to only detect major bugs, still it identified about 4,300 problems in Jenkins. This time still about 90% false positive rate. And that's the fundamental issue, that you see this software, they will give you a deluge of bug reports, and you will have to spend a lot of time triaging the problems in the first place. So this is what the DevSecOps engineers endure, that about 15 to 40% of developers' time is wasted because of chasing these bugs. And there are quality fights that will happen before release, slowing things down. That you will be that the quality team is saying that why wasn't this bug fixed, and the developers team are arguing about whether this is a bug or not, and these fights happen dramatically late in the release cycle, which is delaying the case of the whole velocity, or the desirable velocity that all of us want to operate with. And as such, what many development teams do is, they also, because the tools also miss bugs, and they also produce a lot of false positive, sometimes developers use, or the teams use multiple tools, and they kind of try to they hope that one of the tools will kind of back each other, so together they will find the bugs that one of the tools may have missed if we're using only one of the tools. And together, by triaging them and only concentrating on the common bugs, we will probably be able to reduce the false positives. But in reality, what happens is, the Venn diagrams of the bugs that are detected by the tools not necessarily overlap very neatly. So you'll now see even more bugs thrown at you, and even more false positive. And I know that I'm printing a pretty gory picture, but if you look back at what you do in your daily life and everything, it is not necessarily very different from what I'm talking about. So when the VPs and the CISOs, the high level people in the company, they worry about the cost. And in this case, like for a team of 500 engineers, about 500 man months could be saved if the tools were more efficient than that, and if the false positive rate was reduced, if somehow we could operate from, let's say, 90% false positive to orders of magnitude lower than that. And that could cause an annual savings for a 500 engineer team between $1 to $3 million, based on where you're located, and so on. But the more critical problem is, what if a critical bug is missed? The tools, if they're not identifying the bugs for you, then that creates a fundamental problem, because your software is then in harm's way, and could have problems. So in my talk, what I will be focusing on is this detection challenge. Why are the static analysis tools, they operate with this high amount of false positive? And I will identify three particular problems. I call them the road not taken, the hidden paths, and the polyglot world. I'll get to those. And then I will also talk about what can be done in future, where lies the future. And basically, we are asking a simple question: what if there were services that not only detected vulnerabilities, but also fixed them automatically? And we will discuss about how we can leverage upon existing code rewriting technologies like refactoring, and go beyond the behavior preservation uh, idea that the refactoring tools are based upon, and build tools that can fix problems in software. So let's look into the detection challenges. The first problem is, as I mentioned, that the static analysis tools, they look into the possible paths that can be taken in a program. They create a mathematical model out of that, and from that mathematical model, it tries to reason whether a certain phenomena is going to occur or not. And so in some cases, this is not necessarily very difficult. So here is a very simple Java program where we have a method invocation j.bar, and we want to identify whether this j.bar is safe, as in whether there is an opportunity for a null pointer dereference here. And so the variable j was initialized here, but and what is interesting here is that the the condition under which it is initialized and the condition under which it is used, they are the same. So we can be guaranteed, if we analyze the path, that by the time j.bar is invoked, j is already initialized, and therefore we won't have a problem. Now, what if, and as such, the tools are very much able to do that. Now, let's look into a slightly different scenario where we initialize the variable j, and then we invoke it in under a different circumstances. In this case, we can also look into the code and pretty easily reason that in this case this is unsafe and it will cause a null pointer dereference. And the reasoning is that the condition under which the variable was initialized, it is complementary to the condition under which the method is invoked. So therefore the variable remains uninitialized, it is null, and therefore a null pointer dereference would occur. It is pretty straightforward to just have a look at the program, and the tools can also be able to identify this kind of, or do this kind of reasoning. So there are very few, I mean, if a tool is even missing that, then that's really a bad one. But majority of the tools actually fare pretty well, and is able to identify this problem. Now let's look into a slightly different problem. Again, the same issue of whether j.bar, the invocation there, is safe or not. And in this case, it is still safe because the condition under which j was initialized, it is and the condition under which j was invoked, that condition is stricter than the condition under which it is initialized. So by the time j.bar is invoked, we are guaranteed that j has already been initialized before. So therefore this will be safe and there would be no null pointer dereference. But many of the tools that are out there, they stop doing this kind of reasoning, because doing this kind of mathematical reasoning becomes hard and intractable to do soon, and therefore many of the tools punt on that. And that causes, this is one of the leading causes of why these tools operate with a high rate of false positive, because after a while in the program it just gets complicated and the tools just say that, well, I'm not gonna keep track of or create a more precise or attempt to create a more precise mathematical model anymore. So they start estimating at that particular point, and that's where the false positives creep in. So let's look into a problem that is actually hard and perhaps is not solvable by any of the tools out there. So in the previous example, some of the tools or majority of the tools actually not do that particular computation to identify whether that was a safe case or not. But in this particular case, many of the tools would not be able to do anything, because we are inside a loop and we don't know like how many times the loop gets executed, and then there is also a condition inside that. So by the time j.bar is invoked, we are just not sure whether j was initialized or not in the first place. And this is basically fundamentally where the challenge of the static analysis comes in. There is a challenge in static analysis. We will end up having some false positive, because beyond something or beyond some limit, we won't be able to detect the problems in the first place, or create a mathematical model in the first place. But at least we should try to attempt and try to create as better or as precise a mathematical model as possible. And many of the existing tools actually even fail to do that. And that's why they operate with 50 to 90% false positive. So I will go into a second problem, which is about hidden paths in code. So as we have understood from the previous demonstration, that paths or modeling the paths is very important. But it is important that the paths are also evident in sometimes, or in a lot of times that we actually write code now, because we are using libraries and frameworks and we're using microservices and so on. The paths are hidden from us. The framework handles certain kinds of or the framework contains certain kind of logic that is then imposed upon the code, and the code is stitched in a certain way. So if you look into Java, there are over 100 even popular frameworks, over 100 popular frameworks. In total, it has several hundred, or even in the range of thousands, perhaps, frameworks that are even widely used. So we are not even getting into the long tail of the car. And I've worked in one of the like top bug detection tool companies, and I've led companies there. In those places, what we did was we tried to encode some of the frameworks and try to hard code that, and teach our tool to learn about it, and it quickly becomes intractable. Like, you can do it for one and two, but you cannot do it for 100 or 200 or 500 frameworks. It just becomes intractable after a certain point. So let me give you some idea of what do I mean by these hidden paths in code. So again, we look into a very simple example. This is actually the very well-known thread library, and we have again a very simple program a class that is implementing the runnable class. So it's a thread. It is implementing a thread, and we are asking the question whether this method invocation global.s.length, where s is a global variable, whether this is safe or not. And it will be safe if s has been initialized in some path before. And if we look into the overall picture of the code, the global.s, that was initialized in the method foo above in a different class, and then that class was invoking a thread. But what is happening is that the thread is invoked as demo.start, but when we are calling the start method or invoking the start method, the run method actually gets executed, and the underlying library actually handles that for you. It is very well known. We are all aware of that. But this is a hidden information for a tool. Somehow the tool needs to know that demo.start is actually the same as the run method, and at that particular point, we can safely determine that global.s.length does not have a null pointer dereference, and it is safe. If we are not able to give that information to the static analysis tool, and we create an aggressive tool, then in the absence of that information, the tool may report that this is a potential null pointer dereference, and that will be a false positive again, as I was mentioning. So let me give you a slightly more complicated example, this time from the Android application. So again, this is written in Java. And here we have the Android like on restart method from the Android lifecycle, where we have a password text variable that was initialized from an input from the user. So this variable is tainted, and that or could be tainted because a user or an attacker can pass or intend to pass some bad data there, and that password text is then flowing, or the taint is then flowing into the variable pwd. Then that variable pwd is being used to initialize this object user, and so on. So that happens in the on restart method, which is a part of the Android's activity lifecycle. Now we have another method in that same class, same leakage app class, where we have this send message method, and there we are using the user object. The question is whether the user objects get password, or the password field in the user object, whether it has been tainted or not. And without the absence of information of flow that is happening or actually controlled by the framework, we are unable to determine whether the user.getPassword is tainted or not. So that information is hidden in the Android's lifecycle. So this is the Android's activity lifecycle. And you look into the activity lifecycle, you'll see that the on restart method runs in an outer loop, and then the send message runs after, or may run after that. So when the on restart method is run, at that particular point, the user object was created, and therefore when the send message was run and we are calling this user.getPassword, that password could be tainted. And when that information is available for a static analysis tool, we can now determine that the password pwd variable is tainted, and that taint passes to pwd text, which passes to temp, which passes to message, and eventually that message is used and that message is sent in plain text in one of the methods that we have written, where we are sending a text message, and because we are passing that plain text, basically we are sending our text, sending our password as a in plain text as a text message, and that is a problem. And without the information of the hidden flow that is there in the Android application, we are not able to identify that particular problem. So let's look into a third aspect of this particular issue, which is about the code being polyglot. 95% of projects that we work on, now, they operate on more than one language. And therefore, one language is interacting with another. This has been very, very common now. And there are several ways that languages interact. And therefore, the analysis tools, they cannot just like rely upon looking into one particular programming language only. They have to combine the data from analyzing multiple programming languages and be able to stitch them in order to get a better result. So there are various ways of interacting between multiple languages, and I'll give you some examples. There is so one standard way of doing this thing is execution, where one high-level language calls a method of another high-level language. So here is an example of code. Actually, this is code from Open Refactory, where we are using a SAT solver, and we are running the SAT solver as a C++, or implementing that in C++ code, but our product is written in Java. So when we are calling the C++ routine, we are using JNI in order to do that, and the JNI environment needs to stitch the information together. So somehow, if we want to do analysis across these two programming languages, we have to provide information, how the information is flowing from the language boundary, going from one to another. There are other ways of doing multiple language code. So, and oftentimes the two languages that are being communicating, one of them is typically a high level language, the other one is typically a low level language. So in the case of execution, both of them were high level languages. One was Java, the other one was C++. But in traditional cases, when things are being when things are being introduced, when multiple languages interact, typically one of them is a high level language, the others are low level languages. So in this case, this is the same Android application example. Here, when we are calling this r.id.username, that is actually coming from some specification that is written elsewhere, and from that specification we know like that this is referring to a particular input box, and that input is coming in from there. So this is an information that is also like coming from us, from interaction between two different languages, and this is typically known as data loading in the polyglot world. There are other ways when we, for example, something called shared ID. So remember, in the case of Android activity lifecycle, we mentioned that the send message is occurring in response to, let's say, some event, and the fact that send message would be executed in response to some event, that is encoded in some file. It could be a JSON file, it could be an XML file, and so on. And so in that case, the ID that is used in that JSON or XML, that ID is the shared ID between the actual method name that is being used in the Java code, and that is another way of interacting between multiple code. And all of these cases, these have to be encoded in some way in order for us to be able to identify and be able to detect the problems in a proper manner. Let's look into another way. This is about aspect-oriented programming in Spring or Spring Boot framework. So here we are basically describing a before advice in an XML file, which is saying that in the method do access check, in the method data access operation, before that method is executed, the do access check is going to be executed, and so this is encoded in XML, and the tool needs to, so the program stitches it, or the framework stitches it perfectly, but when a tool is analyzing a Spring application, it needs to be able to identify these these hidden data flow and be able to look into that. So what I have done is I have established that particular idea, that the critical issue of the success of a static analysis tool lies behind modeling the paths that can be taken in the code. And oftentimes, because of those paths being complicated, creates a problem. And because we are using a lot of framework, we are in our framework or libraries in our code, without the absence of the hidden data flow or information that is available, or that is available when and especially when multiple languages are interacting, there are these kind of hidden data flow that are also encoded in the frameworks. Because of this, uh, the existing static analysis tools would operate with a high amount of false positive. So now I'll switch gears and I will cover the second aspect of what if there were tools that not only detected security problems, security, reliability, compliance problems, but also fix them automatically. And in order to do that, we will go beyond behavioral preservation of code. So we are all familiar with refactoring. Refactoring has started over like 30 years ago now, and now is mainstream and is used in most of the IDEs. Languages like advanced languages like Java, they have a whole lot of refactoring. So here we look into the Eclipse IDE, and there's plenty of refactoring opportunities, and we use them very often in order to structure our code. But all the refactorings, they're doing code rewriting based on behavior preservation. They do not change the behavior. The before and the after code remains the same. And the question, and as such, what the refactorings attempt to do is they make code simpler and more maintainable. But what we want to do is we want to make surgery in the code so that we modify the code so that the problem that was there in the code before is gone, but the good path behavior of the code remains unchanged. And that is the challenge that Open Refactory or my company Open Refactory is trying to solve. And so our flagship product is called Intelligent Code Repair, or ICR. ICR combines deep static analysis, machine learning, and code refactoring technology to bring in this feature where we dramatically reduce the number of false positive when we detect bugs, and we also introduce the capability of fixing a majority of the bugs that have been detected. So ICR contains a bunch of fixers, and think of ICR as, let's say, a band of Marvel or DC superheroes, and each of the fixer is a specific superhero with a specific superpower. And so let's say one of them is targeting null pointer dereference, another one is targeting an SQL injection, another one is targeting some compliance issues, and so on. So together they bring in the overall value and help us uh, uh, and create these fixes in the code that can be readily applied to the source code so that the security, reliability, compliance problems are gone. ICR is now available for Java, uh, Python, and C. ICR for Java is also available from the Azure Marketplace. So you can go to Azure Marketplace, you can search for Open Refactory, you can search for Intelligent Code Repair or ICR, and you'll be able to see that. This is available as a pay-as-you-go model. This is available as an infrastructure as a service. So Open Refactory has zero visibility on your code. The IP remains with the client. The machine that is configured, it is an infrastructure as a service. You own the machine. The machine just comes pre-configured with ICR service, and the ICR service runs in the machine on your code residing in the machine. So if you already have your DevOps DevOps in the Azure Marketplace or some other cloud marketplace, this seems just like an inclusion of that. So the way the ICR works, when you lease a machine, is that you can now access to ICR through your web browser. So ICR has three key components, it has the navigator, which is basically the orchestrator that is, or the main, or the first thing that you see when you go into your web browser and go to and join that particular machine that you have leased. And then there is the analysis engine that does the grunt work. It does the detection and it prepares the fixing. And then there is a reviewer that is gonna give you a dashboard where you are able to look into the bugs. And so the idea is that you get ICR from the cloud provider. You link to your source code repository using Navigator. You just tell it like where your code is. It can be in GitHub, GitLab, or Bitbucket, or it could be even residing on the, or you can like put the code on the machine that you leased. It could be on the local machine, and then you are able to use the analysis engine. So at that point, you just hit the analysis engine, it just runs. You review and apply the fixes, and we are done. So this is the one of the dashboard. I'm just showing you some screenshots. Like this is gonna, so for example, it has, let's say, identified that it wants to look into one of your code repositories, let's say GitHub, and you have multiple projects on your GitHub repository, and you select the specific project, you select the specific branch under which you want to run your ICR on, and you just hit analyze. And at that point, the analysis engine kicks in, and it runs. You don't have to wait and watch pane dry by looking at it. You can just go ahead. Once the analysis is done, you'll get an email, and at that particular point, you can go to the reviewer where you will be able to see the fixes that has been generated, or the bugs that have been detected, and the fixes that have been generated. And you can filter the bugs based on like where you want the bugs, or you may be interested on a specific kind or a category of bugs, but then you'll be able to look into those. And you can also apply the fixes. And when you apply the fixes, what it does is it creates a new branch on your source code repository, and on that particular branch you can then create a pull request, and then you can do a code review and so on. You go ahead with your DevOps process, and you will be able to identify the problem, and fix the problem in the first place. So I will look into a few problems or few kinds of fixes that the ICR generates right now. So let's look into some easy stuff. So one of them is, and I'll give you examples from Java code. So one of them is limiting the field access. So in Java, you may accidentally declare a field as public and then access that from outside, but that is a reliability problem that becomes a compliance issue in many of the cases. It actually can become critical when you are accessing variable from outside. You may get into concurrency issues, race conditions, etc. So it is a problematic thing. So it is encoded in the CERT secure coding standard OBJ01 as a critical issue to be fixed. So in order to do that, you basically need to limit visibility of public fields. So here ICR is doing that kind of fix. So it is showing a diff where there was a variable that was declared as public and was probably accessed outside. So it creates it creates a private variable, and it also creates the getter and setter methods around it. And with those getter and setter methods, it is able to it replaces all the references to this method, to this field, with the appropriate getter and setter methods. Now, this looks like very simple or very innocuous, but it actually gets pretty complicated soon. This works fine if you have a field that is of immutable type. But if you have, for example, a collection or a container of some sort, then how do you create the getters and setters? How do you expose that variable? How do you access them? That creates a lot of problems. So even if we are talking about this simple surgery, on paper, this looks like a no-brainer. Actually implementing that is pretty difficult. And therefore, and that's why you don't see these kind of tools outside. I mean, even though this looks like a pretty innocuous, even a behavior preserving thing, kind of refactoring that you can think of, but you're not able to see these kind of changes because implementing these, there are a lot of difficulties there. Let's look into a slightly more complicated example. This one is about finding SQL injection problems in your source code. So in your source code, so SQL injection, we are all aware of that. And this is encoded by the CERT secure coding standard IDS 00. And the idea behind, or one of the ideas behind preventing the SQL statement is, I mean, you can, of course, you can do filtering uh, by filtering the tainted data that is coming from user. But there's always, like, you can filter something and the attacker can find a way to bypass that. You can filter that, the attacker finds that. So there's that cat and mouse game that happens between the attacker and the developer. So instead of doing that, a better way of doing that is to prevent SQL injection by construction. So using a prepare statement, again, that's pretty standard practice. But introducing that prepare statement in code could be a problematic thing. So here's an example of a very simple case where we have an SQL injection attack, or potential SQL injection attempt. So there is an SQL query that is formed by just concatenating query strings. And this query string is, so the input that is used, name, that is coming from user input, and therefore it can be tainted. And therefore, when the SQL statement is executed, there could be some bad things that can happen, which is SQL injection. So in order to prevent that, you would introduce a prepare statement. But in order to do the prepare statement, you need to parse the original query string and identify how to construct that prepare statement in the first place. So you're not generating a single line of code uh, or some structured piece of code. You're actually analyzing the data flow of the previous program and try to simulate that and generate a paragraph of code that would introduce the prepare statement for you. So this is a slightly more complicated example for doing this thing. And therefore, when you introduce the prepare statement at that point, it is secured by construction. So when you are executing the SQL statement, you would not be able to have the SQL injection attack that was otherwise possible. I'll look into another issue, which is about fixing null dereference. So this is very common. In fact, the most common problem in Java that the Java developers face is about null dereference. And so this fixes CWE 476, and also it encoded in the CERT secure coding standard EXP01. There are multiple strategies that can be there for preventing a null dereference. So the first problem is identifying null dereference problem without false positive. Then the key issue is, how do we fix it? And there could be many ways of doing that. We can initialize an object before that, is by forcefully doing that. But where do we initialize that? Do we initialize that at the time the object was declared, or at the time it was dereferenced? That remains a problem that needs to be identified before introducing such a fix. Another way is to do a skipping statement. So you can, a part where we have, let's say, j.foo, we were calling calling a method on the variable j. We can just guard it with if j not equal to null, and therefore we are guarding that particular statement, and we are never allowing a null pointer dereference to happen. But what is the consequence of just introducing that skip statement and therefore altering the path of the program? Is that a safe idea to do? So doing that is pretty hard. So we do that in some of the cases, but in a lot of the cases in ICR, we actually generate just a warning with the breadcrumbs that basically show you where the null pointer dereference is coming in, and this is and leave it on the developer to actually fix that problem. This is a conservative way of doing things, but it actually is the pragmatic way, because the fundamental limits of the static analysis tool, it may prevent you from actually being able to calculate what is the right way of fixing a bug in all cases in the first place. And if you try to be aggressive, then you're actually introducing false positive fixes. So now you're generating a fix that is going to break your code or create some other problems in the code, and that is also not necessarily very good, and it diminishes the reliability of the underlying fixing tool in the first place. So we remain very conservative. we detect, we provide fixes for the cases where we are able to generate them, but then for other cases we just generate warnings. So in practice, what is shown here is that right now ICR is, for all the bugs that ICR detects, for about 50% of the cases ICR is able to generate a fix. For the others, it provides detailed messages that identify how the bugs are occurring, and therefore the developer can still be fast tracked into fixing that particular problem. And remember, the bugs that are identified by ICR, this is done with very high precision. And I'm going to show you an example, a case study on that, right? Like in a few minutes. So finally, I'll talk about fixing data races. So fixing concurrency problems in code, and this is again very, very hard. There are many, many ways of doing that. So you can introduce a synchronized block in the part of the code where multiple threads could access that, or you can actually put a synchronized keyword around the entire method that contains that particular code block that you want to protect, or you may want to protect that at the call site, or you may introduce a volatile fix. What do you do? What is the ideal way of doing the uh, of of dealing with a race condition bug at a particular point, such that it is not introducing, it is first of all not introducing some deadlock or other cases, or failing to, or not failing to solve the problem in the other extreme. So this is pretty hard. And in the case of race conditions, we generate fixes in a small number of cases. I'll say 10 to 15% of the cases, but for majority of the cases we just generate a warning and then let the developer fix them. So let me show you that same example that we initially referred to about Jenkins. So on Jenkins, we identified bugs. So we applied tool one, and if you were there at the start of the talk, tool one identified about 4,300 problems. And tool one is, by the way, very popular. I would bet that of all the people who are listening here, about a third of you are probably using that in one way or another. So it is a very, very popular tool. So you should be seeing these kind of similar results in your projects as well. So when we applied ICR on that, we identified 222 problems in Jenkins, and ICR reported real bugs in 80% of the cases. We found 30 something false positives. And think of that particular phenomena. You are a developer, you now are seeing 222 bugs as opposed to 5,000 bugs. Even if you have 40, that's probably an afternoon's work to knock them off and or triage them, and then you're good. The bugs, what is also interesting is, even after a stable, relatively stable Jenkins code, and this was done on a relatively new version of Jenkins code, the latest version of Jenkins about 3 months ago, you are still seeing that there's about 200 something problems that are there in the first place. So, and it is not surprising. I mean, you have seen Jenkins crash because of null pointer here and there all the time. I don't think that is something that I'm pretty sure, like, people who are using Jenkins, they've encountered this kind of issues sometime in their life. I can bet on that. So when you are applying like ICR on Jenkins, you are now zoning into the actual bugs with a very little false positive, and ICR is also generating fixes for about half of them. So about 80-90 of them there's already fixed, and you just have to then verify the fix and run your test cases, etc., do your QA cycle, and move on. For the others, there will be detailed breadcrumbs for you to be able to find it. So that's what enables velocity. We have been talking about that the teams want to operate at high release velocity. The problem that comes to us or impedes our velocity is this false positive, the deluge of false positive that the existing bug detection tools give us, and ICR provides you a solution for that. I will give you a final case study on applying ICR and also that same tool one. This time we want to demonstrate the fact that the existing tools miss a lot of bugs which ICR doesn't do. So when ICR, so we applied both ICR and Tool One on the Summit benchmark. This is a benchmark that is created by the National Institute of Standard and Technology of the US, also done by the Department of Defense and the Department of Homeland Security. This includes thousands of programs in the thousands of programs, each of them small, and each of them demonstrating a nuance of different kinds of security problems, and very small variations in code, where one of them is a bug, but if you change the code in small way, it is not buggy anymore. So we picked 6 important bug categories, like various kind of injection attacks, like SQL injection, cross-site scripting, null pointer dereference, divide by zero, various kind of reliability attacks, etc., on this source code. And we wanted to identify how much, what does ICR and what does tool one do. First of all, the false positives remain there. In the 1.8 million lines of code on which we ran significant amount, now tool one was producing 140,000 warnings. Holy cow. You run this tool, you see 140,000 warnings. Good luck triaging them. So on the other hand, ICR, so you see here in the graph, you'll see that the gray part identifies the or denotes the other bugs reported, or the false positive in this case, and the blue ones are the ones detected by tool one, and the orange ones are the ones that are detected by ICR. And in the case of ICR, you'll see that the relative positioning between the orange and the gray is the orange dominates that particular bar, whereas in the case of tool one, there's a whole lot of false positive. And across the board, the data that is not shown here, but across the board on all 6 categories, ICR detected more true positive bugs in all of these cases. So if we are using, or if you are using tool one, you would be missing bugs that that tool one is not able to detect, and instead ICR was able to detect them. So addressing the 3 challenges that we identified at the top of the conversation, that there is a lot of false positive, there could be bugs that are missing, and then the bug fixing process is a manual process. ICR is addressing all 3 of these problems head on, and therefore it is allowing you to operate at high release velocity and build a world of software that your clients can all trust. So, and at this point, I'd be happy to take questions.
Hi, Munawar.
Yes.
Yeah, thanks a lot for the excellent session. I have a couple of questions,
Sure.
Munawar. So, is ICR not available for Shisha?
No, it's not available for C#. It's now available for Java, Python, and C. We will get to C#, but probably in 2020, like Q1 of 2023. So it's still some time away. It's not available for C#, unfortunately.
Okay. And one of the audience wants to know about more about the summary of bugs, debugging, and learn more about fixing bugs during debugging. Uh, any explanation about that, Munawar? I know it's a very generic one, but again,
Yes.
want to hear.
So I mean, it's a good question. I mean, so basically, when we are detecting bugs, we are creating this mathematical model of the underlying program, and if that mathematical model could be visualized, that could be helping in the case of debugging in the first place. So it can create flow paths or etc. that we are creating anyway. It is right now not being done this way because the computation is actually pretty intensive, because it takes a lot of time. So these are not done in real time. These are not available as a refactoring tool. These run like a, let's say, like a nightly build. So you run ICR as a nightly build. You integrate it with your Jenkins pipeline. You run it like a nightly build, and in the morning it will identify the bugs for you. Because detecting this thing in real times and also doing the whole lot of computations that remember all the other tools do not do is very, very hard. We cannot do it. So in future, what we are also looking into is basically doing incremental analysis, where we create a baseline at first, and then we just look into the code that has churned between the last time the analysis is run and only do the analysis. That makes the analysis run much faster. And maybe in such a scenario, this kind of information that we are already creating could be used as a debugging issue. But that's another startup. Maybe if I'm successful, or when I'm successful with Open Refactory, I'll probably be able to create another company into that. But that's an interesting question. I'd be happy to discuss more. If you reach me, I'd be happy to discuss more on this.
Yes, yes, Noah. Thanks a lot. Thanks a lot for your valuable time, Munawar, and it was very informative. And I hope the audience enjoyed it well. Thank you.
Thank you. Thanks. Bye.
Hi.
Hello.
Hi, Barry. So I have Barry with me, and I welcome Barry to answer $1 million question: what to use and when in Azure. That sounds very interesting, Barry. That will be, even personally, it's a very I'm looking forward. What are all the resources to use and when to use it? And so, audience, Barry, I would like to introduce Barry, who's a very known author, or in plural site. You can see many videos of Barry in plural site. So, Barry, the stage is yours.
Excellent. Thank you very much for having me, and it's fun to be able to do these things again. Sorry about it's a bit echoey here. I'm in a big room. Normally, I would be in more of a studio setting, but still, I'm sure you guys can hear me all right. So,
Yes.
like it's been said, my name is Barry. I won't bore you with my surname because it's Dutch. It's Luibrechts. It's very difficult to pronounce. And you can find me on Twitter at AzureBarry and azurebarry.com. And today we will be talking about answering the $1 million question: what to use when in Azure. Now, you can also find me on the Developer Weekly podcast. It actually ended, but you can still go to developerweeklypodcast.com and listen to all the 52 episodes that I did last year, which were very much fun to do. And also you can find me on Pluralsight. I have many, many courses, I think 27 now or something. And many of those are about Azure, like it was said. And one of those is Microsoft Azure for Developers, what to use when. And that's loosely what this talk actually is based on. Because in that course, I will go through lots of Azure categories, like what to use for running your applications, what to use for storing your data, and then explaining how to choose the best service for that scenario. So why this talk? Well, Azure is incredibly big. You guys know this when you use it. When you start looking at it, it is just huge. There are so many services, even if you compare it to, for instance, AWS or Google, they just have an incredibly massive amount of services. And sometimes it's overwhelming, and sometimes it's confusing because service A looks like service B. And did they actually create the same services, or is there overlap, and why would they do that? Well, most services are actually meant for specific scenarios. So they do create those things with a purpose in mind. Sometimes, things evolve and then services go away. But still, I try to make sense of all of these services, and let's try and help you do the same with this talk. So Azure is huge, not only in services, but also in where you can host your services. There are so many data centers and points of presence in the world where you can host your services and data in Azure. It's really incredible. Plus, they have their Microsoft Global Network as well, which is their own internet backbone with underwater sea cables as well, that they actually use to connect their data centers and route traffic from and to data centers, which makes it secure and fast. It's really a unique cloud in that sense. It's really doing good. I'm a fan. You can hear that already. So Microsoft Azure is huge. There are many, many services for all sorts of things, from platform as a service services like web apps, to logic apps, to data services, to monitoring things, to AI, to you name it, machine learning, container services. We'll go through a couple of categories in this talk. So we'll start by the category running your application in Azure and then storing your data in Azure. And then we'll have another category after that. And then we will have some time for questions. So if you have any questions, write them down, or we get to those in the end. So let's start by running your application in Azure. How do you choose the best service for that? So I try to start by asking some big picture questions about this topic. So for instance, how much control does my application need? How much control do I need over the service that's running my application? And then next, where do I need to run my app? Is that only in Azure, or is it also on premises, or maybe a bit of both? Or is it Azure Government, or you name it? What usage model do I need? So do I need this thing to be on all the time, or can it be off in the weekend, or what's that about? And then once I've answered these 3 big picture questions, then I can take a look at the specific functionality that I need, and then later on also the costs, of course, and uptime, things like that, which I won't discuss in this talk, because that stuff changes so much and is also very detailed. So let's start by how much control do I need? That's all about control and responsibility versus working on business value. So if you look at this on the left here, you see IaaS, infrastructure as a service. Services that fall into that category are things like virtual machines, but also containers. And with those, with let's say a virtual machine, you have a lot of control over that thing, because you can install your own operating system, you can tweak it, you can go down to the nuts, and then you can actually install whatever you want on that operating system. But that also comes with lots of responsibility, because that means that you are also responsible for making sure that the network, for instance, around that VM and the VM itself and all of its ports are secure, and also antivirus operating system and the configuration of the VM or container or server or whatever it is, you are responsible for that. So yes, you have control over that, but that also means that you need to do more work to keep it all secure and up and running. Now, if you go up the stack one bit, then you see platform as a service. And these are things like Azure App Services, web apps, and others. And here you have a bit less control, but you still have control over the server configuration, meaning that you still control what type of runtime it runs, like does it run .NET, or does it run something else, Java, for instance? Does it run 32 or 64 bits? And then obviously you have control over the application which you deploy in there, and then also the application configuration, which is things like the database strings and application settings. Another one up the stack there, a bit higher, you will see, I call it LaaS, so Logic as a Service, more commonly known as serverless. And there you have less control over the server, because it scales automatically for you. And so also you don't really get to, and why would you set things like 32 or 64-bit or the runtime itself? The platform all takes care of all of that for you, but you still have control, obviously, over the application that you then deploy into your serverless service, and also the application configuration. And then all the way up to working on business value, you have software as a service. And those are things like cognitive services that are just APIs that are already there, pre-made applications that you just use. You can only configure them a little bit. For instance, the pricing tier on the thing, but you just use those. So that's the least amount of control and responsibility as well, but that allows you to completely work on business value and don't bother at all with whatever the application is doing and up and running and security there. So that's the first question. How much control do I need? Do I need a lot of control? You're looking at infrastructure as a service. Do I need not so much control and also not so much responsibility? Then you're looking at services in the category of software as a service. And after a couple of slides, we will take a look at all the services in Azure that fall within these categories. So the next question would then be, where do I need my application to run? Is that in Azure, in the Azure public cloud, for instance, or in an Azure Stack device, which can be a bit hybrid? That can be like a box of compute that you take somewhere, that you put on a cruise ship, for instance. Or is that somewhere else completely, like on premises? You need your Azure service to run in Azure maybe, and also on premises or on your local development machine. or somewhere else, another cloud even, like AWS or Google. And then what usage model do I need? So this is a question of how will my application be used? Is that all the time? That can happen, when you have a website that's up and running, Amazon.com, for instance, so up and running all the time and is used all the time globally around the world. There's always somebody that's using that thing. In that case, you use the classic compute model, which is always on, and then you pay for that thing per month. For instance, an Azure App Services web app that you use in an app service plan that just runs all month. If that's not the case, if you just use your application occasionally, so sometimes only when it is used, like an API that you only use when it is called, then you would use a serverless compute model. And with a serverless compute model, like an Azure Function, for instance, you only run it when it's needed and you pay only when you use it. So you pay per execution. So when you have all of these questions, the big picture questions answered, then you can take a look at what functionality do I actually need. Now, this is an example of these big picture questions. So for instance, I trust Azure to scale for me, which is a question about control and responsibility. This is around, so I want a serverless service. My application needs to run in Azure and also on premises. So I need to think about something for that. And my app only needs to run once every hour. So not the classic model, but the serverless model would work for this one. All right, so this is a picture of all of the services in Azure that you can use to run your application in. Now, actually, this picture is not complete anymore because there is another one as well for running Java applications. And after next week, when that's Microsoft Ignite, I'm sure there's more that's there because Azure is always moving. And I try to update my Pluralsight course that this is in as well after every major Microsoft conference so that it's up to date again. We have on the left virtual machines and container services like container instances, Azure Kubernetes Service, web apps for containers. Those all are things on the infrastructure as a service side that you can have lots of control over. There's also Azure Batch, which you use to schedule jobs of a task, like for instance, to render a movie and then scale that task out over lots and lots of nodes of VMs or containers. There's Azure Service Fabric, which you can use to run microservices applications at scale or any other application really that you can do. Cloud Services, which is one of the oldest services in Azure that you can use to run web applications and APIs. There's Azure App Services Web Apps, Azure App Services Mobile Apps. Web apps you can use to run a web application, and mobile apps is used to run a backend for mobile applications in that can do things like offline sync and notifications. Then there's the all well-known Azure Functions, and there's also Azure Logic Apps, one of my favorite services that you can use to orchestrate a process with. Now, how do you sort through these? Well, first you could take a look at that first question, control and responsibility. Now, these services here all fall within the infrastructure as a service bucket. So VMs, obviously, and also container services, and also a little bit of Azure Service Fabric, because you can use it in two ways, really, Service Fabric. And the most complicated way enables you to have a lot of control over the services that you run in there, but also you have a lot of responsibility of how you do that there. And that means that you need to configure the underlying VMs and maintain them. Now, there's also platform as a service, of course. Obviously, these are the app services web app services mobile app, and also Azure Cloud Services, the older services, and also a little bit Azure Service Fabric, depending on how you use that. And then there is the Logic as a Service or the serverless services, and these are Azure Logic Apps and also Azure Functions. And I must say that Azure Batch actually can also run serverless there, where you can have it scale up its nodes to run a job and then scale back down when it is done. So this is then the first question. How much control and responsibility do you need? And that, yeah, there you go. So on the left, lots of control and responsibility. And on the right, you get to work on your business value a lot because the platform takes care of a lot for you, like Azure Functions, for instance. And then if you need to stay vendor agnostic, so if you want to run your applications anywhere, Then you take a look at these services. So VMs, because you can run a VM image also on your local machine where you virtualize it and just run it. Containers, obviously, you can run anywhere, including in any other cloud. Azure Batch uses containers and also VMs to run its jobs. So you can use those to run anywhere as well. Azure Service Fabric, the SDK of Azure Service Fabric, you can install that literally anywhere, including on your local machine. So also in other clouds, on premises and in a VM. And then there are Azure Functions and also Azure Logic apps, which you both can also run anywhere because you can use the Azure Functions runtime that runs anywhere. You can install that on your local machine, and you can use that also to run Azure Logic apps nowadays, which is pretty cool because that means that you can run functions and logic apps within a container, let's say, and then run it, I don't know, on a Raspberry Pi. So if you want to run services occasionally, so serverless, then you take a look at these services like we discussed earlier. So Azure Batch, also functions and logic apps. All right, let's compare now the functionality of these services. And because there are so many services, we'll start by the category of container options. So containers and VMs. So we have VMs, Azure Container Instances, Azure Kubernetes Service, Azure Web Apps for Containers, Azure Batch, and Azure Service Fabric, which incidentally also can run containers with its own container orchestrator. All right, let's take a look. So if you want to lift and shift your existing application to the cloud, then you'll take a look at virtual machines, because that's a very easy place to start, right? Usually when you have something running on premises, it's already running in a virtual machine. You could then virtualize that. You can take that image that it's running on and then just run it in the cloud. That's a good first step to get into the cloud, because then there, the virtual machine, you can make it highly available and secure and make the cloud take care of all that type of stuff and then move on from there. Now, if you have just simple applications that you run in a container without a container orchestrator, so in a single container, then or without a container, then you would use a virtual machine or also Azure Container Instances, because that runs a single container without an orchestrator, although you can use an orchestrator to use multiple Azure Container Instances. If you have more complex applications, which is more regular, usually it's more complex and you have multiple containers running multiple services, then you would use Azure Kubernetes Service, which is AKS with the Kubernetes orchestrator, or Azure Service Fabric, which has its own Azure own container orchestrator. If you want to run orchestrated microservices, then really Azure Service Fabric is the thing for that. It's marketed for that. It's also really, really designed for that with an actor model and all that type of stuff. Yes, you can do that also with Azure Kubernetes Service. That is true, but it still is extremely complex to do still nowadays. If you want to run your application anywhere, then also Service Fabric works for you. Yes, you can use containers and also the VM image to run it anywhere. But like I said, Azure Service Fabric SDK is the thing that you can install anywhere, including on your local machine. If you want to run a web app or on Windows or Linux with Azure App Services features, which are things like deployment slots and easy authentication authorization, and also integration with GitHub Actions, then you would use Azure App Services Web Apps for containers, which is a very specific scenario. And then if you have repetitive jobs, like for instance, the rendering of a huge computational thing, like the rendering of a movie file, and you want to do that quickly, then you can use Azure Batch to scale that job out over multiple nodes. All right. Now, where do you run background tasks in? You have several options there. You can run them in cloud services. You can run them in Azure App Services, Web Apps, Web Jobs, which is then like a sidecar service that you get with an app service. If you want to run an Azure function, you can use that as a background service, and also Azure Batch. Let's see. If you have a short running task, well, all of these services can run short running tasks. If you have a very long running task that might run for hours, actually all of these services can do that as well, including Azure Functions. You can make that also work to run very long running tasks. It just doesn't run in serverless mode then anymore, in consumption mode. you would then just run it on an actual app service plan and pay for it all month. But it is possible to run long-running tasks in Azure Functions. If you have very resource-intensive tasks, like for instance the rendering of a movie file, you would use Azure Batch. If you pay all month, then you would have these services that follow the classical model of cloud services and web jobs as well. They're not really serverless. They run then on a thing like an app service plan that you pay for all month. And in contrast, if you only pay for when you run, then you would use Azure Functions and also Azure Batch. And I'm missing a nice dot there, I see. So that's the serverless one. If you need to deploy a complete application to run, which means that you need to write a little bit of plumbing actually to make this work in the specific service, that's for Azure Cloud Services and also Azure Batch. That requires a bit of plumbing. In contrast, you can deploy only the code that you need to run, so a little bit of code, a couple of lines of code in these services, and then it just runs, which I think is just a fabulous thing from Azure Functions, for instance, where you can just make a couple of lines of code just run serverless and at scale. All right. So where do you actually run your applications in? Well, you can do that in Azure App Services, web app, mobile app, in cloud services, Service Fabric, Functions, and Logic apps. So if you want to host your web applications, so a website, for instance, you can do that in an Azure App Services web app, in cloud services as well, Service Fabric as well, because you basically can run any application in Service Fabric. And if you want to host your own APIs, then you can also do that in Azure App Services web apps. There used to be an Azure App Services API apps app, but that doesn't exist anymore because that did exactly the same thing in Azure App Services web apps. So they merged those two together. So host your APIs, you do that in a web app. You can also do that in cloud services, in Service Fabric, and also in an Azure function, interestingly, which of course you can, because in Azure function, you can expose that to the web with an HTTP trigger, and then it just triggers whenever you call your API, which is pretty cool. If you want to host a backend for mobile applications that does things like offline synchronization and notifications, you use the Azure App Services mobile app. Now, if you want to automate one step of a larger process, you would use an Azure function. You do that by having a trigger in a function and then having an output. And then if you want to automate a complete process, you would use an Azure Logic app, in which you can call multiple Azure functions and other APIs to make a complete process. Now, if you want to enjoy features like deployment slots and easy authentication authorization, then you would use services from the App Services family, like Azure App Services web app, mobile app, Azure Functions as well, and also Azure Cloud Services, which also has deployment slots. And if you want to run microservices at scale, then you would use Azure Service Fabric, which really is made for that. But you can also use Azure Functions for that in combination with durable functions, although it's a bit more tricky and it's not really designed for that, but you could do it if you wanted to. Doesn't make it a good idea. All right, so that is how to run your application in Azure. Now, the next category is where to store your data in Azure. This is a bit more easy than the previous category, luckily. Again, we'll start with the big picture questions, which are, what will I use the data for? And what type of data am I going to store? And then we'll take a look at which functionality do I actually need. So the first one, what will I use the data for? Is that for your application? Let's say for your forms over data application, which are most applications. Then you will have data in the form of OLTP, so online transactional processing. You need a type of data store that is optimized for that. Or if you use the data for data analytics, so you want to analyze the data, you want to do stuff with it, maybe build a machine learning model with it, then you would use a data store that is optimized for OLAP, so online analytical processing. That's the difference. Now, let's take a look. So what type of data am I going to store? Is that relational data, so tables with rows and columns, or is that something else, unstructured data, which can be document data, key value data, graph data, or anything in between there? This is an example of these big picture questions. So my app is an online reservation system. So that means I need an OLTP data storage system. And my app needs to store and retrieve document data. So not relational data, but document data. All right. So these are the options for storing data in Azure. Still a lot, but a lot less than running your application in Azure, right? So we have Azure SQL Database, the one that I love because I used to work with SQL Server back in the day as well. And now I progress with that throughout the cloud days here. Azure SQL Database. There's Azure Database for MySQL, Azure Database for PostgreSQL, and Azure Database for MariaDB, which are also the managed services within the cloud of these database technologies. So for MySQL, for instance, it is actually MySQL, but now it is running in Azure, which makes it scalable, highly available, and secure. There's Azure Cosmos DB, which is a very special service that you can use with multiple APIs. So you can talk to it in a MongoDB API, a SQL API, or a table storage API, for instance, and it just works. There's Azure Storage, which has subcategories of Azure's file storage, queue storage, blob storage, table storage, and disk storage. And there are the big data storage types, which is Azure Synapse Analytics, which used to be Azure SQL Data Warehouse. They renamed it, and now it's a bit different in functionality as well. And then there's the Azure Data Lake Store. All right, let's take a look. So the first question, what type of application do I have? Then you can take a look at this. So the top ones are the online transactional processing ones. So Azure SQL Database, for instance, and all the Azure Database for MySQL, PostgreSQL, MariaDB. Also Azure Storage works for that very well, and Cosmos DB. And the bottom ones are really optimized for analytical processing. So Synapse Analytics and Data Lake Store, they perform the best when they are used for that purpose. Yes, you can mix and match these throughout the purposes, but this is what these services are optimized for. All right, so what type of data? Do you have relational data in tables with rows and columns? Then you store those in Azure SQL Database, Azure Database for MySQL, PostgreSQL, and MariaDB. That's it. Those are the stores for relational data. If you have unstructured or document data, then you can store those in these services. So Cosmos DB and all the Azure storage services, including Azure Table Storage, which sounds relational because it's a table. And it is true, it is a table with rows and columns, although it's not completely relational because each row can have different columns and the data is not related as well. And then there are the data analytical services, which also can be divided into relational and unstructured document data, but we'll see that in a second. All right, let's compare these for functionality. So let's take a look at first the OLTP data stores, which is SQL, MySQL, PostgreSQL, MariaDB, Cosmos DB, and storage. All of the Azure storage services I've just packed into one, simply because they otherwise don't fit on the slide. All right, if you want to store relational data, then you can do that in these services like we just saw. If you want to store semi or non-relational data, then you can use Cosmos DB and also all the Azure storage services. If you want to use Microsoft tools like SQL Server Management Studio or Azure Data Studio, then you would use Azure SQL Database and also Azure Cosmos DB and Azure Storage. Those are really Microsoft native services, and all of the Microsoft tooling around that works really well. If you use MySQL, PostgreSQL, or MariaDB, they come with their own open source flavor of tooling. If you want to have advanced querying capabilities, then you would use SQL, also PostgreSQL, MySQL, and MariaDB, and also Cosmos DB. Azure Storage is not really meant for that. It's more simple to just store stuff in there, and then you get it out with OData queries, for instance. If you want to use multiple APIs to access your data, which is a very specific scenario, then Azure Cosmos DB is the store for you. And another thing about Azure Cosmos DB is that you can use it to store data in multiple geographic locations, and have that be writable as well. Azure SQL can also do that, SQL database. But that only has readable nodes that you can geographically synchronize. Azure Cosmos DB is really optimized to have global performance. All right. So now let's take a look at the analytical processing ones. So how do you choose between Azure Synapse Analytics and Azure Data Lake Store? Well, if you have relational data that you want to store, then you do that in Azure Synapse Analytics. So there you store data in rows and columns, in tables with rows and columns. You don't do that per se in Azure Data Lake Store. You can, because you can store data in Azure Data Lake Store basically in any format that you like. If you have non-relational data, then that you store that in Azure Data Lake Store, not in Azure Synapse Analytics. So this data store, Azure Synapse Analytics, requires you to define a data schema upfront because you store data in tables with rows and columns. So you need to know what type of data that you're dealing with in order to define that schema and then store that data in those tables. This database, Azure Data Lake Store, basically, theoretically, has no file or database size limits. Azure Synapse Analytics does, although these limits are huge. And usually, you have less money than you can, the limit on your credit card is lower than the limit of data that you can store within these services. Now, here's the question: how do you actually then choose between these services? Well, I think it's this. So you use Azure Synapse Analytics when you know which questions you want the data to answer up front. So you have lots of data and you know what type of answers that you like to get from the questions that you already know. Why? Because you need to upfront design the data schema there. So you can only do that when you actually know the questions that you're going to ask of the data. When you don't have that, so when you don't know what type of questions you're even going to discover, what type of patterns you're going to discover in the data, then you use Azure Data Lake Store to just have a bucket of data that you go through with AI and machine learning to just see what sticks. All right. So that was data, running your applications and data. Here's a final category, and that is how to choose Azure services to speed up your application. All right. So we'll first start now by looking at the options for speeding your applications up in Azure. We have the Azure CDN, so Azure Content Delivery Network. You use that to store static files like images and video files and distribute those all over the world. We'll see how that works in a second. We have Azure Cache for Redis, or Azure Redis, and you use that to store key value pairs of data in extremely fast in-memory storage so that you can have a cache of very fast storage. There's Azure Traffic Manager, which you can use to make your applications geographically redundant, but also extremely fast. And then there's Azure Front Door, which does kind of the same as Azure Traffic Manager in that it is sort of a load balancer that you put in front of your applications and then routes traffic to your applications. Although there's a difference between Traffic Manager and Front Door in that Front Door also contains a CDN in there and has other capabilities like a web application firewall and works on a different stack of the OZ layer, which we'll see. All right, so again, we'll ask a couple of big picture questions. First one is, are my users globally distributed or not? Are they maybe only in one country, or are they all over the world? Does my application use data that is used a lot and doesn't change often, or is it something else? And does my application use audio, video, or images? And then after that, we look at the functionality again. So, are my users globally distributed? Well, if that's not the case, then we stop right there. But if that is the case, then we ask the question, is the traffic between users and my application, is that HTTP based, or is that something else like TCP based, for instance? If it is HTTP based, then we take a look at Azure Front Door, because that is what it supports. That is the stack that it works on, HTTP. If that isn't the case, and you also want to have traffic that is, for instance, TCP based, then you need to take a look at Azure Traffic Manager, because that works on a lower level of the stack. And for both of these services, when you use them, then you can also stack that by using other services like Azure CDN and also Azure Redis Cache to improve your speed more. Now, the second question, does my application use data that is used a lot and doesn't change often? Well, here is a table of data that changes often. These are orders in a table, and these change often. Let's say Amazon has a table like this on Amazon.com. You get lots of new orders, orders change, orders get canceled. This changes a lot. But you might also have a data that looks like this. So a table of countries that you might load into a drop-down list box on your website. This might be used a lot, but doesn't change often. Maybe you update this once a year where a country is added or changed or something. Doesn't happen a lot. So this type of data that changes little, is very much suited to put into a cache, like Azure Cache for Redis, because you load it in there, and from there, you can just use it in your application, and then that provides in-memory data for optimal speed. It's extremely fast. And it also has advanced features like geo-replication, which means that it replicates the data in the cache all over the world so that it is closer to your applications. And also data persistence, which means that you can sometimes save the data that is in memory to disk. That is important because, for instance, if you are Amazon.com and lots of people have their shopping basket in your Azure cache for Redis or whatever type of cache, if that then fails, that cache, then you might have lost millions and millions of dollars. So you might want to save that every other minute or so. So this is that fast. Why is it fast? Because it's in memory and because it's key value. If you compare that, for instance, to Azure SQL databases, you can also have in-memory tables, but still you need to execute a complete query. This thing doesn't. This thing just does a lookup based on a key value pair. That makes it that fast. So then we have another question, which is, does my application use audio, video, or images? So static files, really. If that is the case, and you have a website that uses audios, videos, or static files that you have in your website and you serve up through your website, that is fine if your users are geographically close to your application that you run somewhere. If that is not the case, then they have higher latency. Now, what is latency? Latency is just the time that it takes for a signal, so for instance, an HTTP request, to travel over the wire. Now, you would say, well, that should go extremely fast, right? Because that's the speed of light. It is the speed of light, but it goes through all sorts of hops and routers and things under the water, over the water, satellites, you name it. It goes all the way, it goes super fast, but it still takes a little bit of time. And now you would say, well, okay, 188 milliseconds versus 19 milliseconds, that's not a lot. But then latency adds up, because if you serve a whole website, that's lots of requests. Let's say it's 10 requests. Well, usually it's a lot more. If that's only 10 requests and you have a 173 milliseconds delay there, then you already take a look at looking at 1.7 seconds there. If you assume that it all goes in sequence there, not parallel. So latency adds up, so we want less of it. Now, how do we do that? We could stick those static files into a CDN POP, or point of presence. This is basically a small data center that Verizon and Akamai have, for instance. Microsoft has its own CDN network as well. And these are all over the world. So if you put your static files into one of those CDN points of presence, then they get replicated all over the world, including always somewhere a location that is close to the user, and thereby minimizes the latency of getting that request. Another thing that this also does is that it offloads traffic from the website to the CDN, because now the website is not serving up those images anymore, but the CDN endpoint, which is a completely different service, is serving up those images. So the website now has more CPU cycles to deal with other things, requests from users, for instance, which is cool. So how does that work with Azure CDN? Well, if you have an Azure CDN service endpoint, you create that in Azure, then you attach some sort of service, storage service to it, like for instance Azure Blob Storage, and then you put your static files within that storage service, and then automatically, then CDN starts to populate all of those points of presence all over the world with that static stuff, the static files that you have. In your website, how do you use this? Well, you simply, if it's a picture, you simply then point to the Azure CDN endpoint instead of to wherever you got your picture from before, let's say a folder within your website. And by doing that, you have implemented Azure CDN, which is really cool and really easy to use. So, speeding up your applications in Azure. Let's compare these services. We've already talked about a lot of this. So if you want to offload traffic from your application, then you would use Azure CDN, like we just saw. Azure Redis Cache as well, because you can put data in there that is then not stored in your application anymore. And Azure Front Door as well, because it does contain a CDN itself. If you want to bring data closer to users, then you can do that through those points of presence within Azure CDN. Redis Cache as well, because it can use geo-replication to put its data closer to users. And also Azure Front Door, because it has a CDN in it. And if you want to bring your application closer to your users, then you would use Azure Traffic Manager and also Azure Front Door, because both of these services can do geo routing, which means that you put these things in front of your applications, and then when a user hits your endpoint, so for instance, Traffic Manager figures out where the geographically most performant version of your application is. So for instance, a web app in West Europe versus a web app in Australia, and then routes the traffic through there. And Front Door does the same in that regard. And then finally, if you want to provide fast in-memory access to data, then you would use Azure Redis Cache. All right. Whew. So those were the categories. Now, if you want to stay up to date with Azure, which is very difficult because things go very, very fast, like you'll see next week when it's Microsoft Ignite. At least I think it's next week. I use these resources and more. So there's the Azure Architecture Center that I use. It contains sample architectures and best practices like design patterns and stuff. It's really cool. Sometimes new solutions and sample solution architectures are added there. So I go there, for instance, if I want to figure out, hey, I need a web app with a database, but I don't want to expose those to the internet. How do I do that again? And then there's the answer there. There's also Azure Friday, which is Scott Hanselman. He does a great job there on basically a video podcast where each week he interviews someone from an Azure team, and those guys then explain something about Azure, an Azure service or a feature that just came out, which is really cool. There's also some blogs that I follow. There's a couple of links in the next slide there. And obviously you can follow Pluralsight as well, which is lots of Azure content that is kept up to date. So that this is a couple of links there. And that also includes Azure tips and tricks. I also contribute to that. Those are blogs and videos of, well, an Azure tip or a trick, like how to use Azure deployment slots, for instance, or how to choose between services, for instance, which is really cool and also free. All right, so you can find me on Pluralsight, and you can also still check out the Developer Weekly podcast. I think these were my slides. So now we have quite some time for questions, actually, which is great. So if you have any questions, shoot.
Hi, Barry.
Hi.
Hi, thanks for a nice session, Barry. I personally enjoyed this one. And for this session, we have a bunch of questions. Can I go one by one?
Sure, yeah.
Okay. The first question comes like, what's the maximum duration of tasks we can run on a particular function? Like basically, any time limit for an Azure function?
Okay. An Azure function time limit. Well, there are different time limits for that. It depends on how you run your function. So you can run it in consumption mode, which means that you run it serverless. Typically, it then runs for 5 minutes or less, which is long for such a thing, because you really would expect that to be like an API call that just runs for a second or less or something. You can run it for 5 minutes there. You can tweak it a little bit with some application settings. So if you go to the settings of your Azure function in the runtime there are some hidden things there that you can do to make it to 10 minutes. So those are serverless ones. And then if you run it on an app service plan, then you can run functions for way longer, like an hour or so. And then additionally, if you run functions on a premium plan, which is very expensive, but you can do that, then you can basically run them indefinitely.
Okay.
So it basically
Perfect.
depends on how much you want to pay.
Yes, yes, Barry. Got it. And even it's more clear. And the next question is when not to use the Azure functions. That is, the user is looking for some sort of non-favorable use cases.
When to not use Azure functions? That's a very good question because they are very, very useful. They are very useful. Well, I would say, for instance, for microservices, like we just saw, you could use Azure Functions to create a complete microservices application because you can use them to create an API with, and then multiple APIs. But Azure Functions themselves don't have any discoverability capabilities. So they don't know about each other, and they don't know where to find the service that does X or Y or something, where a typical microservices application needs to be able to find other services. So for a complete microservices architecture, I wouldn't use Azure Functions. I would use something like Azure Service Fabric or even Kubernetes, for instance. And there are frameworks there that can help you with that, like an actor framework, for instance.
Okay.
Apart from that, Azure Functions are great.
Okay. And in which scenarios we can go for logic apps, Barry?
Logic apps are really underappreciated, I think. They are so cool because you can automate lots of stuff with it. So when you create a logic function, it asks you for a trigger, just like an Azure function. So how does this thing start? You can start it on a schedule. You can start it based on an external event, like you receive an email or a webhook triggers or something else happens. Something is added to a SharePoint list. And then you can just trigger this whole process of things that you call. You can call an Azure function, you can call your own API, but you can also call one of the, 200-300 existing connectors that exist there that can do things like send an email through Office 365 or through Google, send a tweet, look through some tweet, use the SendGrid API, turn on and off a light, trigger a build, lots of stuff. So any time that you need to automate anything, and you think, I can just code that into some application or something. No, just look at a logic app. It does that for you, and it does it serverless, and it just runs automatically for you. And you can also have workflows in it, which are very cool. For instance, when it triggers, then it could send an email to me where it asks, hey, do you approve this build, for instance? And then I get to do that, yes or no. And then it even waits for me for, let's say, 30 days for my answer. And in 30 days, if I then say, yes, approve, then it still continues to run. It still remembers that and it continues to run. All that logic is built in. So anytime you want to automate anything, first look at a logic app because it's super easy to use.
Perfect, Barry. And the next one is, what is Azure Front Door?
Which one? Azure what?
Azure Front Door.
Front door. Yes. Azure front door. So it's basically a load balancer type of service. So if you have, let's say, a web app right here and another one right here, you would put a load balancer before that. So the user would first go to Azure Front Door, and Azure Front Door would then send that user request to your applications. So it's really the front door for your users. So you can put those things, a front door, an Azure Front Door, in front of your application. and that gives you the ability to route requests to wherever you want. So for instance, you could say, if a request comes in that has a URL of slash Azure Community AZ, then send it to this web app, and if it doesn't, then send it to that web app.
Okay, it is similar to the LB in AWS.
Yes, although front door is more advanced because it also comes with a web application firewall, which means that you can have all sorts of security rules in there. So it looks actually at SQL injection attacks before they come to your application. They are stopped right there at the core. Other types of attacks like that as well, HTML attacks, cross-site scripting, all the OWASP top 10 things are all stopped right there. And it then also contains a little bit of caching, so in the form of a CDN. So it speeds up your application as well. So it's a very clever load balancer in that sense.
Okay.
Yeah.
And so before closing it, like I have one more interesting question. Like, can I use DB managed instance instead of installing the SQL on the VM? Which one is recommended?
Okay. Yeah, so then the question is, can I use an Azure SQL database managed instance instead of installing SQL Server on a VM itself and then running that in Azure somewhere? I would
Right.
say, if you need extreme control, so if you need, what's that called? CLI objects within your server, for instance, that's a lot of control within SQL Server where you actually need those objects. Then you would install it on a VM, like an extreme example. If you don't need that, then you would use the managed instance. I would also always try to go for the managed instance because that means that Azure, the platform itself, is responsible for keeping that thing up and running, available and fast. And you don't want to do that yourself on there because then that means that you will be called at 3 a.m. in the morning because the SQL Server is down in the server. Yes, Azure will take care of that VM for you. It will keep the VM up and running, but not whatever application that you install on the VM. That's up to you. It's your responsibility. You don't want that responsibility.
Yeah. That explains very clearly, Barry. Like that's one of my personal question. So recently we were in an application design which we were supposed to take a decision on it, but I hope I took the right decision.
Now, from my standpoint, what I just said is very easy, but obviously you also need to consider costs there, right? Because in a real world, there's also costs, and Azure SQL Database Managed Instance is very expensive.
Okay. Okay.
But then again, it includes the SQL Server license. So if you need to buy that and then install that on a VM, it's also very expensive. SQL Server licenses are very expensive. So, you need to weigh that as well. And if you have unlimited money, of course, just go for managed instance always.
Okay. And the other question is, Microsoft share my information in Azure with any government agencies or?
Yeah, government agencies and data privacy. So I guess the question is, can, let's say, government agencies access data that is in Microsoft stored somewhere? I guess the short answer is yes, of course, in case of a very good premise. So if they have a reason to believe that whatever data you have in there might be of national security importance for whatever country that is that the US or some European country, I'm sure they can access that. You should always assume that. But they do not just, obviously they're not able to just browse through your data. That is very, very highly illegal. Only in case of actual emergencies, then yes, they can,
Okay. Got it. And the last one we'll take, considering the timeline, we will consider this as the last question. Barry, like what new things we expect from Azure? I hope you already answered on that on the session itself. Nobody can expect, like it's very fast. We cannot predict that one. But again, we just wanted to hear from you.
Yeah, well, I think Containers are great, and they are still complicated to use sometimes, especially when you have container orchestrators like AKS. Lots of command line stuff going on there, lots of things that can go wrong. I think Microsoft will make that a lot easier to use, containers in general. So it will probably be super easy to just have a container or multiple ones, spin them up, see that visually somewhere, and use that in a way easier way that you don't need a very specialized certification and lots of training for that, because then you can just use it. So that's one. The same will go for AI and ML, so artificial intelligence and machine learning. That will also become way easier to be used. And you see that already in cognitive services, for instance, which is AI and machine learning as a service, basically. It's pre-trained models. You don't have to do anything for that. But it will be easier to also then add your own models without being a data scientist or having a whole team of AI people doing that. So I think definitely containers, AI and ML will become easier. And the rest is already pretty mature, like data storage, for instance. They will all just become a lot cheaper, and running your applications will also just become a lot cheaper and more integrated. So, let's see what they come up with next week. I really can't say anything about that yet.
Yes, Barry. Barry, and one important question the user wants to know this answer is in Cosmos DB, which is better for complex data store, either a core or Mongo API?
For complex data store, well, underlying the data is actually stored in exactly the same way. The APIs are just different ways to get to that data. So I guess the question then would be, what would be better to maybe also query more complex data in that sense? Then I would, it doesn't really matter. Like MongoDB, you can also have very advanced queries in there, and SQL as well. So it just depends on what your application is and what you are more comfortable with. Ultimately, for Cosmos DB, it doesn't matter. It's stored in exactly the same way. Performance will be also almost the same there. Costs will also be the same. So it depends on what your application does. Don't rewrite your application completely. Or if you start from scratch, what are you more comfortable with, Core or Mongo? I think that's more of the question.
Okay. Thanks a lot, Barry. Considering the timeline, thanks for your valuable time. And some of the slides, I took the screenshot and I'm going to keep that in my desk for all time reference. The slides are very precise, and really all of us enjoyed the session.
Excellent. Then one more thing I want to say, if you want more of this type of content, there is this course on Pluralsight, Azure What to Use When. If you do not have access to Pluralsight, reach out to me on Twitter or LinkedIn. I'll give you a 30-day free trial code.
Sure, Barry. Thank you.
All right. Thank you. Bye-bye.
Hi, Benny.
Hello.
Hi. Hi, everyone. I have Benny with me to give a great session about GraphQL in HTML with Apollo elements. And a few few words about Benny. Benny's specialties are to craft progressive web apps, mobile first, offline first, accessible, and user-centered web experience. And today, probably I'm so excited to learn something new on the client-side web application development. Probably Benny, it's handing over to you, Benny.
Thank you. Hello, shalom from Jerusalem. Good day to everyone. So my name is Benny Powers. During the week, I'm a principal web developer at Red Hat. I'm also a core member of the Open Web Components open source community collective. And today I'm going to talk about a library called Apollo Elements, which I maintain. And it's based on Apollo GraphQL and combines that Apollo GraphQL client library with web components to help you factor performant, declarative, HTML-first GraphQL web apps. So in Barry's previous session, we learned a lot about the different services that you can use on Azure in order to build your web services from the back end through to the front end. And now we're going to talk about one option that you have for building out the front end of your web apps on Azure. Okay. So before we start, I want to give a thank you to our sponsors and partners for putting this together, helping to put this together. That's me. Okay, so yeah, the talk is about GraphQL in HTML with Apollo Elements. Today we're going to start by covering sort of the basics of what GraphQL is and what it looks like, but a little bit on the server side, and then some information about how it functions on the client side. Then we're going to move on to a short introduction to web components, what they are, how they work, some of the advantages. And then we're going to talk about the subject of our talk, Apollo Elements, the library in question, and how you can build your web apps using GraphQL and web components. So let's start by talking a little bit about what GraphQL is. Well, GraphQL is a query language. That's what the QL part in GraphQL stands for, Graph Query Language. And it's a query language for APIs. So just like SQL is a query language for databases, you can think of GraphQL as a query language for APIs. It was published, the specification was published by Facebook in 2015, and it's gained tremendous popularity. It's used by GitHub, Twitter, Atlassian, IBM, Amazon, and many, many more. There are some trade-offs to using GraphQL, and before we get into the details of how the language works, I think it's worthwhile just going over them a little bit. So on the plus side, you get strong types for your data at runtime, which means that if you have a certain data object that let's say your client receives, then the client has certain guarantees about what that object contains. It's very abstract and very expressive. Writing components with GraphQL, especially front-end components, is a really pleasurable experience. GraphQL is great for deeply nested data. It makes these kind of complex data structures easier to manage because you can query for exactly the data that you want. And on the server side, GraphQL lets you define the fields on all of your data objects with functions, which are called resolvers. And that gives you tremendous flexibility when you're factoring your app, especially on the server. But there are some trade-offs with using GraphQL that we should be aware of before we sort of dive in for hype reasons. There can be an implementation overhead to using GraphQL, both on the server and on the client, that you should be aware of, as opposed to just sort of regular HTTP calls. Debugging a GraphQL app can likewise be a little bit unfamiliar if you're not used to it. There are sort of different conventions that one should learn about and be aware of. And as we mentioned, the overhead, there can also be performance pitfalls depending on how you factor your backend, as well as on the front end. There's a certain cost that you have to pay in terms of bundle size in order to load up the necessary libraries, can be. And there can be lots of gotchas, both on the back and the front end, that it takes experience to learn how to deal with, or just reading a lot of blog posts. So let's get into how exactly GraphQL works a little bit. So every GraphQL app revolves around a GraphQL schema. And a GraphQL schema is essentially a GraphQL document written in GraphQL, a particular type of GraphQL called the schema definition language. And it contains essentially a variety of types that are available in your application. So for example, we might have a person type like we have here on the screen. And using the schema, we can define what the fields are on each person object, the possible fields. So we might say that a person has a name and a picture, which are both strings. And a person might also have a list of friends. And you see here that the friends property is recursively referencing itself. So that means that every person can have a list of friends. And each of those friends is also a person. Now, using the schema, when we're writing our GraphQL server, we can define resolver functions that get the contents of each of those fields, whether from a database or perhaps they're automatically generated or some other means. So here's an example of what that might look like in a Node.js backend. We could have a person resolvers object, which we pass to the server instance to say, here are all the resolvers for the different fields on person. And in that object, we could define, say, a picture resolver, which says that if somebody requests a picture on a particular person, we should run this function in order to get it. In this case, the function that we're running is, let's say I have an ORM or something like that in my backend that goes and gets the picture by ID. So we call that function. Likewise, let's say our database provided a list of friends as string IDs. So I might map over that list of friends, go out and fetch that person and resolve the friends list in that regard. So GraphQL can be analogized to HTTP in some ways, but in other ways, it's very different. So unlike a REST API, which will have multiple different endpoints depending on the different resources that you want to access, GraphQL servers typically only expose a single endpoint, usually /GraphQL when we're talking about HTTP. And unlike in HTTP, where there are many verbs, get, post, put, delete, options, etc., GraphQL really only has basically two verbs: query, to read information from your graph, and mutation, to update or change information in your graph. So by analogy to REST APIs, where you might issue a GET request to get information from an API, in GraphQL you would query. And where you might issue a post, put, or delete request to an HTTP REST API, you would issue a mutation in a GraphQL app. So let's take a look at what making a mutation, a query looks like. We'll start in a GraphQL document by declaring a query, and we can give it a name, in this case, person query. We can also pass variables to a query. So in this case, we'd say that a person query takes a single variable called ID, and the type of that variable is an ID type, which hints to the GraphQL server that it's a unique ID. And the exclamation mark at the end of ID signifies that this variable is required. The server should throw an error if it doesn't receive that ID variable for this query. That first line is called the query operation, and it combines the name and the variables. On the second line of our query, now we are selecting fields on the root query object. So when we wrote our server, we would have said that one of the fields you can query for on the root query is called person, and that field takes an ID. And here we're passing in the ID variable that we have on our operation, passing it to the person field on query. That in turn will run the person resolver on the server. And then inside that person field on root query, we can select the particular fields that we want on person for this query. So for example, we can get the name and the picture like we saw before, but we can also say that we want some of the friends list. In this particular query, we only want to get the name of each friend. Perhaps we're not interested in the picture, we don't want to display it. Perhaps we don't necessarily need to cache these objects by ID, so we'll only ask for the name. We might get back a data object like this in JSON format from the server. So a typical query response would be a JSON object with a top-level data key. And inside that data key, we have our person object that we queried for. I mentioned at the start that GraphQL is strongly typed at runtime, so that type name property that you see on the first line here, that hints to the GraphQL client or anyone else who's interested what type of object this is. And as we see, we can get our data, the name, the picture, and the list of friends. One of the advantages to writing your app with GraphQL is that you can sort of massage your data or suit it to your client. Let's say our database schema doesn't match our query schema. We might have different casing scheme. For example, instead of having name, there's here first underscore name and last underscore name. So our name resolver could combine those. And we see that there's a friend underscore IDs field here, which has a list of string. We want a list of friend objects, so we can resolve that friends property that way. We can still respond sensibly from our GraphQL server with the kind of data that the client requests. And that brings us to writing front ends in GraphQL. What does that look like? Well, typically on the server, GraphQL lends itself to deeply nested and network data, like we saw before. On the client side, GraphQL front ends naturally tend towards a component-based architecture, which is very popular nowadays in front ends. So in this example, you can see that there's a components folder which has multiple different components, and each component directory has its own styles, its own class, and its own query file. So that can be a very well-organized way to factor a front-end app. When we write a UI using GraphQL, sort of the top-level way we're going to think about our UI is that each component is a function of its query. What does that mean? Say we had a query that gets a list of users with the ID, name, picture, and bio for each user. Well, then our UI would take that query, get the data from the server, and produce, for example, a list of user cards that have avatars, names, and bios, etc. So in this case, the UI, which is the specific cards that we're rendering on the screen, are a function of the query that we passed to that component. And lucky for us, web browsers nowadays come with their own built-in component model, which is called web components. And now I want to talk a little bit about what web components are, how they work, and how we can use them to build our apps. Web components are custom HTML elements. And you, the author, the user, can define the behavior of those elements. So for example, there's a video element in HTML, a built-in HTML video element that displays video when you give it a source file. You can write your own elements that do similar things. Perhaps it plays an animation or a game given a source file. Web components, or custom elements, they're also called, they can have their own HTML templates, their own class methods in the DOM. They can fire and listen for events, standard events and custom events, and they can have their own DOM properties and HTML attributes as well. You build web components using the standard web technologies that you're already familiar with, HTML, CSS, and JavaScript, with all of its expressive potential. So let's take a look at a quote unquote vanilla web component, meaning a web component that doesn't use any libraries in order to do its thing. So every web component ultimately is a JavaScript class that extends from HTML element. And when you do that, you can define, excuse me, when you do that, you can define standard callbacks, which can run effects when the element does certain things. For example, you can define a connected callback. Every time this element connects to the DOM, either somebody appends an instance to the DOM, or the browser finds it in the page HTML and registers it. So you can do certain things inside that connected callback. One of those things you can do is called the attach shadow method, which is sort of the secret sauce of web components. What this does is creates a private DOM fragment, document fragment, unique to this element, in which you can have tighter control and greater encapsulation on what happens inside of your web component. in our instance, we're going to give that shadow root some HTML, a span tag with an ID, and a slot element. Just note that for the purposes of this demo, I'm using inner HTML, but there are more performant ways to do this kind of thing, to template your elements. You can use the template element, for example, for greater performance. Once we've defined our class, we can call custom elements.define. Custom elements is an object on the window, a global object that comes with the browser. We can pass a tag name to that custom elements.define call, in this case, person-element. Every custom element has to contain at least one hyphen or dash in its name. That's what separates custom elements from built-in elements. And the second parameter to define is going to be our class that we have defined. Once we do that, the browser will find all of the instances of person element tag in the DOM and upgrading it, assigning this class to that element with all of its behavior. So here's some example HTML that we might use. We might put our person element and give it an emoji attribute and pass in a block quote. If you remember the slot element from the previous slide underneath the span ID emoji, that slot element says to the browser, any passed in content should be projected into the shadow root at this position. So we'll slot in a block quote like that. So what does that look like in practice once you put it on the page? Let's take a look at some of the features of web components. When we add this element to our page, we'll get a shadow root inside the element. And inside that shadow root will be the DOM that we provided. We can, for example, put a link element to some CSS, which will only apply inside our shadow root. We have our span with our ID, and we've got our slot element for the block quote that we slotted in, or any other content that we want to slot in. One of the things about shadow roots, which is really the best, is that it encapsulates your DOM. So you'll note that we have a span with an ID on it. Now, if we were to call document get element by ID emoji on this document that this person element exists in, we wouldn't get anything back, because that emoji element doesn't exist in the global document. It exists only privately in the shadow root of this element. So if we wanted to get a JavaScript reference to it, we would have to query for the person element first, take its shadow root property, and on the root call get element by ID. And that would give us back our span element. Let's say we passed in this CSS as our person element.css. Well, with the host selector, we can target the person element itself. We can say that the whole person element should have a particular font family, let's say. And we can also target privately our private DOM, for example, the emoji ID element. Now, targeting that emoji by ID will only affect instances of our person element. It won't affect any other elements on the page that have the ID emoji. This can be really powerful for design systems where you want to have control over how your button or your input renders without affecting the rest of the styles on the page and potentially breaking your users' applications. So, for example, we could have next to our person element another element with the same ID of emoji, and our styles wouldn't affect it. And in fact, that would look like this, right? So here we have our private emoji, which is wizard emoji says is italic, but the block quote with ID emoji is not italic because those styles don't apply to the global document. Web components are extremely powerful, and you can do a lot with them. In actual fact, this presentation is written using web components. Each of the slides is a web component itself. And here's our person element with its shadow root and emoji in there. So that brings us to Apollo Elements, which is the subject of our talk. Apollo Elements is the glue between GraphQL and web components. And there are two main ways that you can use Apollo Elements to factor your apps. The first is using pre-made custom HTML elements. For example, there's an Apollo query element. And the second is by defining your own custom GraphQL elements using one or more web component libraries of your choice. And there are a number of them that we support here. So you can write vanilla web components that extend directly from HTML elements and use Apollo elements with them. You can write your web components with Lit, which is a popular web components library, with Microsoft's Fast Element, with Haunted, which has a hooks, or Atomico, which have a hooks-like API, many other different kinds of libraries. And in actual fact, you can write your app using multiple different web components libraries, depending on your needs, and they can all coexist together side by side on the same page. So let's talk about writing queries using HTML. The first thing that we're going to do is we will set up an Apollo client element. So this is one of the custom elements that's provided by Apollo Elements. And we can pass in a URI to our GraphQL server. In this case, we'll do the SpaceX, unofficial SpaceX demo server at https://api/spacx.land/GraphQL. That Apollo client element will be responsible for all of the elements, all of its child elements, and all of their child elements, even through shadow roots. So underneath the Apollo client element, we can add in an Apollo query element. And if we like, we can pass a GraphQL script as a child of that element and define our query in there, right there in our HTML. The element will parse that script as GraphQL and initiate the query. We can also put our query as a .GraphQL file on our web server and have Apollo Query fetch it for us and parse it from there. Now, once we have our query data, we want to render some kind of template, right? Earlier on, we talked about how in GraphQL apps, the UI is a function of the query. So we have our query here. Where's the function? With Apollo Elements components, we can pass in a template element using this special curly brace mustache syntax. And that will let us update our DOM performantly every time the data changes. So in this case, we'll give a first level heading, and that will take the launch next.mission name property that returns from the data. We can hide a paragraph depending on the loading state of the component, and then display some of the information that we got back from the server here in the template. So here's a live running example of what that would look like. Okay, so we have our template element, and here on the right-hand side, you can see the results that we got back. This actually went out and fetched from the SpaceX server. It told us that the mission name, the next mission name that's launching through SpaceX is CRS-21, and it's launching from this location aboard this type of rocket. Okay, so usually when we do a GraphQL app, we don't just want to query for data. We also want to sometimes make changes to our graph. And we do that through mutations. So how would you write a mutation component using HTML? Again, let's start with our Apollo client element. And again, we'll point it to the SpaceX API. Let's pass in a query. For example, let's say we want to get all of the latest users which registered in the SpaceX API. And that'll be through the latest users query that we have on line 3. And we'll pass in a template which repeats through the list of users that we got back. And for each user, it'll output an li tag with that user's name property. Now, if we want to register a new user, we can use the Apollo mutation element. And what we'll do is we'll give it the insert user mutation document at insert user.mutation.graphql. And we can also give this element certain types of inputs. Let's see how that looks. Here we'll use some custom elements from a library called Shoelace, which is a UI system designed and developed by Corey LaVisca. And the input functions more or less like a regular HTML input. You can type your stuff into it. We can pass it a label, username label. And the button functions, as you would expect, like an HTML button. But there are some special attributes that we're going to put on these elements in order to give them behavior inside our Apollo mutation. That data variable attribute tells the parent Apollo mutation that this input is responsible for a variable to the mutation called name. And the trigger attribute on the button tells the mutation element parent that anytime the user clicks this button, that it should actually issue the mutation. It should send the data over the wire or over Wi-Fi to the server. So let's see what that looks like. Here you see that the last 3 users registered to SpaceX.land are all called Sherlock Holmes. Who knew? And we're rendering them here with our template. Down here, we have our username input, which is the one that we registered here. And we have our add user button, which we had over here. So if we want to register a user, oh, I forgot, there's 2 more attributes that we didn't mention yet. This refetch queries attribute and the await refetch queries attribute. What those do is it tells the mutation every time you finish or you get data back from the server, go ahead and refetch that latest user's query by name and wait for its results before the mutation toggles its loading state. And that way we'll be able to update our UI every time the mutation happens. So let's put in our asconf dev user. That's in loading state now. And we see that it has, in fact, fetched the latest users from SpaceX.land. If you've used Apollo Client before, you might be asking yourself at this point, hey, wait a minute, refetch queries is not always the recommended way to update the UI. Can we use updater functions to do that? And in fact, we can. Mutation updater functions are an API on the Apollo client, which let you define a function for updating your UI instead of just declaring, go and fetch these queries again. It's a great way to save network hops and increase the performance of your application, as well as to handle more complicated use cases where the mutations could affect calculated fields or things like that. So let's briefly take a look at how that would work in Apollo Elements. Instead of using the refetch queries and await refetch queries attributes, we could just pass in the script and the template to our component. And then in JavaScript, we can query for that mutation component, as well as its sibling query component. And we can assign an update function to the mutation elements options object. That function, I don't want to get into too much details about this because you can read about the specific APIs on the Apollo client documentation website. But that function takes the instance of the cache as well as the resulting data that we got back from our mutation. And then we can sort of modify our data the way it should look as a result and call write query on the cache using our query elements query property. For more information on update functions, see the Apollo client website or the Apollo Elements website. So these Apollo Elements components are available via NPM. You can get them at apollo-elements/components and import them into your apps. And being on NPM, they're also available via CDN. So you can just drop this script tag into your page and start writing GraphQL. The Apollo Elements components are declarative because they're ultimately just HTML. They're dynamic. Their templates update themselves when the data, every time the data changes. And they're HTML first, letting you think about the structure of your app, its semantics, and its document instead of being focused entirely on script. But there is much more to the Apollo Elements library than just these custom elements. So I want to talk about what we can do to factor more complex applications. The Lit team at Google that's responsible for the Lit library, formerly called Lit Element and Lit HTML, recently released version 2 of Lit. And one of the brand new features that they've added is something called reactive controllers. So what are reactive controllers? They're a composition primitive for web components. You can think of them kind of as analogous to React hooks. But these controllers aren't just limited to Lit element. In fact, once you've written a controller, it can work with any component system with a little bit of glue code. You can use controllers with React, with Angular, with different web components libraries, or directly on HTML element with a few modifications. Controllers complement or replace class inheritance or class mix-ins, which was and continues to be a common practice when factoring apps using JavaScript classes. So whereas mix-ins and inheritance have a my element is a something relationship to the mix-in, controllers have a my element has a something relationship. So instead of having, let's say, an Apollo query or maybe a user query element, which is itself that query, you could have, let's say, a profile page element, which has a query to get the users. And we'll see what that looks like in a few slides. I like to take an analogy to biology. There are structures called membrane transport proteins in animal cells, and they function as channels to allow certain substances into or out of the cell. And they're typically activated by sort of these key proteins which fit inside and open up the channel to allow molecules in. If you think of your lit element as being this large baby blue animal cell, it implements an interface called reactive controller host, which allows it to function alongside with controllers. When you bring a controller into your app, let's say this dark purple blob over here, it opens channels into your element in order to interact with the DOM or with the element's update lifecycle. So we would call add controller on the element in order to register that controller. And inside the controller, we could call request update on the host, for example, maybe to re-render the DOM or to run other property effects. The controller can also hook into the element's lifecycle. So for example, a controller can have an optional host connected callback, which will run during the connected callback of the host element, or a host updated callback, which will run after every reactive update to the DOM. So let's take a look at a simple example. Every controller is a simple JavaScript class. It doesn't have to extend from any particular library, so they can be totally zero dependencies. Here's a clock controller which displays the time. When we run the constructor, we pass in a reference to the host and call add controller on the host. And then we can get a formatted time value using the datetime format API. When the element connects, we'll start our set interval in order to set the new value and then update the host. So every time the optional timeout is reached, let's say 1 second, it'll call request update, and that's what's updating our DOM here. Likewise, in the disconnected callback, we can just clear our interval so that we're not wasting space. And our host element, similarly, in this case, it's a lit element, has a reference to its clock controller. We're passing in a reference to the host, as well as the timeout of 100 milliseconds. And when we render our DOM, we can say, hey, I want to get the formatted time out of my clock controller, and it'll render just like that. Your lit element, you add the controller, we can import it from our library, and we can render out that time value like we saw previously. But I mentioned earlier that controllers aren't limited to lit element. If I wanted to write my element using just HTML element, I can use the controller host mixin, which is provided by Apollo Elements mixins package. I can apply that mixin to HTML element, and that will add that reactive controller host interface onto my element to allow me to use controllers. So for example, in the update callback, I might perform some imperative DOM updates inside the shadow root of my host. So here's a little more complicated example just to flesh out our knowledge. Here we have a color picker element. We have a mouse controller, which gives us the position of the mouse at any given time. And our color picker, when it updates, will set some style properties on the host, depending on the mouse's position. So we can see we're updating that circle loop element over there. And when we click, we can pick the particular color that we want to use. Controllers are great. In our mouse controller example, how does the data flow work? Well, first, when the color picker element connects, it calls the host connected callback on the mouse controller. That adds an event listener to the window, listening for mouse events. Every time we get a mouse event from the window, it sends it back to the handler on the mouse controller, which calls host request update on the host, and that re-renders the DOM. So then the host, in turn, will access the position property on the mouse controller in order to get the data that it needs. And now that we've gone over how controllers work, we can talk about the Apollo controllers and how you can use them in your app. So we have an Apollo query controller. It's analogous to the Apollo query element that we saw before. And in actual fact, the Apollo query element uses this Apollo query controller under the hood. This Apollo query controller will query data from your GraphQL server or from the local cache, depending on how you write it. And it'll expose the state of the query in its data property, loading, error property, and others every time the state of the controller updates. So if you get new data, if the loading state changes, if you get an error, you can render those to your DOM. You have lots of different options in an Apollo query controller, like you can set up polling, you can set up fetch policies, and basically all of the options that you have in Apollo client. For example, you can call fetch more on it to do infinite scrolling, pagination, those kinds of things. Let's take a look at an example. In lit, we would just instantiate our new Apollo query controller, passing it a query, and there's a third parameter for options. If we were using Microsoft's FAST library, we expose an Apollo query behavior, which is sort of the fast version of reactive controllers, and it's more or less the same API. If we wanted to write our apps using hooks via the Haunted or Atomical library, we could pull in the use query library from Apollo elements, and that also uses the Apollo query controller under the hood. We'd get our data back. Or if we wanted to use hybrids, which is sort of very innovative, different sort of web components library, we can just pass the query factor along with our query. All of these are well typed. So if you pass in a typed query object using TypeScript, you can get autocomplete and types on like this.query.data, for example. So let's take a look at how a query component might work with a controller. Let's define an interface for our query. Let's say that it queries for profile and it gets back the name, which is a string. We can then define our user profile query, and we can strongly type it using the type document node from Apollo client. And we'll just say that this is the query document. When we define our custom lit element as user profile page, for example, we can give it some shadow styles, and then we'll pass an instance of Apollo query controller along with the user profile from before and an instance of the Apollo client, let's say, that we brought in. You can use a global instance or you can pass in a specific instance. In our render function, let's destructure the data and the loading state from the query controller. And we'll just render out a little string that says, hello and welcome. And that's what we have over here. In addition to the query controller, we also have a mutation controller. So as you'd expect, it fires mutations off to your GraphQL server. It provides a mutation function with several options, like you can pass specific variables to your mutation. You can use optimistic UI, which is sort of like saying, I expect to get this specific response back to give you a faster feeling UI. And all the other options that you have on Apollo mutations, go and see the documentation. And like query, it maintains the state of the request, updating the DOM every time you get new data, new loading state, new errors, etc. We can also pass in an update function like we saw on an earlier slide. So just like before, you can use mutation controllers with lit, with Microsoft Fast, with hooks, or with hybrids, and just with HTML element as well. So here's an example of a mutation component that has both a query controller that gets the user profile and an update profile mutation. So let's create just like we did before, let's create our user profile query here on our class, pass it in that same user profile mutation query object, But we're also going to add a mutation property, which is a mutation controller and has our update profile. We can pass it the instance of our client as well as an update function. And what this update function will do is it will update the specific user profile query with the data that we got back from the mutation. one of the great features of controllers is that you can stack them together. So in the previous version of Apollo Elements, all of this was based on mix-ins. You couldn't really have a single element that had both a query and a mutation together. But now that we have controllers, you can put them together in the same element, and it's nice. Okay, so let's do a little bit of DOM. We'll have a click listener that every time we click the save button, it'll issue the mutation on our mutation thing, and it'll query for the value for our input. And we'll just render our DOM out over here, depending on the state of the query or the mutation. We can render out the result of the query here. And we can also set up our input to, this will be the value of our new username and our button. And when we click it, it'll run that click save method. So let's try that. There you have it. So it went off to the server, set the new name using the mutation, and came back from the query, updating the UI for us. The advantages to controllers, like I said, are that they are composable and stackable. You can share them around, add them to arbitrary elements, add arbitrary amounts of controllers to your elements. They don't modify your base classes, so you're always aware and in control of what kinds of values and things that you have on the base class. And unlike a mixin, which might clobber, sort of superclass properties, the controllers don't, because you assign them a new field on the class. They're very dry. Don't repeat yourself, because you can isolate your code in one place and pass it around, and they're reusable. So I just wanted to point out as well that Apollo Elements isn't necessarily limited to just JavaScript. Here on the left-hand side, we have an example of writing one of these components using F#, and that's through a library by a colleague of mine named Angel Munoz called fable.lit. And so here we're writing the same kind of custom element class with controller. And on the right-hand side, we're doing the same thing in Ruby.
Hi, Benny. Sorry, on the last slide, can you please enlarge that one? It's not visible.
To enlarge, yeah, sure. Let me zoom in. So here's like an example of using Fable. And here's an example using Ruby. I just wanted to demonstrate that it's possible to use other languages to do this.
Okay.
Put links to all of these in the discussion. Okay.
Yep.
So the controllers you can get, like the elements by npm at Apollo Elements/core, and likewise you can load them over CDN using JavaScript modules. So let's just review what we covered. We talked about what web components are. They're custom HTML elements. They have their own. They can optionally have their own isolated shadow DOM, and they let you do fast updates in your app. They're very performant. Our GraphQL HTML elements are declarative. They have dynamic templates, and they're HTML first. And our GraphQL controllers are cross-compatible between frameworks. They're composable, and they're compact. I hope you'll try Apollo Elements for dashboard SPAs. You can imagine a business SDK that vends a set of custom elements that have Apollo Elements controllers inside that go out and fetch data from your company's GraphQL server and provide it to users, maybe given a token or something like that. Or micro front-end widgets that have their own isolated shadow DOM and can query from your GraphQL server and do things like that. So I want to thank the communities that are involved here, the esteemed communities that are taking part in this event, and the partners that were involved as well in making this possible. And now we have some time for Q&A.
I think it was an excellent session, Benny. And let's go with the questions. And the first question itself, it's a very simple one. What is SPAs? Single page applications. What is SPAs?
Yes, a single page application is a very JavaScript oriented app where navigations are handled using JavaScript instead of sending a new page request to the server. So you might download a single HTML file and then run JavaScript to update the state of the page and what's rendered to the page, depending on what the user does.
Okay. And can I use this library within my Node.js application?
Yes, you absolutely can. It pairs really well with Apollo Server, and you can serve those Apollo elements using regular HTML in for example, a multi-page application where every time the user clicks a link, it issues a new page request to your Node server. So you could just send back that HTML. And any HTML page that has those Apollo elements and that also loads up the script, the module script, which defines them, they'll behave as you expect. And you can also, of course, write your own JavaScript modules using the controllers and do your pages like that as well. And you can do that with any server. Like we saw, you can do it in F#, in Ruby. You can just write your own HTML and put that on a static web server as well, an Azure static web server, web storage, for instance.
Okay, okay. And one of my personal questions is like, for the fetch more method, I was saying that to loop for the infinite paginations and all, like if to pull the infinite records from the DB and show it instead of the pagination. How it works, Benny? Could you please explain more on the fetch more method?
Sure. Yeah, I don't want to get into like too many details because there's extensive API documentation, which you can look at on the Apollo client website. But the basic idea is that you would define a query to get your initial data, and then you can say fetch more in order, maybe when you click on the next page button, and you could pass into fetch more some new variables. Like, so maybe you're doing cursor-based pagination, so you could pass in the cursor for the next page to fetch more. And then you can also pass in an update function which says, here's how to update the cached data and how to update the UI when the results come back from the fetch more. And you can do that maybe on a scroll event, let's say, when you get to the bottom of a long list of tweets or something like that.
Yeah, that's what like in my mind that's what it came instead of like even I didn't realize that on click of the next button, because next button obviously we will be making another call to retrieve the data, but on the scroll, if we make that or if we use that fetch more on the scroll event, then it'll really make sense. That's what my understanding is.
Yeah, and then you can update your DOM very efficiently. One of the advantages to the Apollo client is it's sort of declarative data. So once you update the cache's data, it'll automatically update all the components on the page that reference that data, no matter which query they come from.
Okay, that's perfect. And thanks a lot, Benny, for your valuable time. And one thing I just wanted to highlight is the membrane transport proteins. That was really very interesting, and it was easy to understand that how it works, how the controller actually binds within that. So
Yeah,
thanks a lot, and it was very interesting, Benny.
yeah, a pleasure. Do we have any more questions or any more feedback from the audience?
No, not it. Like overall, the feedback was very nice, and everyone is saying that it's an excellent session. There's no other specific questions, Benny.
Okay, great. So thanks for watching. I made this presentation using Apollo GraphQL, D3, Lit, tools from OpenWC, Rocket, which is a static site generator, and Shoelace components. So go and check them out. If you want to read more about Apollo Elements, you can go to apolloelements.dev. It's all one word, apolloelements.dev. And if you want to learn more about Apollo GraphQL, which is the open source library that Apollo Elements is built on, you can go to apollographql.org.
Yeah, sure, Benny. And I request the audience to submit the feedback session without file. I have posted the session code on the chat. Please do give the feedback. Thanks a lot, Benny. Thanks for your time.
A pleasure. Thank you very much.
Hi, Mike.
Hi, Satish.
Hi, how are you today?
Fine, and you?
Doing good, great. And thanks for joining, Mike.
No problem.
Yeah. And hi, everyone. Mike is going to walk us through the evaluation of Azure ARM. That's what one of the very interesting topic for today. And a brief about Mike is the CEO at 350, an experienced consultancy company with a strong focus on the Microsoft Cloud. And one more important thing is he's the founder of Dutch Cloud Meter, which I'm so proud to say that. And he loves to share his knowledge, which also one of the reasons why he founded the Dutch Cloud Meetup. And Mike is a public speaker who writes blogs and organizes a lot of events in Dutch. Microsoft has recognized him as a Microsoft Azure MVP. So, with that introduction, like Mike, the stage is yours. If at all you want to add anything more.
Thank you, Satish. No, I don't think I will add anything more. So let's just dive into the session. So let me start by sharing my screen. Let me pick the right one. Yes. So if I'm not mistaken, everyone should be able to see my screen at the moment. So hi, everyone. Welcome to my session for today. Like Satish already mentioned, I'm Mike van der Graag, CTO at 350, a Dutch consultancy company, and I'm also the founder of the Dutch Cloud Meetup, where we host meetup events on a regular basis. But today we are here together to talk about Bicep, and basically the evolution of Azure ARM, because Bicep is a new language coming into the Azure platform and giving you a lot of other capabilities that you did not already had with Azure ARM. But first, as we are talking about Azure ARM and Bicep, and Azure ARM is in fact a sort of infrastructure as code. Let us first look at what is basically infrastructure as code. So basically, I found this definition on a post of Donovan Brown of Microsoft. Basically, infrastructure as code is the management of infrastructure in a descriptive model using version control to store the files. So basically, how you can see infrastructure as code is basically a file that describes your infrastructure and that you can save in version control systems or store in files somewhere. I always like to discuss it. Basically, if I look at against the Azure platforms, that infrastructure as code is some sort of your contract, and that's basically the contract of your infrastructure. So how should my infrastructure look like? So really making sure that you do not have some kind of configuration drift when you're moving from environment to environment. So basically, why should you then use infrastructure as code? Basically, you should use infrastructure as code to save money. And that's basically you will be saving money by delivering stable environments. And you can deliver those environments very rapidly and at scale as well, because you have everything saved in infrastructure as code. It's very easy for you to spin up a new environment, maybe spin up 10 environments as well, basically in a couple of minutes as well, because you have everything saved in a file. You can add additional version control, so you can version your infrastructure. Normally, when you do changes on your infrastructure, you do not really have version control about the changes you are doing manually. By infrastructure as code and making these changes in infrastructure as code as well, you can move back to specific versions of your infrastructure. Reusability, so you can really reuse components you create. So for example, if you sometimes create a VM template, you can reuse it at another place, another time. Sometimes, depending on the choice you have made, you can also use it on another cloud provider as well. Repeatability, so you can really easily repeat the things you are doing. So moving from a dev to a production environment is really made easy for you, because you can just deploy the same template to the same environment, making sure that everything you have saved in the dev template will be moved exactly the same to the acceptance and the production template as well. So it also gives you the ability to create resources according to strict rules and remove human errors. So I've been working with a large enterprise for a long time now. And basically, they have strict rules about resources they spin up in the Azure platform or on-premise itself as well. By using infrastructure as code, you can really make sure that everything that's specified within those guardrails you need to obey to are implemented in your infrastructure as code. This way you make sure that when you deploy an environment, you already obey to the strict rules they have, really making sure that you have a certified product that you can use and reuse within your environment, and not having the hassle afterwards of getting a security incident and everything else. Basically, the last one for this list is the configuration drift. Configuration drift is specified here is that in a lot of environments, moving from dev acceptance to production, or moving in a different way as well, is that people always do manual changes. You really should not do any manual changes and don't click around in the portal making changes to your environment. No, you should always do that in your infrastructure as code, really making sure that you can have that same template and move it from environment to environment. When looking at infrastructure as code against the Azure platform, you work with ARM templates. And basically how Azure is structured is Azure has the Azure Resource Manager. With the Azure Resource Manager, everything with handling resources and everything else in the Azure platform is basically handled by one specific layer. Meaning that if I use the CLI, or when I use the PowerShell, or even the SDK, the REST clients, and the portal itself, the communication to the backend within the Azure data centers is all done in the same way, because all those communications are going to the Azure Resource Manager. Meaning that if I create an ARM template and deploy it to Azure, it goes directly to the authentication authorization model and then to the Azure Resource Manager. And depending on the resources I will be creating, it goes to specific resource providers. Meaning that the authentication all goes to the same way and the template moves the same way as well. But where then comes Bicep? So what is Bicep then? Bicep is a domain-specific language. Domain-specific language you already all may know is HTML. And basically, Bicep is a transparent abstraction over ARM. Meaning that if you have a Bicep file, you can translate that Bicep file to an ARM template. That's basically also what the tooling does. So you create a Bicep file, and when you do a build command for your Bicep file, it will construct or compilate to an ARM template. And basically that ARM template is later on used to deploy your resources. Bicep now has a one-to-one capability with ARM. So you have the same capabilities that you have within ARM, and we have Microsoft production support, meaning that as the version of Bicep is still at 0.4 at this moment, and not at a 1.0, but Microsoft already supporting Bicep files. So basically everything that's generated via Bicep is supported by the Microsoft platform itself. And basically on the right side, you can see how that system basically works with the Azure Resource Manager. So you have an Azure Bicep file, and by using the Bicep commands, you build an Azure ARM template. And basically that ARM template can be used during your deployment. But why should you then use Bicep? What is the reason why you choose Bicep and not, for example, use ARM like you already are doing? So basically, Bicep is much simpler. The syntax itself is much simpler, and it's much easier to write as well. Basically, in Visual Studio Code, there is a lot of tooling now already available that helps you writing those Bicep files and making it in a structured way. Next to that, a Bicep file itself is much easier to read against ARM, because ARM has a lot of characters in it itself, as it is a JSON file. It's much harder to read. Very large templates, yeah, that's a positive point for Biceps, because you will not be getting very large templates. It's basically a downside of ARM, where if you have a large environment, you will get a very large ARM template, or you would have to start using linked templates and save those linked templates on a public location. By using Bicep, that's not necessary anymore. But let us just jump to an example. So for example, what you can see here now is that This example just shows you a storage account. This is a out-of-the-box ARM template that can be used to deploy a storage account. You can see that already for just a storage account, I already have 33 lines with not a lot of information because it's just a regular standard storage account. So if we would do this in Bicep, it would be a lot easier. So if I just create a new file, and let's call it storage.bicep. We first of all, like we had with the other one, we had a parameter, and let's name string. We have a parameter, location, string. We have a default value as well, resource group, location. You can already see that I'm very easily writing up a new Bicep file, and I already have 2 parameters. Now I just need the resource. So basically, if I just type in resource, let's call this resource storage. And you can already see that the intelligence is helping me of getting the right resource. So let me just take storage, and then you write API version, and name. That's my parameter name. Let me just use the intelligence. That's a typo as well. Let me just correct it as well, just to make it nice and clean. SKU. Let's set this up. And let's give it. In just a couple of seconds, we have created a new template that deploys your storage account. Regularly, if I would have needed to do this within ARM, I wouldn't have done a live demo because that's basically terrible to do and terrible to start. You are missing characters and everything else. Basically now with the use of Bicep, that's made it very easy. And very easy to start with, very easy to deploy, and also using that intelligence that you already have in Visual Studio Code. To dig deeper into Bicep, let's jump back to the slides and just go through how to get started. Basically, Bicep needs to be installed because it's cross-platform tooling that you need to add to your system as well. You have different options to get it installed. So you can just use the Windows installation. For Chocolatey, you have a Windows installer available on GitHub as well, if you look at the Bicep repository. So it's very easy to start. But the easiest option to get started is basically the PowerShell integration. And I will get into that later on. The other thing you also need is Visual Studio Code extension. The Visual Studio Code extension is really required for you to get started with the Visual Studio Code, making sure that you have that rich intelligence to get started and write your own templates. So if we look at the tooling, and like I mentioned before, the tooling itself is integrated within PowerShell, and it's also integrated within the Azure CLI as well. So you do not really have to reinstall the Bicep components itself if you have the latest version of the CLI or PowerShell. But Microsoft will make sure that when you start using the comments that the tooling is downloaded to your local system. So, but how do you then use the tooling? Basically, the toolings is the same within the Azure CLI and PowerShell, only you have to prefix them, of course, a little bit different. But if you look at the Bicep executable itself, you have the possibility to use 4 comments. So you can use the build comment, basically specifying Bicep build in your Bicep file, and that basically constructs your ARM template. So if I would perform the first example, it would construct me an ARM template called file.json that contains my complete ARM template. We have a Bicep decompile JSON is a decompile method. So all of you may already have started with creating ARM templates and maybe are thinking about jumping over to Bicep, but how do you then jump over? you can make the very easy step to just use the bicep decompile method. Basically what it does, it constructs a bicep file from your JSON. And I will show you that later on in the demonstration as well. Next to that, you also have the restore and the publish comments. And that's basically because of a new functionality they have added in the 0.4.1008 version that was released last week, that you can use to have private repositories. And I will get back to that later on in the presentation. So like I already mentioned, you have the integration with PowerShell and CLI. The only difference there is that the full integration is only available in the CLI. So you can use AZ bicep build or AZ bicep install to install bicep. Then you have to have version 2.20 or later for the CLI to work. And you also have the capabilities to directly deploy your bicep files to Azure, meaning that you do not supply your JSON file at the deployment comments. No, you supply the bicep file. One good thing to know here is that when you just specify your bicep file as the template, what the tooling does, it constructs the ARM template locally on your system and then supplies that ARM template to the Azure Resource Manager. So technically on the Azure side, nothing really changed because you're still supplying your ARM template. The only magic that's happening is basically on your local system. So on your local system, you are constructing that file and then supplying it to the Azure resource. So let us jump back to Visual Studio Code and let me just show you some small things. So we just created this storage template that basically deploys a storage account. So we have bicep here. So let me jump to that folder. Templates. And do a bicep build. And then I call it storage of bicep. See that it's almost completely ready. And the only downside is that I already had a storage.json file. So it just overwrites the file. And what you can see here happening is if we just do it over, you can really see that it works. You see the storage JSON jumping in. You see the metadata tag that's just for the changes that Bicep knows that there are changes. And then you see that it constructs the parameters, location, and the resources.
Hey, Mike, sorry for this. Can you zoom in a little bit?
Yeah, of course. I totally forgot. So
yeah,
what you can see here is that it constructed the JSON on the fly from your Bicep file. So basically moving from the 10 lines you have in Bicep to 33 lines in ARM. What we can also do is if I just remove the storage.bicep, and now I only have a storage.json in my folder, like you can see here. I only have a storage.json in the template folder, and let me do a bicep decompile and storage. Type it correctly, JSON. See some warnings coming in. And you see that I now have a green file called storage.bicep. And if we open it up, you can see that it's constructed a storage.bicep YAML file that basically contains my storage account. So it's very easy to use the comments of Bicep and get started with building your components. So if we jump to what's then specifically in a Bicep file. So we already know that we have ARM, we have parameters and everything else. Basically the same structure applies to Bicep. The only difference within the structure is that everything in ARM needs to be grouped. So you have to group your parameters, you have to group your variables, you have to group your resources, and you have to group your outputs. For Bicep, that isn't important. So if you want to specify your parameters with your specific resource, that's okay. So they do not have to be on top of your Bicep bicep file, so they can be with your resources. That's the same for your outputs. You can specify the outputs anywhere in the file you want. And basically, if you look at the structure, you already have the same components as within ARM. So you have the parameters, the variables, the resources, and the outputs. But you also have the module section. And we'll jump to the module section later on. So if you look at the parameters, it more or less works the same as within ARM. So you have the default value possibility where you have the specification of a parameter. In the example, you can see that we have a parameter location of the type string, and that is resource group.location. So by specifying the is character, we are specifying a default value, meaning that if someone supplies a different value as a parameter to my deployment, that default value is being replaced with that value. So you also have the allowed values, where we can specify an allowed attribute with the specific parameter values we want. And you can also combine it, of course, with a default value. You have a secure value as well. The length constraints. So you have a min length and a max length. You can have a description on each parameter, and you can have an integer value constraint. So basically a min value, max value, more or less works the same as the min length, max length, but then basically for specific values. Next to that, you also have the metadata, where you can specify custom metadata of your parameters. So for example, if you want to have additional descriptions for your parameters, you can use the metadata tag as well. Moving forward to the bicep files and what you all have in there, one important concept of bicep files is scopes. So as you may know, and not everyone knows it in the Azure world, is that you can deploy resources on multiple scopes. That's also possible with ARM. So you can deploy the subscription scope, you can deploy the resource group scope, but you can also deploy the management group scope or even the tenant scope as well. That's basically all handled within Bicep by specifying scopes. By default, if you create a Bicep file, it's scoped to the resource group. That's also the default scope of an ARM template. So if you specify a scope in your Bicep template, so for example, you specify target scope as subscription, everything that's in that Bicep template will be deployed at that target scope. And you can even specify the target scope management group or even the tenant level as well, as specified here. But then, for example, if you have specified that scope, you also need to do that scoping, of course, on your additional resources. So what you can see here is on the right side, we have a storage account and we have a log. So basically we have an authorization log. And on that authorization log, you can see that I've specified a scope, storage ACC, basically referring to the storage account, meaning that this resource is scoped to the storage account and that the authorization log is deployed on that storage account by specifying the scope. Even for modules, you have the same thing, and we will get into the modules in the next slide. But for a module, you can specify a scope, meaning that, for example, if you specify a target scope of subscription on your Bicep file, you can you can create additional resource groups, for example. So you have a Bicep file where you create multiple resource groups, and then you can scope your specific resources to a specific resource group in there as well. So then, I already mentioned them a lot of times already, Bicep modules. Bicep modules is a way within Bicep to make, reuse your code. So basically, if I write a storage template, a Bicep file for a storage account with specific properties, specific parameters as well, specific configuration, I can save that Bicep file as a module. A module itself within Bicep is not more than just a simple Bicep file, so it's exactly the same. Only you then have the capability to reference a module from a different file. So you can really easily link bicep files together in one main template. So what you see arising in many situations, that I've seen it as customers as well, is that you create one main .bicep file that references additional bicep files, aka modules. So basically, a module is a contract to other files where you have the capabilities of using the parameters and using the outputs. And when they are deployed, they are just nested deployment resources. So what you already have seen, of course, in ARM is that when you want to link ARM templates together in the old way, you would, for example, create a storage account, deploy an ARM template on that storage account, then generate a link with a SUS token for that template and integrate that into your ARM template, just to make sure that you not have that large ARM template. So you build up an ARM template with a lot of references to just public locations that basically, if someone knows the URLs, they can reuse those templates as well. With Bicep, that isn't needed anymore. So you just have local references to your Bicep files, and you can incorporate them into your template. But now on to the next best thing, in my opinion, is that they just released it. I think it was last week or the week before that as well. And if I'm not mistaken, it's still in preview as well, is that from version 0.4.2008, you can now use external/shared modules. So you have the capability of specifying modules, Bicep modules, and deploying them or publishing them to an Azure Container Registry. Or basically, when you use template specs, you can use Azure template specs as a module within your Bicep files. The greatest thing about this concept is that role-based access control is applied to all those resources. So for example, if you look at an Azure template spec, I can apply RBAC rules on that resource to make sure that not everyone in my organization can use that template spec. The same applies to the container registry. So you need to have access rights on that container registry to retrieve that module and use that module in your Bicep files. So you have a very easy way of sharing your modules, and you already created Bicep files within your organization so that they can use those modules and use that in their own modules to deploy their own applications. To give you a practical situation, I'm working with a large enterprise, and we are really looking at certifying services, meaning that we have, for example, an Azure App Service, and the Azure App Service needs to be configured in a very specific way. But I do not want to rewrite that ARM template every time I need an Azure App Service. And as it's a global organization, you can also start sharing it on an internal website or something else. Then you have to give people access to that, and you have to maintain an additional location. By using, for example, a template spec, I can just use the Azure platform, can give the appropriate teams access rights on those template specs, and they can just reuse that certified products. But as you are using a template spec, you also have a production resource. So you also have to manage that as a production resource, meaning that you have compiled that as well, meaning that you have a very good and easy way and a regulated way as well of version controlling your certified products. You can also deploy additional versions on top of that as well. So that's a good new thing. In Visual Studio Code, you also have a linter, really making sure that everything you create is according to best practices. Basically Bicep best practices. So it really helps you writing your files and making use of new functionalities that you have in Bicep. So for example, in Bicep, you can now use string interpolation as well, and you should not use the concat function anymore. So you can see that here in the slide as well, that I should have used string interpolation instead of the concat function. So now let's just go to Bicep and Visual Studio Code and do some nice things. So we have discussed a lot of things already. Let me just first start with the linter. So for example, I have a bicep file open here that deploys multiple VMs. If I look at the command palette, I can already see that I have a lot of problems. So I have about 5 problems here that I can very easily change as well in my file. So I can see here that I have some variables that are not declared or not used. They are declared, but they are not used. I should have used string interpolation instead of a concat function, and my resource group is not working as it should. There are differences there in the API reference. So what I can do here is the variables not used. So it gets me to the same section. I just remove them because they are not used. And then the problems are away. For the string interpolation, I can just click on the light bulb and it gives me an example. And if I click on it, it will directly change it in my bicep file as well to make use of those components. Basically, the resource groups problem is because I'm using the wrong version. So if I change the version, you see that Visual Studio Code is really helping me in getting the right version in there. So I can just click tab. And click tab. So you can see here as well that now the scope is red. And that's basically because it's a wrong scoping. And it's not anymore required on the resource group because I have chosen the target scope subscription. I do not have to supply the scope, so I can just remove it as well. Meaning that I now have a good bicep template, and it's just pointing me out that there's something wrong with my storage JSON. What we also have, if you look at, for example, this bicep template is a bicep template that contains a complete web infrastructure. So it's a web infrastructure that is building up an Azure App Service, an App Service plan, that also has some login configurations, all in one template. Just specifying this, if I would have done this in ARM, I would have an ARM template of maybe 200 lines. So if we look at some scripts, we can just do a nice deployment. So let me do the right one. So let's go to the right file and then just the key. So you can see at the 001, we will just build the web app that inside the bicep file, and we can do a new resource group deployment on our infrastructure. So if I just run this selection, the bicep file will be built. So you can see that the JSON file appears now on Visual Studio Code that has about 150 lines. And it's basically the complete same configuration as we have. If we jump back to the PS1, we can now also run the Azure commands. So you can see here that I'm referencing the same JSON file, and I'm just creating the template as well. Let me just run the selection. This load by policy, that's good. That means my policy engine works. Let me just set my context to the right subscription. So to give you a small idea what's happening on the background, let me just run this because this takes a couple of seconds as well. This should work now. Yeah. I have multiple subscriptions in my environment, and I have specified a lot of policies on my subscriptions itself as well to be able to keep my subscriptions in some kind of management state. And I have one subscription that's called Subscription NPM Sandbox. And that's basically my own sandbox subscription where I can just deploy everything I want in the naming conventions that I want. And what you saw happening on the other one is that I was deploying to a subscription that was still in my context that does not allow a specific resource group called sp.-bicep-001. So you can see here now I've kicked off a deployment with these two scripts with some specific parameters for my website. And I'm just now using a regular ARM deployment method because I'm still referencing the JSON file. So if I now would look at my Azure platform, and I have that one here. If we just go to the resource groups, I should have an SP. Oh, it's still. That happens sometimes. It's not there yet. Not in the UI. Let me just move to the subscription then. Because the resource group was already created. I saw that on the PowerShell script, but it sometimes takes a while for the portal to just show everything else. So you have to believe me that the subscription, the resource group is there and that it's being created at this moment. So I will show you that later on in the portal itself as well. And let us just keep this one running. I think it's now just running because it has a lot of resources. Let us then step to 002, and that's basically the use of a module. So basically what I've here in my project, I have a subfolder called .modules, where I save my local modules. So you can see here is that I have 4 modules and all for specific situations. So I have a module for a storage account, a module for an Azure App Service, a Linux VM, and a virtual network as well. So I can really easily reuse these components in my bicep files to deploy very easily a storage account with specific configurations. So if I look at the module, it's just as simple as well. But for example, if I look at the Azure App Service, it's more or less different. So you can see here the linter again that I should have done it in another way. But for example, in this module, I have multiple resources to deploy an app service environment. Basically completely pre-configured with the instrumentation key and everything else. What you can see here as well is that referencing properties of different resources is made very easy. So you can see here is that I configure an app setting on my app service for application insights. And I'm just referencing the resource app insights. And let me search it up. It should be somewhere here in the template as well. Yeah, so I have a resource app insights. And I just ask for the properties. And what you can see here as well, I have complete intelligence. So I can just ask for the properties and then say, okay, I want the instrumentation key. What the system does underneath is that it also creates the dependencies. So you can see here that I have specified them explicitly. That isn't required because Bicep constructs those dependencies itself. So Bicep knows, okay, I will be deploying this resource. But for this resource, I am using the App Insights resource. So I need to construct a dependency when I construct the ARM template. So that's totally done for you. But sometimes I like it to do that explicitly so that I see it right away when creating my services. Jumping back to the module part. So I have basically a file with multiple resources. I call it a module, and I can fairly easily use them within my templates. So I have a Bicep file called use module, and I can just type in module, and let me just call it a web app, and do a file reference. More or less, normally you would say the resource type. So like you have seen in the first demo, you just specify a resource type and then use that. But now we are just going to use basically a file reference. So I can use the file reference for the app service. And then is basically now I've done this. You can see here is that the reference module has errors. Okay, that's basically the linter coming in. But if I stand on web app, I can also see which properties I still need to declare. So you can see here that it's missing required properties, name and params. So if I just specify a name, let me just do something. Use the type ahead as well, and that's parameters. And basically what you see here now, I have to supply 4 parameters. And if I look at the module that I had, and look at the parameters, I also had 4 parameters. So it has complete intelligence to your module file, making it very easy for you to reuse your resources. So if I specify those, reuse location, SKU, and SKU name. You can also see that it's bugging me about the SKU capacity, that it should be an integer. So let's supply an integer and then it's fine. You still see the red lines because the module isn't fine, but we step over that for now. So it's very easy to reuse your components by creating your modules, specifying all your resources in that module, and then reusing that in a main template. What we also discussed is basically external sharing and having external locations where your modules are saved. So you can see here that I have 2 examples in here. One that's using a template spec and one that's using a storage registry. What to notice in here is very important. So you see the BR, that stands for Bicep repository. And it's referring to a Bicep repository with the alias sponsored registry, and then basically the path to your specific Bicep module. Same applies for the automation. So you have TS, that stands for template spec, then the alias of my template spec, and I will show you the alias later on, and then basically just the name of the resource and then the version. So I've mentioned aliases a couple of times. So if we look at the bicep.config that was introduced with the linter as well, and where you now can specify your module alias as well, is that you have a module alias. So I have a module alias called sponsor registry that's just pointing me to my Bicep registry. And I also have a module alias for template specs called template specs, and that's just pointing to a specific Azure subscription with a resource group. Meaning that, for example, if I specify a module in my template pointing to one of those specific locations, what happens underneath is that the Bicep tooling will download the module itself, or will download the template spec itself, saves it in the local cache of the system, and then gives you complete intelligence. So let us just try that for a template spec. So we have an automation template spec here, and let me just do another one. So let me just do a module template spec, specify DS, specify template. I hope now that the private preview will work with me. And let me just get a template spec. So I need to go to my subscriptions. I have a template spec on this subscription because I normally always construct all my resources via templates and template specs. So you can see here that I already have a lot of template specs in here as well. And let us just use an internal app service template spec. Let me copy that name and let me check the latest version. It's 03. So let's move back to my Bicep, paste the name, do the correct version, 03. You saw the resource itself jumping from a red underscored line to just a regular name. Means that the red underscore lines means that, okay, I do not have this template reference in my local cache. And when it jumped off, it has already downloaded the template spec, and I now have complete intelligence. Because you can see here now, if I just stand on this one, I can see that I have required properties, names, and params. So if I just do the name, that's always required, template, and go to the params. So then I can see the parameters of my template. Oh, let me just type it correctly then. Yes. And now I have complete intelligence for my template spec that lives in Azure. So I can see all the parameters of my template spec. And to show you that it's true, let's move to the template spec itself. And that you can see here that I have those parameters all specified in my template spec. Meaning that I get complete intelligence of things that live in Azure that I can reuse within my Bicep file. making it very easy for you to use Bicep and also reuse components you already have somewhere in the platform. Good point to notice as well is that you should have those access rights, of course, on the environment to make sure that you can connect to those resources. Regarding the registry, so you can have a container registry in your Azure platform. So I can show you that one of mine as well. Let me move to correct subscription. I have a resource group called sponsor minus Bicep. And in there, I have a container registry. In this container registry, I think I now have one repository. Oh, I already have two with minus/modules/storage account, and I have a bicep/modules/vnet. So I have already pushed 2 modules to this repository, and that's basically where the other comment that I showed you on the template comes in. So when you have a module, you need to have a way to publish that module to your repository. So if we look at this comment, you have a Bicep publish comment that references the module file that I want to publish, and then basically just specifying a target. So that's basically the path that you want, and you have a version. And this is basically just my container registry. Made it very easy. So you can really reuse the system and reuse those components as well. So that's about modules. And if we then also look at an example for scoping, you can see here that I have a template, a Bicep template with a target scope subscription. So I'm just scoping this template to a specific subscription. With the comments of giving me the capabilities of creating resource groups, and not only creating resources, now I also want to create resource group. So I can specify a specific resource of the type resource group to make a resource group, and then I can scope it to a specific subscription. And then, for example, if I would like to have a storage account in that subscription, I can just specify, I now have the module because I reuse the components, and I specify a scope app.rg that basically references to this resource, and it creates a resource group with the specific storage in there as well, making it very easy for you to start and construct all your resource groups in basically one Bicep template. Another good thing that I want to show you is that if you have worked with ARM and have worked with ARM a lot, you know you can have for loops and everything else as well in ARM. They are really, in my opinion, they were hard to do in ARM. Within Bicep, that totally changed as well, making it very easy for you to just work with arrays and for loops to deploy multiple resources. So what I'm going to show you is an example of a Bicep template that creates a resource group. And in that resource group, it will create multiple VMs, depending on how many VMs I specify. And basically, the Bicep template itself will create 2 resource groups. So you can see here is that I have 2 resource group resources, up.rg and up.rg vnet. And basically, the up.rg will be used for my VMs, and the up.rg vnet will be used for my vnet for the VMs itself. Then I have a module, and that's basically referencing to my Linux module that I have for my Linux VMs. And I just constructed a for loop. So I have specified the VM items. That's basically a parameter of the type array. And I can just do for VM item in VM items and just do this. This basically means that if I specify 4 VMs in my VM items array, it will perform this command 4 times, meaning that it will construct the VMs and configure them as they should be. You can see here that I'm also referencing my VM VNet item. So it basically also creates the VNet in my specific resource group for my VNet. So if you look at the options that you have for deploying it, that's the 004 version. Let me just use the 005. That's more easy. So you can see here that I have a 005 with multiple VMs from an array. I just do secure password. Don't mind the password. It will be changed later on and the resource will be removed. And I have an array of VM items. So I specified 3 VMs. Bicep 001, Bicep 002, and Bicep 003. And then I do a new AZ deployment. So I do not do a new Azure Resource Group deployment. No, I do a new AZ deployment because I'm scoping the subscription and I'm not scoping to a resource group. And basically what it will do, it will just deploy that to my subscription. So if I do a Bicep build, it now has my JSON file. And now I just do a run selection of this. And basically what now happens in the background, the ARM is constructed, ARM is sent to the Azure Resource Manager, and everything will be created in Azure. So to get back to basically the first demo, because I hope that it now shows me the resource group that we created. Yeah, you can see the SB Bicep 001 that now contains the app services. Good thing to notice as well is that as we used modules, you can also see that I have a name of 001 Web App Insights. So you can really define the naming of your deployments as well, but you also need to make sure if I redeploy the same Bicep template, the name is replaced. And basically what it uses to these deployments is, if we look at the 001 we deployed, right? It uses just the standard deployment name. When using modules, for example, you will see deployments coming through with the name storage account external, automation spec, temp spec. Those items will be used as the deployment names. So I'm hoping that maybe it already shows me. Yeah, it already shows me the other 2 resource groups. So you can see here that the SB Bicep 005 appeared and the SB Bicep 005 VNet appeared. And the VNet is already done, where I can also see that I have 1 deployment. And that's basically what I meant. Basically the name specified in the Bicep template is saved here as well. So this contains the VNet for my VMs. And if I just move back to the 005, you maybe can see that we already have some VMs. You can see here that I do not have all VMs. And the nicest thing to see here that the 001 and the 003 are already finished. And I'm not sure what he's doing with the 002, but that will be coming in later as well. You can see here that for some reason, the 002 version took some time longer to create, but it's already there as well. So really making sure that it's easy to use the components itself as well and deploying very easily. So then I only have to discuss one thing with you guys as well, Bicep CI/CD. So basically, how do you then integrate your Bicep files within your CI/CD pipeline? And basically, the answer is very easy. You can just use the command line tooling in your Bicep, from your Bicep in your CI/CD pipelines. So I have an example for that as well. So basically, I have an example in GitHub Actions. So like I've mentioned before, I write everything that I deploy mainly in template specs. And basically, how I do that, I have a repository in GitHub where I have template specs, which you can see here as well. These are specified template specs. And basically, I do not specify my template specs in ARM. No, I specify them in Bicep. So for example, I have a Bicep file for a secure database that deploys a secure database with a VNet connectivity and a private endpoint, for example. What I do if I make changes to this repository and, for example, to one of these templates, I just run a GitHub action. So I have several GitHub actions specified here that just deploys my template spec to Azure, meaning that I will have a new version of my template spec there. And if we look, for example, at one of those items, you can see that it's very easy to integrate Bicep into your components as well. So you can just see here that I have basically just the default configuration for a GitHub action, and then I have some specific steps. So I have a specific, and that's basically just get me the latest version of Bicep and install that on my agent. Basically what I then do is I run a Bicep build. So I build my Bicep file into an ARM template, and then I archive. Why do I do archive? Because in my continuous integration, I want to have an ARM template, because we will use that, and that's basically my production resource. So if I want to move back basically to a previous version, I want to be able to look at the archives and retrieve a specific version. So I archive those and I upload that artifact, and basically then I do a deploy action. In that deploy action, I just retrieve my ARM template that is specified in the archive. I log into Azure and I just create a new template spec with a specific version, making it very easy for you to integrate Bicep in your CI/CD pipelines. I think in the meantime, there were also some people that already created some extensions as well to make it even more easy. But I think using this component is also very easy, just installing the Bicep agent and reusing it as well in your templates. Back to the presentation, as we are almost running out of time. So I have some resources available for you that you can use to get started and get started for reading. So you have the Bicep GitHub repository. That's basically the repository for Microsoft, where they constructed Bicep, as Bicep is just an open source project, of course. Some documentations, my personal repo, so you can go to github.com/mikevandergaag/bicep to read all the Bicep files that you have seen in the demonstration. And if you look at my other repositories as well, you can also look at the platform repository, for example, because there's a lot of Bicep in there as well. And then there's also a Bicep playground. That's basically a playground where you can start with doing your Bicep comments and start working with Bicep as well. Then, of course, the sponsors of the event, learning partners, and the communities. And then I think maybe we have time for some questions and answers.
Yes, Mike. So let me jump on to the first question. How do I use bash in the terminal to apply commands? Do I have to download a bash package in VS Code?
You want to use bash in VS Code, if I understand you correctly.
Yeah.
Yeah, I'm not sure there. I really don't use bash. I only use the terminal integrated into Visual Studio Code itself as well.
Mm-hmm. Okay.
It's basically in there by default.
Okay. And the second question is, can we use ARM Bicep for setting up alerts?
Yeah, basically everything that you can do within ARM can also be done in Bicep. There's a one-to-one capability.
Perfect. And there are certain conversations going around bash inside VS Code. That's fine. So considering the timeline, thanks a lot, Mike, for your valuable time and valuable insights as well. And so I request the audience to submit the feedback using the link and the session code, which will be shared which already been shared. And let me share it once again. Thanks a lot, Mike.
No problem. Thank you guys for the great event.
Thank you. Hi, Maurice. How are you today?
Hi, how are you today? I'm fine. Enjoying rather unusual nice weather in the end of October for the Netherlands.
Okay.
Yeah,
Good,
usually
good,
we
good.
have rain and wind, but today it's actually sunny.
Oh, is it good to hear that? And in Chennai, it's rainy today.
Ah,
Yes. And hi, everyone. Morris is going to explain about building a reliable applications with the React and C Sharp and Azure. I hope definitely it's going to be very intuitive. And to give a brief introduction about Morris, Morris is an independent software consultant and trainer. He specializes in TypeScript, React, ECMA scripts, and ASP.NET Go. And apart from the development, he teaches ECMA script, TypeScript, React, and ASP.NET courses. So since 2005, he has been continuously awarded as an MVP from Microsoft. So that's really amazing. Almost it's now 16 years, right, Maurice?
I think so. I kind of lost track. Actually,
Ah,
I have, yes, 16 stacks of one of those discs for my MVP awards.
ah, okay, okay.
You know,
And
they
Maurice
get
is
stacked. I actually had to go around the corner.
yes, yes. And Maurice is also an active in Dutch.NET user group and helps to organize a lot of meetings in Netherlands. So with that introduction, I'm leaving the stage to Maurice. Maurice, it's all yours.
Okay, thank you very much, and welcome everyone to this session on building reliable applications using React. As you just heard, my name is Maurice de Beyer. I'm not going to introduce myself again, but I'll upload these slides to SlideShare later and I'll tweet them so you can find all about me later if you want to. So, the title of the session, what are we going to talk about? Well, I'm going to talk about building reliable applications, and there is actually quite a lot to talk about. So I've kind of made a pick going from different things, some of them technical, some of them development focused, some of them runtime focused, some of them more workflow focused, all sorts of different things. So on the front end, I'm using React. But even though I'm using React, if you're using Vue or Angular or any of those front-end JavaScript frameworks, you're going to run into pretty much the same issues. So it's not specific to React. On the back end, I'm using Azure. But even if you're not using Azure, this is an Azure conference, so I'm kind of assuming you are. But suppose you're using one of the competitors. Sorry if you are, but the same kind of things will apply there as well. So pretty useful. Now, one word of caution, all of this is opinionated. It works for me, and it's not like I do this all the time with every application. Some things work in some scenarios, but don't work in other scenarios. So it depends. But it is opinionated. Take what you can use from this. And if something doesn't suit your use case, don't do it just because I said I'm using it, but well, keep an open mind there. But before I start with Azure, I want to start with cheese. And that's because making cheese and making software is actually, well, not the same, but related. Making cheese is kind of hard. There are a bunch of steps you have to take, and if you make mistakes in one of those steps, your cheese is going to end up being pretty much unedible. So you have to be precise. And some cheese is made in a very artisanal way by a farmer. Like I live in the Netherlands, and close by we have a number of farmers that make their own cheese. But it's also made in large factories in big quantities. Now, why cheese? That's actually because of those holes in the cheese. There is this thing called the Swiss cheese model, and that describes a way of preventing risks. And the way I look at software, it's all about preventing risks. What's the risk? Well, something in production goes wrong. There is maybe a bug, maybe something wasn't deployed right, maybe there was some internet connectivity dropping at a moment in time where you thought it would be up and you're trying maybe to save some data and the server is not available. Well, there are lots of things you can do about it. And the way you should think about it, the way the Swiss cheese model works is everything has hazards, but you can build in layers to prevent those hazards. And they use the Swiss cheese model because this is kind of based on a slice of Emmentaler cheese, which has big holes in it. Now, if you've got one layer of cheese, you'll prevent some issues, but lots of them will run through and you'll run risks. So you can add more layers and you'll catch more potential errors and you'll have fewer bugs in the end. But there is a drawback there. If you add too many layers, you'll make everything, well, difficult. And in the end, you won't be able to do anything because there are too many procedures and error checks and things to go through. Now, if you want to prevent all errors from ever happening in production, the best way is to put up so many layers that you'll never go to production, because if you're not in production, you won't have any errors there. Of course, that's also not very useful, because if you don't go to production, you won't have any users using your application. So you kind of have to find that balance there. But a lot of the things I'm going to show you are slices like this. They catch some potential errors, but not all. And if you combine them in the right set, which applies to your situation, then you're going to catch most, not all, but most errors before they reach production, and your end users are going to be happy and be able to use your application. Now, the first one I'm going to use is TypeScript. Lots of front-end developers doing React or Vue or one of those things use TypeScript. Use JavaScript. But you can also use TypeScript, and I would highly recommend going to TypeScript. As the TypeScript website describes it, TypeScript is really typed JavaScript at any scale. So you can create small applications with it with relatively little overhead. You can start using more of TypeScript. You'll get a bit more overhead, but you'll get a lot of additional type checks there as well. And there are language features like type unions, tuples, optional chaining, etc., which will really help a lot. And I've got a sample application here, and let me show you a few of those. I've got an account component here, a bank account. And this does an AJAX request. Where is the AJAX request? Right here. It fetches some data. And then when this initial renders, that data returned is going to be undefined because it's not there yet. So I could go do lots of checks, but with a real simple operator here, the coalescence operator, I can say, well, if accounts is an array, I can map over it. But if it isn't an array yet, well, it's still undefined. Don't worry about it. Don't throw an error here because I'm trying to run map on something which isn't an array yet. Just ignore it and potentially return something else. In this case, I'm not returning something else, but with the null coalescence operator, I could say, well, return an empty array instead, or maybe something completely different. Makes it really easy to check these things. Now, some of these will work in JavaScript, but quite a lot won't. Now, there are cases where I've worked on projects where we really should have used TypeScript from the start, but they didn't. And there is one way you can switch from JavaScript to TypeScript relatively easy. There is this way where TypeScript can actually start type checking JavaScript. And that's if you start adding JS doc comments to your JavaScript. You install TypeScript, you start adding JS doc comments describing your JavaScript code, and TypeScript will use that to check the code. That means you can start combining TypeScript and JavaScript without first having to change everything to TypeScript, which is potentially a lot of work. Now this works relatively well. I would recommend starting with TypeScript, but if you join a project, they're already started with JavaScript, and you want to switch to TypeScript, great, do it this way. Another great thing with TypeScript is you can create all sorts of map types. This one, for instance, is very useful. I've got a React component. I need to know about the props I can send to it, so the arguments that that component expects. I want those typed. Well, I can just extract the types from that component. I've got a function. I can do the same with the TypeScript return type. I can ask, okay, what is the return type of a function, or the parameters being sent into a function. So TypeScript will be able to infer things like that from components, from functions, using a mechanism called map types. So it takes a type of a component, a type of a function, and returns me a new type. And there are also very useful map types like read-only. I've got a type of person which has a first name, a surname, and a date of birth, for instance. Well, give me a read-only version of that which can't be changed. Well, with the read-only mapping, I can create a new type based on the original type. I add a property to the original type, well, the map type automatically has it. I've got a type, but I only need a part of it. I can use partial. There are lots of examples like that. There are lots in the standard TypeScript library. There are lots of other libraries out there which will let you do that. But they're actually relatively easy to write as well. One thing you can do with them, which is really powerful, is opaque types. And I'm not using map type in this example, but I've actually got another example here in code, which does so. So over here, I'm saying I've got an opaque type, turn a number into an opaque amount type, or here, or a whole person object. Now, why would I want to do that? Let's take a look at this code. I've got a transfer amount here where I want to transfer some money to a bank account. And it takes two parameters, an account and the amount I want to transfer. And down here, I'm calling the function, and this all compiles fine, no problem. Except there is a problem. It's a little hard to spot if you just glance at the code, but if you look more carefully, if I hover over this, you see that the transfer amount function takes an account as the first parameter and the amount as the second parameter. But I'm actually calling it with amount as the first and account as the second parameter. So they're flipped around. But amount, account, very similar. So you actually have to look at this properly to see the difference. The words are pretty similar. Now, that's because both of these are numbers. But suppose I said, well, I've got an amount type and the amount is here. So we'll put that in here and I'll turn this into an account type. And we'll say that this number really is an amount and this really is an account. Now all of a sudden, TypeScript starts complaining here and says, well, the type of amount is not assignable to the type of account. They're not the same. And now TypeScript will tell me, okay, flip those around and we're all good to go, which is a really nice feature. Now it's again one of those things like, do I want to change all of my types, never use primitive types, turn all of them into opaque types like this? Should this first name and this surname, should those be a special first name and surname type, and the same with the city and the date of birth? Probably not. Probably for the more important fields, like an account and amount, where it's easy to flip them around and do the wrong thing, yes. But for all sorts of strings where there is no specific business logic attached to it, it's probably overkill. But you certainly can do so if you want to. So it's one of those things where use it where it makes sense, but don't use it just because you can. Another thing when you're working with the front-end code is use ES modules, and specifically use named modules. So React is actually going to switch away from the currently used default modules. So right now, what you do with React is this bottom one. You do import React from React. And a lot of people do that with their components as well. Import some component from some file. And that works perfectly fine, except it tends to lead to errors. Suppose I go to my component, I've got a single account component here, and I'm exporting that, but I'm not exporting it as a default export, I'm exporting it as a named export, which means I have to use it as a named export. Suppose I rename this, I call this single account EX. I go to bank accounts, and we can see up here there is a compile error. Single account has no exported member name single account. So the first single account is the file, and it says, did you mean single account EX? Because it actually is smart enough to do so. Now another benefit, let me undo this for a moment. In Visual Studio Code, if I press F2 or do the rename refactor action, if I rename it this way, I've done the same rename, but Visual Studio Code is now smart enough to know, okay, you were using it over here. That's the same thing, so it's renamed it here and somewhere down here where it was used. Where is it? Right there. Now, if I was using default exports and imports, I could export it using one name, import it using another name, and it's a lot harder to understand and a lot easier to get mismatches. So a recommended way and the way React is going to go. Another thing is building your code. I've got a really small application here, and that runs pretty fast, builds pretty fast. But if your application becomes larger, then building your TypeScript and type checking it is going to become slower. And I've worked on some relatively large applications where just doing an npm start takes a lot of time. It takes minutes before it's actually running. Now, incremental compiles after that were fast, but the initial startup was very slow. That's because TypeScript has to compile everything and it takes time. But there are much better alternatives out there these days. And the one I'm using right here is ESBuild. And ESBuild is a much faster way of compiling TypeScript and JavaScript. There is another tool, a similar one, called SWC. And earlier this week, Next.js, a very popular React framework, announced they were switching to SWC to do the same thing. Now, when you're working with an application, you kind of have to host it. And at development time, I have to host it in a development environment. And with React, you can use Create React App or something like this. But I'm actually using Vite because that uses ESBuild and is much faster. Why is it much faster? Well, we can see that if, where did my application go? Here's my application. If I open up a page like this and I check the network, and let's go there. And now let's make a small change here. Few characters here. I see look what happens, and I can see that, is that, no, that's the API. That's not the one I want. This one is the one I want. Here, you can see that a bank account.tsx is transferred over the wire. And if I look at the contents, I can actually see my React component. So this uses ES modules to only transfer a single component which was recompiled over the wire, not a complete bundle with quite often the complete application. So it only compiles one file, it only transfers one file over the wire and is a lot faster. Even with a huge application where there are lots and lots of components and other TypeScript files. So highly recommended. Next.js, which I just mentioned, is using a similar technique using SWC and trying to do very much the same and speeding things up very much. There is also the thing of hosting your application at runtime. Now, I've seen people do lots of things, but a very common thing when hosting a single page application like a React or a Vue or a Svelte application is to run it inside an Azure website. And that will work, not a big thing, as long as you don't do npm start in there. Don't ever, please ever do that. npm start is a development environment. You get a development web server, which is not meant for production. But if you build your React application, deploy the results to an Azure web application, that's going to be perfectly fine. IIS will host it and it will run perfectly fine. But do you really need IIS and all the capabilities there to host what's really for the server just a static application? No, you don't. And it turns out there are much cheaper and faster ways to do it. And one is to use an Azure Blob Storage. So what I did is I configured an Azure Blob Storage, and down here you can go to static website, and I've clicked enable on that, which gives me a special container where I can upload my files. So if I go to the containers, there is this $web container. And if I inspect that, we can see there is an index.html, there are a couple of images here, robots.txt. If I check assets, we see there's JavaScript here, there is CSS here, all sorts of things. There are map files here for debugging stuff. Basically, this is my hosted application. And if I go back, oops, not there. Here, I can copy this URL to the clipboard. And that loads my React application hosted on Azure. I can go to the accounts. There is a page with movies here. Probably not something you'd combine in a real application, but this is just for demo purposes. So that works perfectly fine. Now, we need data here as well. That's not part of the static application. So I'm actually doing that. Let me close these down with a server-side part. And in this case, I'm actually using Azure Functions. So I've got some really simple functions here. There is very little logic, but this basically said if we do a get, respond in this case with the contents of a specific JSON file. Kept this really simple. In a more realistic scenario, this would probably go to a database, get data from there, etc. But that works perfectly fine. The same for movies. There's a bit more here, but not a lot. Get a specific movie, get the list of movies, although I'm not even using this endpoint. Azure Functions work really well for these kind of things. Now again, not every application can use Azure Functions, but if you can, it's the perfect way. It's simple, it's cheap, you can easily redeploy them, and if you don't need to maintain states in your application on the server over a longer period of time, then it's really, really easy to do so. Want to run them locally? That's fine. Over here, let me clear this. Using Azure CLI, I can do a func start, and in this case, because I'm doing a cross-origin request, I'm saying -- course star allow all cross-origin requests, and that starts my server locally, so I can test things. And there it's, well, almost there it is running again. So a really convenient way to host those. Now blob storage works fine, but there is one problem when it comes to single page applications. I've got the version running on blob storage here and I can click through it and all of that works fine until I click the reload this page button. If I do that, I'll get this error. The requested content does not exist. Why is that? Well, if we look at that container, where was the container? Here, web. We can see there is this index.html and a couple of images, and in here there is a lot of JavaScript. Well, the URL here is not for an index.html, it's for accounts. It turns out with a single page application, all that navigation is normally done locally in the browser. So what I can do is I can go to the root, which loads that index.html. Now I can click on accounts where I load the accounts, but the navigation, even though the URL changed here, was done locally. But I cannot request this directly from the server, which is kind of painful because now people can't bookmark this, etc. So I want this to be slightly better. Turns out with Azure, that's really, really easy. We've got an Azure CDN, which is also pretty cheap to set up for a basic version. And with the CDN, you can add something called routing rules. So I've got a routing rule right here, which says if there is no extension on the URL, then rewrite to the index.html and we'll let the client side figure things out. So here's that rule, pretty simple. Now, if I look at where are my endpoints, here we've got the original hostname, which is my blob storage. Here I've got the Azure Edge.net endpoint, which is the CDN. If I use this one, application loads up exactly the same way, no difference. Works perfectly fine. Except now if I refresh, the CDN says, well, I'm asking for accounts. There is no .some file extension on there. So I'm going to rewrite it to index.html and I'm going to let the client sort it out in JavaScript, in this case, the React application. It will take care of how to handle that. And that will just work. So I can go to movies, hit the reload button. It just works. Another benefit of a CDN is that it's deployed all over the world close to where the user actually sits. So even though blob storage is pretty fast in loading things, loading the application from a CDN is even faster. So that's a nice side benefit. Two big benefits of using a CDN there. And price-wise, CDNs are, for something simple like this, are really cheap. So this is much cheaper than hosting your own applications and setting things up that way. Now I also want to automatically deploy things if they're good. So I'm hosting my code on GitHub, and what I'm actually doing there is automatically deploying my code. We can go there. I've got 2 YAML files. So because I'm on GitHub, I'm on the .github folder, workflows, and there is this publish client. And that basically says, okay, let me zoom in a bit. Take all the code from client. If I push to main or there is a pull request, run some code which basically builds it. It, well, could potentially test it. I haven't got any tests in here, but I'll come back to that in a bit. And when all of that is good, go and deploy it. So there is one more task down here, which says, okay, go and deploy it to blob storage. I also want to do the same with my services. So there is another workflow here, publish server. Kind of does the same thing. Whenever a push is done for the server, it runs this script. It uses .NET to compile everything, and then it deploys to an Azure function on Azure. So really nice. As soon as my main branch, is it main? Yeah, main branch is updated, everything will be deployed automatically, provided tests, etc., if configured, pass. So something which just prevents errors. Don't do this manually, do this automated as much as possible. Now I mentioned testing, so I didn't actually have tests configured in my build. There should be, but I didn't. But we really should be testing. Now, I'm a big fan of test-driven development, but there is this thing with the traditional testing pyramid. You might have seen this, and that's what most companies, most teams do with testing. And at the bottom, there is unit testing, where you test small units. Then there is integration testing. Then there is automatic end-to-end testing, where you test the whole application. And in the end, people end up doing manual testing. And that's fine, except it tends not to catch a whole bunch of errors. Unit testing is the big thing here. Now, there is nothing wrong with unit testing, and you should certainly do that. But over relying on unit testing leads to problems in production. And I searched on Twitter and the internet, and I found some interesting memes over unit testing. And this is one of them. I've got two windows here, and they were unit tested and they work fine, but you can kind of see from the way they are stuck together that there is an issue there. Like, the handle for one window blocks the other. So even though both windows by themselves open up perfectly fine, together they don't. I like this one even better. I've got a door here. There is a latch on it, the deadbolt. It looks pretty well bolted on. It looks pretty solid. So it looks like if we close that bolt, that door is locked and is not just going to open. So unit tested, worked perfectly well. Everything was fine. It's locked. Except this was a sliding door, so it turns out it wasn't locked at all. That's the kind of thing you run in with unit tests. You test small things, they work, but together they kind of don't work anymore because lots of interactions between different units are left out, and well, they kind of tend to break things. The less checks you have, the more likely that's going to happen. So what I recommend is actually not over relying on unit tests. You still should use unit tests. There is nothing wrong with unit tests by themselves, so it's not like you shouldn't use them. But use end-to-end tests more. End-to-end tests tend to test your application completely. The front end, the back end, the different things working together, and that's what your actual user does. Even test doesn't reflect what your actual end user does, it's only so useful. There is use for it, but in the end, it's the proof in the pudding. An end user does something, does that work? Well, different ways of doing it, different tools. My favorite tool is Cypress.io. It's a great tool to write tests like that. And a shameless self-promotion, I created a course on Udemy about Cypress.io, and that's currently the highest rated course on Cypress. So if you want to learn more about Cypress, I would recommend going there. Of course, I did it, so that's a shameless self-promotion, but an example of some tests here. We've got a test here for the movies page, and we check whether we can go to the home page, whether we find a link named movies. So if I go back to the application for a moment, we find the link here. So basically, the user does this, go here, click on movies, and then what does the test do? It checks whether it can find Schindler's List, which is down here. So it looks if it can find that title. Well, that's something a real user might do. No technical IDs here, etc. Then there is another test. Go directly to movies, make sure you can go there, see if you can find the movie Spirited Away, and see if the description, at least part of the description, is there. So that test would be something like go here, find Spirited Away, which is down here, and see if part of this description is here. Now, how long does it take to run tests like that? I've got a number here. I'll run all of them. They start up. Oh, that's interesting. That actually failed. That should not fail because all my tests should pass. Let me rerun them. And it fails again. Interesting. Did I change something? The value was undefined. So apparently I changed something and I broke my application. Interesting. You didn't see this. This test worked perfectly. I'll fix that later. So another really nice thing about Cypress is that I can kind of start faking things. Shouldn't do that too much, but you can. Now, where is that useful? If we look at my application test, you can see there is accounts, movies, but also this page for vehicles. And this is actually in browser, so I can actually use it in here and do things. So I can actually play around with the application in here. But if I go back to the browser, right here, there is no vehicles. Why is that? Well, assume for a moment we're on a team where building an application where one team is responsible for the backend, another for the front end. And in this case, the backend team hasn't done the API for vehicles yet. Now, quite often I then hear that the front end team says, well, the APIs aren't there, we can't proceed. But with Cypress, you can. We can fake the APIs, and that's what I'm doing right here. I'm saying before each test, intercept every API request for a vehicle, and instead of actually doing that request, just return the content of this JSON file. And then in our test, we can just navigate there and actually test whether the thing works. And using UI here, we can actually navigate through it, we can click through it, and we can use this during development. Now, how come we've got vehicles up here and we don't here? That's because at runtime, I'm actually looking whether we're running inside of the scope of Cypress. And if we are, I know it's safe to show up or to have vehicles show up here because we're intercepting that AJAX request. But if we're not running in the context of Cypress right here, then that fake isn't set up, that fake AJAX request. So I can't actually run it until the backend team has deployed that new API. So take care of that. Another thing which I've seen go wrong quite frequently is the types used on the backend and the front end. Now on the backend, we're using C#. On the front end, we're using TypeScript. So directly sharing types is not an option. If we were doing Node.js on the back end and we're using TypeScript there as well, we could use the same types. But here we can't. And there are potential problems there. And let me show you a problem if I go to accounts. I can load accounts and you'll see a list of transactions here. And that works for all of these users except the last one. There is an error. There is a mistake in or a mismatch in the way these types are described. If I go and look on my client, where is the type? Here, no, that's the server. In here, there is a type of bank account and it says the transactions property is of type transaction. It's not null, so it must be an array, possibly 0 elements in there, but it must be an array. If I go to the component, where is it? Bank, single bank account. Down here, if I hover over it, it says it's always a transaction. It's never going to be null. But it turns out for this last user, it really is null. Well, if I go to my backend types, right here, it actually says here required, which is not correct. I should remove that. Now I've got this mismatch. On the back end, the transactions could be null. On the front end, it still says it doesn't. I want to prevent that from happening. Let's do that fully automatic. I'll restart the server because we changed a type there. I'll stop Cypress, don't need that anymore. And I'm going to run a little script, npm run and swag. And swag is a little tool. And that's going to pick up changes from my front end. Oh, sorry, from my back end. And update my front end types. So if I go back to functions.ts, we can see that right now, transactions has been redefined as a transaction array or null. So now those two are in lines. And now if I go to single account, it still says that account. So we reload this because for some reason it is not picking up the changes to the type because it should realize that transactions could be null here and this is a compile error. But it's still not picking that up and it can't go to the definition. And no, I don't want to install new types. I'm not sure why Visual Studio Code is not picking up that change. Now, what am I using here? I'm using a specification called OpenAPI. An OpenAPI is a way where you can describe your types somehow. I've got an example here. Let's go to the editor, live demo. I've got a definition here of an API with endpoints, types, etc. And OpenAPI can be used in different ways. And the best way is to define your API endpoints this way. I've got different paths set up. I've got, where is it? The types somewhere down here. They're a little further down. Here, for instance, there is an order type which has properties of an ID and a pet ID, etc., and is of type object. Then I can generate code on that. You can see here generate server, generate client, and you can see there are lots of options on how to generate it. Now, what I'm using is a tool called nswag to generate the client-side tool, but I'm not generating the backend. I'm using tool called Swashbuckle, which takes my .NET types, my C# types, and exposes those as an open API endpoint. And then with NSWAG, I generate the client-side bits, the TypeScript bits, but it could do other types as well. I could use it to generate C#. I could format it different way. It's quite flexible. And I generate my client-side bits based on that. And that way, they're always in sync. I update my .NET, my Azure services, my client rebuilds, it will update its types, it compiles against those types, and if there is a mismatch, all of a sudden that breaks. So when I do this in my CI build, I'm actually generating these types, the API types, with every build. So if a publish is done on the Azure services and there is a change in the public types there, then I'll compile against that actual update. And if that doesn't match my client-side code, my client-side deploy will actually break and I have to update it. That's because in this case, the service is leading with the type definitions. Now, one potential problem there is time. And the problem there is that my front-end application kind of lives independently at runtime from my backend. An end user can go to the browser and say, well, I've got this application open and I'm here. And as long as, let me refresh this, as long as I am just clicking around here in the application, I'm not loading a new one. And that's fine. That's the intention. But there is a potential downside to that. Suppose I don't reload this application for days, maybe even weeks, and that happens. Lots of people don't shut down their machine, but they just keep their browser open, which means that the single application stays active. Whenever they first loaded it, that version stays active. Now, if you in the meantime deploy newer versions of your services to Azure, they go live, but some users still use old versions of the applications, well, there could be a mismatch there. You might have deployed a new front end, but they're not using it yet because they didn't refresh their browser. And you get into issues. So what I'm doing in the build time, I'm actually generating an assembly version and I'm grabbing that when I update my client-side bits. So because I run NSWAG, it should be updated, and there is this file, an API version, which says, okay, this was the version of the API when I updated my types. So the types are valid against this version. Then every time I do a request to the backend, I include this as a custom header, and the backend says, well, is the front-end version of the application, is that still valid? Is that version still compatible with the current version? And if it isn't, it returns an error. I've got a real simple check. Where is it? Not in here. No, it's not in the slides. So let me quickly find that check in here. Where did I put that? Here. So here I'm basically saying if the build number is less than 10 versions ago, then it's considered fine. And if it's 10 or more, then we'll throw an exception that the client version is too old. The client will get a 500 exception, and he has to load the latest version of the client application, and then everything will work again. This is a bit arbitrary. In reality, you probably want something which is a bit more sophisticated. Depends how you work with build numbers, etc. But this is a relatively simple check which will work if you do a deploy, say, on a daily basis, and you make sure that you actually update at least a minor version if your API isn't compatible, and you check on that as well, and certainly the major version. Just an example on how to check things. Now, there is actually more to check there. There is another thing which I frequently run into, and that is that the types used on the back end and the types on the front end don't actually match. Because on the back end, my types tend to be the shape of the database. Typically, you see that people retrieve data from a database and the REST service kind of returns that over HTTP. But then on the front end, you've got a UI, and that's split up into different sections, and you tend to want data shaped slightly differently. So what I do is I actually work with different shapes. The types I generated were for the types that came from the service. And then on the client, I use different shapes, and I have a mapping between them doing the right thing. Now, that's long living clients. That's checking of the version. So it was actually there. That's something else. Let me actually show you in code what I was going to go to. Here in the bank account, I have one of those mappings. So I'm fetching the data against the API type, and then in here, I'm mapping from one shape to another shape. And in this case, I'm changing the transactions a bit, etc. But what I'm also doing is I'm saying, okay, I need that other type. How do I get that? Well, I use a validation library, ZOT in this case, where I'm describing how that type looks like. And ZOT is a validation library, and it will let me validate things. Now, quite often with data validation, you see people validate user input data, but I would highly recommend validating data which comes from any other source. So whether it's a backend of the application or an external thing like a user, for the front-end application, both are external, and you should validate the data either way. For the backend application, the Azure services, it doesn't matter where the data came from. Does it come from the front-end application? Well, presumably that validated the data, but you can't trust that because a user might have done an AJAX request directly to it. Maybe some hacker did. So always revalidate data when it crosses boundaries. Now I've got this validate API here, which is set to false, but if I set that to true, it will actually start validating. And right now this actually complains, because that should be an array. I think, yeah, then the error goes away. So all of a sudden TypeScript has picked up the types and it realizes the right thing again. But now because I start validating, my service will actually tell me when data is not what I expect. And I have to do this on the local version. So if I refresh this page and let me put that all back in here again. See if I get the error I expect. Yeah, that's the error I was trying to get, which kind of shows I'm expecting data to be in a specific shape. I'm expecting that transactions property to be an array. It says here expected array, but I actually received a null. In this case, that's because of that mapping where I intentionally made a mistake. And in this case, compile time checking also found it. But again, multiple cheese holes, compile time checking, runtime checking. Maybe it feels like being a little paranoid occasionally, but that's the wise kind of thing to do. Now with that fixed, if I refresh, everything is fine. And now that the last user actually works fine, it does a map, but over an empty array and no transactions to show there, but no error. Another thing with networks is they tend to fail occasionally. Maybe you've got your application deployed and a user is using it on a mobile device, on a phone, sitting in a train, and that train goes through a tunnel. So he briefly loses connectivity. Well, if you just do an AJAX request, that might fail. So what you should do is always have retry policies. So I've got a library, an npm package called Poly, and that's Poly.js actually, and that's based on a .NET NuGet package called Poly, and that is for transient error handling, which means that, okay, try something, and if it fails for some reason, in this case the AJAX request fails, then in this case wait a bit, wait 1 second and retry it, and if it still fails, wait 2 seconds and retry it, and if it still fails then we can really consider it failed. But that means if connectivity briefly drops while we're doing an AJAX request, it fails, but we'll retry. And in most cases, the only thing the user realizes is that it's slightly slower, but it will still work because it was automatically retried. And it's not like the user has to go in and hit F5 to refresh the browser to make it work again. So I'm running out of time, so I'm going to go through the rest relatively quickly. Workflow when developing. I would highly recommend not working with long-lived Git branches. Short-lived branches, a few hours to do something and then create a pull request, merge that into the main branch and work with it. Deploy that main branch often. But that leads to a potential problem because we've got a main branch which contains work which, well, is frequently updated, and lots of new features actually take more than a few hours to work on, maybe a few days, maybe even a few weeks. So you kind of want to hide that code. Well, use feature flags for that. And when you release to a small set of users. So maybe you've got maybe you've got something like what Microsoft does with Windows. There is a fast ring where you can let users opt in, or maybe you've got some companies, client companies or regions where you want to test first, or maybe just the internal companies of your own code. Feature flags are also highly recommended, so you can turn things on and off. Not going to demo that, don't have time for that, but Azure has this app configuration service, which is really useful for that, which I actually use for that. If you can't, there are services like Launch Darkly, which works quite well. But Azure App Configuration actually has the benefit that it's not just for feature flags, it's also for other configuration things. Things like which API endpoint should I use, which tend to differ between production and testing environments. So here's an example on how that could potentially work in the backend, where it's kind of fake, but here I'm saying that movies feature, for instance, is only allowed if the user agent is a Chromium browser. So on Edge or Chrome, that would be true. On Firefox, that would be false. So if I open up this in Firefox, right here we've got accounts and movies. But I go to Firefox and we only see accounts, no movies, because it didn't match our feature flagged request. The client-side bits for that basically use some React code, not going to go into details yet, and then some conditional rendering in React or similar frameworks, really easy. I'm just checking whether the features.movies is true. If it is, I'll render that navigation item for movies, and if it isn't, I'll render a null, which basically means don't show anything there. Another thing, runtime errors, but I've really run out, so I'm not going to show you, but they will occur. Whatever you do, make sure to catch them on the client side, send them to something like application insights and collect them there. Application insights works really well for that. I can go here, go to browser exceptions, and I can see exactly what exceptions occurred. I can select them, see the details, see other stuff that happened with that user, see the callback, see which components were used, etc. Without that, you won't know what happened on the client. So all the details. So conclusion, lots of cheese holes, lots of slices of cheese to catch different errors. Use what's appropriate for you. Use TypeScript, deploy using a CDN, blob storage, things like that. Use feature flags, use automatic type updating, these kind of things. So thanks for all the sponsors for making this available, and the partners and all the different communities involved. I'm afraid we won't have time for a Q&A, but please fill out your feedback form. And thank you all very much for attending this session. And my apologies for running over a minute.
No worries, Maurice. It was an excellent session, and it's worth waiting.
Thank you.
So, Maurice, as you said, I think if at all any questions that comes, I will redirect directly to you. Considering the timeline, I'm going to give the handle, your Twitter handle, to the audience, so that if at all they want, they will be able to reach out to you in person.
Yeah, excellent.
Yep. Thanks a lot, Maurice. And audience, I request you to provide your feedback with the corresponding session code. Just now I pasted those details on the chat window. Thanks, Maurice.
Okay, and thank you for organizing this. Appreciate it.
Hi, Abhishek.
Hey, hi, Steesh. Can you hear me loud and clear?
Yes, it's loud and clear. And Abhishek, a quick check. Can you share your screen, and we'll ensure that it's working?
Yep. Can you see my screen?
Yeah. Yes, we are.
Okay, I'll stop sharing then. Okay.
Okay. So, hi everyone. The next session we have Abhishek to discuss about building and scaling ML classification for admission prediction. So, Abhishek, the stage is yours.
Yeah, thank you,
Abhishek,
Satish.
may I,
And
yes, yes, may I request you to give a small intro about yourself first?
absolutely, absolutely. So thank you, Satish, and good afternoon, everyone. Good afternoon, good morning, good evening, wherever you're joining from, all across the world. My name is Abhishek. I'm the co-founder and CEO of Extra Edge. We are a SaaS company based out of India, and we help education brands across the globe increase, manage, and predict their sales. That's their admissions. And with that context, I would want to share about our learnings and journey applying machine learning and a bit of prediction into education sales, what we call admissions. So I have been a programmer for a long period of time, but now as a co-founder and the CEO of the company, one of the key areas for me is to make sure that we leverage data to give very clear insights to our customers. So with that, I would go ahead and share my screen, Satish, if you allow me, and get started. Is that okay? Satish, you there? Okay. Just let me know once you are able to see my screen.
Sorry, Abhishek. Just now, yeah.
Yep.
Can you? Yes, now we are.
Great. So that's what we are going to cover, ladies and gentlemen, about building and scaling ML classification for admission prediction. As you might all know, that machine learning can have multiple applications at different business processes. Today, I'll be talking about how this application can be powering education sales, what we call admission, which exactly what Extract does. Uh, but before we move, a very quick agenda. So I will give you a very quick background about what kind of problem are we solving here. So what I've learned as myself a machine learning practitioner, that domain is very important, and articulation of the problem is probably around 50% of the work. So would want to talk to you about the case study of our company. What exactly are we solving for? Followed by what was the case of machine learning in transactions? What kind of data are we talking about after we identify the problem statement? Then the data structure and model performance, and most importantly, how this can go at the hands of the end users, who and how can we dumb down our lot of technical jargon to make sure that it's usable at the ground level for the admission marketing and sales teams who are our end users across the globe. And then I would love to do a show and tell and show you how that looks like while we run at production, a bit of code, and happy to take questions on. So with that, I think just to understand what's the use case for Extra Edge here. So as I told you that we help admission teams acquire and win. What it means is that whenever, and a lot of people who are present here in the audience, right, we all have been a part of an institute, an organization where we have studied and gone for our higher education or undergrad, postgrad, and so on and so forth. So whenever we enter an organization like that, an education organization, we have a journey, how we reach out to them, how we are selected, our selection criteria, so on and so forth, how these brands influence you in online, social, and digital world. So that's what Extra Edge does. We provide them an end-to-end marketing and admission platform through which they are able to understand the student's journey and use leading and lagging indicators to make the right admission decisions. Imagine, a Stanford or a Carnegie Mellon understanding the profile of a candidate, because a lot of people apply and seats are limited, and they choose judiciously using intelligence that who's the right fit, who's not the right fit. So that's exactly what we solve for. And from a machine learning perspective, there are two core areas which are very evident here. One is what we call identifying the needle in the haystack. So how do we identify using a bit of boosted decision tree and a bit of classification, that which is the right candidate as compared to the past data, historical data of the institute's admission. And second is what we call reinforcement learning. So while we have identified the needle in the haystack, how do we make sure that what kind of nudges or communication should go to them and in what time duration? Before I move ahead, let me tell you something about education that maybe few of you would know, but there are three very unique criteria about education which makes it very interesting from a marketing perspective to solve for. One, uh, education decisions made by the kids or the students from a brand's perspective are are irreversible in nature. That means that once a student chooses to go to a college, seldom is the fact that he drops off. So that's an irreversible decision. A. B is that it's time critical, it's time bound. They need to take that decision in the next 3 months, 4 months of the cycle. And finally, education, like right, similar to healthcare, is it does not care about what's going on in the world. People will study and buy medicines, right? So it's like it's pandemic proof, so as to call it, if you call it, right? People will go and study, right? So this makes it very unique from a brand's perspective to make sure that they leverage intelligence to look at their existing admission data. And that's a viewpoint to all of you, right? A lot of us closely watch what's happening in the venture capital market, right? If you look at all these cohorts, right, universities, coaching, edtech companies, new age skilling, study abroad, and K-12 and early education, a lot of these people spend a huge amount of money to acquire students. After real estate, retail, and e-commerce, education is the highest spender of marketing money across the globe. And hence it becomes a very interesting sales problem for us as technologists and technology providers to empower these education brands to take the right admission decisions or help them in increasing their conversions, right? That's exactly what we are talking about. And there are 5.5 lakh brands all across the globe, right, from a big university to K-12 player, some of the logos that you could evidently see here. Moving to it, while we look at it, that how we make admissions predictable and data driven, I think we need to really look at from a very holistic and vision perspective and a mission perspective, and that's a mission that Xtrage is on today. Now, when we talk about the predict platform, how are we structuring it? And it's very important that what value you are adding to your end users and your business economic buyers, right? So for us, there is a management. They own the institute, the trustees, right? They are doing admissions for 30 years, 40 years. But now in a post-pandemic where everything is happening digitally, right? They really need to understand their past data to identify who's the right fit for their institutes. Also, the admission heads or the enrollment or recruitment heads need to plan their outbound activities and inbound activities based on that intelligence and data. And finally, the people or the admission counselors or admission executives who speak to those prospects and students to comfort them and help them in their academic choices. They need to use that historical intelligence to decide what's the next best action for them. Should be sending them an email? What kind of email? When? Should be making them a call, or should be a video call or an audio call or a phone call, and so on and so forth. So we all solve, these are the problems that we solve for these end users as we move forward to it, right? So why machine learning in transactions? And when I say machine learning in transactions in admission, in admission processes all across the world, why? I think what's happening today is across the world, across different areas of businesses, the way a buyer and seller interact with each other is fundamentally changing. And that's how I want to set the context for this whole session. And to give you an analogy of it, if you think about us as consumers, right? If you look at how we used to buy before and how we used to buy now has fundamentally changed, right? So right from broking, rentals, ATM, auto and communication, vegetables buying, or going to malls have been transformed into the new ways. Now, it's very, very important to understand that when the old way is replaced by a new way, how buyers and sellers interact, it really changes the market dynamics in industries, and that's exactly what has happened in education too. There's a millennial buyer today buying a course sold by edtech companies and universities who are trying to become edtech companies, and there's a lot of data being exchanged of what they do on online, on their website, on their landing pages, on Zoom calls, videos, inbound calls, phone calls, SMS, email, text messages, WhatsApp. all can be a very interesting stream of data which we could look, and we could really help these brands make the right decisions, as their buying and selling has also fundamentally changed, similar to these industries, right? So what I'm trying to tell you is that the admission teams will only win by understanding the customer or the buyer journey. And in an admission where it's a very personalized decision for anybody who takes an admission in any kind of course, more hand holding and understanding or empathetically understanding their needs is required, and that's where machine learning can play a huge important role. uh, Moving to it, I think I wanted to set the stage for you guys that before I go into a lot of technicalities and how to build these models, trying to get the business right, that why are we doing what we are doing right now and why now? It's a very important question for all our technologists, that why we should be building something now today, right? Moving from there and segueing more towards choosing your weapons of algorithm, toolkit, language, and design. I'll try to go bit more deeper into the technology side of it, how you should think about building these kind of models now when you have understood the business use case for us, right? So I think I've just taken a cheat sheet. I think it's very important to understand that how your business case decides what kind of algorithm that you would want to fundamentally use for it. So for example, in our case, we really need to, at the end of the day, tell the admission teams or the sales teams of any education brand or a tech company that whether Abhishek will take admission or not. So if you look at a fundamental from a machine learning problem, right, it's a classification problem at the end of the day, that we need to tell them that is this guy going to go ahead or not going to go ahead, right? Again, you can use different other means to it, but the choice of what algorithm or what toolkit works for you should be driven by a business use case and not the other way around. And often than not, it sounds very intuitive, but as we start building it out, we somehow lose a sense of it once a while. So it's also important to understand that business case should drive the choice of technology here. Same in machine learning too. It's a beautiful cheat sheet from Azure itself, where you can read about various use cases and try to find out which algorithm will work for you. In our case, we chose a combination of classification boosted decision tree, which is a part of the overall classification, and got ahead with that. So what did we do further, right? Once we identified that, I think what we started to look at in really detail, that what approach should we take, right? And if you have a huge set of data that requires training probably in hours, so in our case, my model requires training every 12 hours, right? So you really need to choose these things based on is it a linear model, or is a fast training required, or there's a long training time required. So just to give an example, if you have a long training time required, and long training time because your model is complex, data is huge, probably a neural network will be a better choice as compared to a 2-class decision forest, which trains you fast in this case, right? So I think there's a lot of help available out there for you. What the help can't do for you is answer the business questions, because as business builders, we really need to articulate that question and then go and choose the one that fits our use cases, right? So while we started to build and develop of it and started to do it, we started to choose 2-class classification, and we started to work on it, that how we could make best use of it. And and then we went on building out to it. So for all of you who are planning to leverage machine learning or any kind of algorithms based on that, right? Let your business case be very well written and articulated, and we'll talk about it. And then you go ahead choosing on a criteria of what do you want to achieve. Is it a linear problem? Is it a binary problem? For us case, it was a binary problem. And then what kind of training times do we require? That will constitute your model that could scale up over a period of time. So very important to think about your business case that will decide your model approach over a period of time, right? So and as you rightly see here, it's very critically and very equivocally written that it predicts between 2 categories, which is exactly what we wanted to solve for, right? Moving to it, I think I cannot emphasize the importance of this. Whenever you are building a product or a project where something like machine learning is involved, you have backend engineers, you have data analysts, you have machine learning experts, you have business analysts. all contributing to it. So I took the liberty of just putting out, so simple kind of collaboration doc in case we use a Dropbox paper. And it's very important that we all the stakeholders collaborate togetherly on that doc, because there will be less Chinese whispers. People know exactly how things are changing, because what happens while you build these kind of models, things change at an early stage very, very frequently, because business definitions may change, your approach might change. At one day you are working on on a 2-class boosted decision tree, but you just realize that your model needs longer training time, you move to a neural network. And then you also look at classification, then a k classification, and so on and so forth. So the business also changes, so does the model approach changes, and so does the backend changes. So very important to not undermine the power of a collaboration document that will go, and that should be updated real time along with the code and everything, and that should go out with that. A very obvious thing, but I thought of just mentioning it to you as I'm talking about how to go about building the whole process to it, right? A very good aspect when you're building a machine learning model is to involve business and business use case analysis at the top of it. If you are the business, that's great. And also involve the backend, the people who are writing the APIs at the end of the day, and talking to the backend at the start of the process, so they are very much aware of it. Also, a mistake that we did is that we did not involve the designers at the start of this. So it's very important, because finally this all shenanigans will emerge into a beautiful UI that people will use at the end of the day, and the end user do not need to know these things, but the designer will put into a frame where it makes sense for it. Quickly moving to it, going more deeper dive into data structures and performance, and taking these design decisions very, very early in your model preparation and building aspect to it. So I think you really, really need to understand that your model will train and retain very, very quickly. And let me give you a simple example. So in our case, we have more than 200 odd customers. Every customer has a different data model, right? Potentially. So we are looking for a multi-tenant architecture where everybody has the different data model, but we have an anonymized master model on which all connect, and they keep on getting updated on a real-time basis, right? So what kind of storage account do you want to use? How do you want to train that data? How do you want to partition and shard your backend? These are some very important considerations that you need to take. And that's why I mentioned that involving a backend person at the start, that, hey, look, we are doing these kind of modeling. How does your backend look like? Is it a NoSQL? It's a relational? Are we leveraging data from a reporting database? Are we breaking down to it? How frequently are we updating these models and scores? These are very important considerations, and it's very important to identify what kind of relational or non-relational backend components you're going to use. And this is not only this, right? Because your model will train and retain itself over a period of time, because more data is coming in, which also talks about a very important part of how these APIs are sorted. Now, this is an example of my own API. Now, when we started to build out, right, we wanted to build out all contributing factors to our probability score, or to the opportunity score of an enrollment of kid we were calculating. So it was very important for us to identify what are those factors that were determining that. Not only that, we also wanted to make sure that there is an element of sentiment involved which goes into it, right? So we mentioned that there needs to be sentiment. And I mean sentiment that if an admission counselor has a Zoom call with a kid in India, and they had a 1-hour Zoom call, we will be able to transcribe that call to text and run some sentiment analysis on top of it, like using Louis and so on and so forth, and bring that also into the system. Because that subjective conversation of a kid with an admission counselor in across the world is very, very important. That's a very rich source of data and text of whether he's making sense, he's answering these questions correctly or not, is he the right fit or not, and so on and so forth. Right. So identifying the contributing factors and these, and structuring them in a kind of API output on a JSON or a XML, whatever you're trying to use, right, is very, very critical. I mean, it's a very simple thing, but if you don't figure out and don't think about it at an early stage, what will happen is that there will be a lot of confusion when you go from, probably from a testing to a staging and prod, that your business might end up complaining that you have not thought it through, and these data are not coming finally at the end of it, right? In our case, we not only solved prediction, but we also solved what we call recommendation. Because I mean, how good is a prediction which does not recommend, right? So we went ahead and started to recommend. And while we did that, what we also thought about is that if the recommendation is a phone call, it is incomplete without a dimension of time, that in how many days I should make that call. So, so these are the three questions we wanted to answer. That what's the propensity or probability of that guy taking an admit? A. B is that what's the sentiment of conversations across emails, SMSs, text, WhatsApp, and also video and audio calls, and by converting them to text using some kind of speech to text, and finally recommending these people at the ground level what to do next. So, very important to think about your scalable web services along with your choice of backend when you start building out to it. Moving to it, I mean, it's very important also to start measuring your model at a very early scale. Now, a lot of people who are machine learning experts know that accuracy, precision, recall, and F1 score are the key parameters on which you could identify your true positive, false positives, and so on and so forth. But educating your teams that building the model is just one part of it. Understanding that whether your model's predictions are true positives or true negatives or false positives or false negatives or not, and how accurately are they going and performing is very, very important. So while we started to build it out, our accuracy was around 60%, 70% across 2 million data rows. But then we started to improve. And today, as we stand after multiple iterations, we are at around 70 to 80% accuracy. That means that with 78% accuracy, we can predict whether a guy will take admission or not, or he will not take an admission. Right. So very important, and it's often said that whenever we write code, telemetry becomes very critical and important. So whenever you are building a machine learning model, these are some of the parameters which will help you to, think about telemetry from a very different perspective. And all their definitions are very well articulated on any Azure ML, website, and they're very clear. But using them and running them in your, try run or test runs on a Jupyter notebook or on a staging environment or using Azure ML, whatever your choice of weapon is, right, or IDEs, is very, very critical and important. Now, so far, I have tried to cover what business use case we are solving. So just a recap of it, education brands spend a lot of money to acquire kids, and the sales needs to be made predictable because there's a lot of data about the kid, and we are solving that predictability to the admissions. B, what's the choice of data models, and what's the choice of algorithm and backend and the JSON structure, and how finally the output should be so that the front end team can dumb it down for it. So, and that's my next slide, that machine learning and AI, there's so much talk about it, but finally your end users do not care about how great your technology is, right? They care about, are you really solving their use cases and problem to it? So how can the end users relate, and how to dumb it down? And one of the things that I would want you guys to know based on my learning is that please dumb it down for your end users, right? They don't understand what I'm talking about right now, neither they will, right, and neither they should. So we need to dumb it down. So how do we dumb it down? So it's like, that's how we started to present it to people, that the number that at the end you'll see, that percentage of conversion, it's basically a metric indicating the likelihood of a prospect to become a buyer. As simple as that, right? So we defined it, we called it, and this is how we presented it to the team members, right? When we were doing a presentation, that, hey, look, you have historical data of admissions, you all know that. We are applying some of the data science to it. There's a live score which you can use. This is as simple as that, and dumbing it further down to it, right? And finally, also educating, because the first question that these will ask you, the end users, is that, how are you doing it? And then you answer these questions. Hey, look, there are a lot of activities that happen to it. There are incoming calls, outgoing calls, video calls, audio calls. There is text messages, emails. We are tracking your click tail data on websites, on landing pages. There are remarks or comments entered by it, and there's a lot of subjective data coming to it. And we train all your 2 to 3 years past data so that we can give you a score which will also guide you on what to do next, right? So, kind of dumbing down, taking them through slowly to it, and then defining it, right? So when I'm saying to you, outgoing calls, what do outgoing calls mean finally, right? So outgoing calls means that number, duration, connected, dropped, frequency, and urgency of calls done. For example, imagine that a kid calling Carnegie Mellon, on a Zoom or probably on a Skype or using a phone, and speaking for around 55 or 60 minutes, right? Talking about his visa process, his coming down there, how can he take class, curriculum, what are the scholarship options for him, right? Can he take some modules or pathways in India itself, and so on and so forth. That's a very great indicator that this guy is moving in the right direction, as compared to they making a call to a prospect for 5 or 6 number of times and he does not pick up the call, right? Or the number is not correct, right? So that's a negative indicator. And finally, contributing factors need to be thoroughly defined for anybody else. And I would highly recommend that whenever you're building the models, right, write these contributing factors very clearly down to it. So we identify these contributing factors, we wrote it down, and this is just one use case for admission sales. It could be retail sales, it could be real estate sales, it could be even not sales, it could be a e-commerce cart predicting what people buy when in holidays, it could be anything. But the contributing factors in that case will be different, and you really need to discuss with your business or business analyst and identifying them and note it down and dice it further down. What do they internally mean for your backend team, and what do they mean for the business, as I'm showing you right now, right? And when you come to it, then you tell them that finally, why we doing all these backend and these kind of intelligent stuff, so as to speak, it will finally get converted to prioritization, filtering, sorting, and focus. So one of the questions our end user asks us that it all sounds good, right? But how does it help me? And that's a very good question. That, I mean, all sounds good, but how does it help me? Then we tell, hey, look, by these things, you are able to prioritize better. You are able to find the needles in the haystack. You are able to push them towards the right outcomes that you aspire for, and you are able to focus because you have limited time and bandwidth, and you only have 120 seats to fill. Should you be talking to 12,000 people, or should you be talking to 1,200 people who are the right fit? Who do you want to talk and invest your time on? Now that's music to the ears, and that's how you need to communicate back to the business and how to go about it. So finally, as we move down into it, this is finally it looks like, and it's very important to also keep on communicating to these. So this is a very initial screen that we had, that we wanted to give to the users, that this is how it will look like. We'll have scores to it. After that, you can make a call, you can send a text message, and so on and so forth, and you can go about it. So we co-created with our customers, saying that where would you want to receive these conversion scores on, and we did 5 or 6 iterations, which I'll show you right now. And finally, when we did that, we also kept on taking feedback from them, as in like we are giving them recommended actions, but we are also asking them that, do you find this useful? And if not, then why not? And we used to take this reinforcement data back to our model to it. So initially we started to receive comments like that, Anna, this probability or this percentage score is crap, it does not work for me. Some people said that, I mean, I would have never ever thought that this particular prospect can convert, but your score really helped me to do that. So we receive mixed and that will happen with any kind of technology toolkit, and especially an ML model you deploy on production in a use case. Allow your users to freely and with freedom give you feedback, and have a feedback loop inbuilt to it. And I'll show you, we had a feedback loop from day one, because we wanted to users to use this and give us a feedback, be positive, negative, we don't care, but we want the feedback to come to us. So build a feedback loop when you deploy your models on prod, and so that your end users can talk to you, because often than not, there's a lot of behavior change to use these things. We are so passionate about building these things, but people are not incentivized to use these things, your end users. They only care about their problems. They don't care about your machine learning models, right? So how do you do about it? How you go about it? Finally, when we give recommendations, we try to map these recommendations as a function of time, because they cannot process every recommendation in one go. So we build a calendar for them so that they could identify which recommendation should be taken at what period of time. So think about easing the process for it, so they could keep a track of it. Finally, I spoke about the feedback mechanism, voting, suggestions, and so on and so forth. That's very critical and very important. That needs to be built out and carved out to it, right? Again, user feedback and iteration, as I said, it's ever evolving. It keeps on evolving as we move towards it. And here, I think, very important that you identify that what are jobs to be done. So a lot of times, we end up in a lot of complexity, but involving your end users from a job perspective is very important. And I'll exactly tell you when I show you, on a show and tell live demo, that what I mean by the job, that what job they want to do. They want to just identify those needles and go about it and communicate with them in real-time basis. Again, machine learning is, or any model, is a very iterative process. In 1.5 years, we have iterated a model around 5 times. So do not build like that, build like this, because if you start to perfect and do not take stakeholders at the early case, then there's a great chance that you might not get there. So build like this, take incremental steps, solve one problem or use case at a time, and then build on top of it. Because as I said, at the early days in 1, 2, 3, the chances of failure are very high. You're not getting the problem statement right, they're not getting the end result right, or they're not liking how the model is giving them scores. So model needs to be tweaked, new algorithms probably need to tweak and use, data is not correct, and so on and so forth. So again, high recommendation that build incrementally, and every point in time with a focus group or users, show them what you're building, like a UI and everything I showed you, and take feedback from them constantly, right? So with that, what I will do is that I will quickly do a show and tell from a live product demo, and probably then take some quick questions. So Satish, are you able to see my screen? Satish, if you could just give me a heads up that you're able to see my screen, I'll shifted it. Okay, I think guys, if you could tell that you can see my screen, I think that will be great.
Sorry, Abhishek. I was on mute. Yes, we were able to.
Okay, great. Okay, sure. Just wanted a confirmation. I shifted. Okay, so again, moving to the live demo, I would say that I mean, there are a lot of ways to quickly check and train the model and feed to it. I find this very quick way of really putting all your data sets and and columns to it, so you can probably quickly you can do a lot of selections. In this case, we took all those columns of the data that we had uploaded, and you can run small splitting and experiments on top of it. And that's a very initial kind of model that I built just to give you a glimpse of it, where you can run some very quick use cases, and how you're scoring the model, how you're evaluating the model, and and so on and so forth. So do these small experiments. Once you are doing these small experiments, then go ahead, you can visualize, identify what are the results coming out to it, how the accuracy is looking like, what's the threshold, what's the different run times telling you, and what they are not telling you. So that's a very good way of kind of how do you run code on localhost. So there's a very good way of running this code on your own personal machine, and doing some very initial experiments before you move on into a lot of different complicated Jupyter notebook and so on and so forth to it. And again, you can model it, and you can move it beyond to any point in time if you want to. And it's very intuitive. Again, you can choose anything, but the best part is that you can connect it to a web service input and to a web service output. So you are getting data in the form of an XML or a CSV, which you can import out to it and throw out to a front end to it. So that's also very critically important, that you kind of have some kind of readiness of output which can be transformed into your product or a front end, whichever it is, right? So in our case, what again, not going much deeper into it, so just take an example of, so this is a student, he's applying for one of the programs in a department, and there are a lot of activities that have happened with this kid, right? So if you look at this kid's journey, there are a lot of things he has done. So there's a video call, there's a mail, there's an audio call, there's a text message. There are many things he has done. I mean, he has gone through a video call, there are some WhatsApp messages he has received and sent, and then now he has also made some kind of payments at some point in time in his journey, right? Because people end up making payments to it, and payment link was sent, it was successful, payment was collected. So a lot of the student journey is being tracked here, right? And while we are tracking the student journey of this candidate Rowan, we generate the score, and the score really talks about that, hey, look, the probability of this guy is really poor because of some of the factors that are interest of the lead. And interest is, in our case, that whether he's initiating conversation in the form of an email or SMS or a phone call, and so on and so forth. But at the same time, there's also sentiment being captured based on the comments that these reps are typing in, and we convert the calls to text, and also the video calls to text, and do some sentiment analysis on that. So that's what your sentiment tells you, that it's the analysis of textual comments coming from these perspective to it. Then the contributing factors are these are the corresponding things. A simple thing like did the salesperson leave a good comment or a positive comment, which one of the colleagues was speaking about in text NLP analysis, right? And did he open my email, when, how many times did he went to my website, he did what? And this chart keeps on improving over a period of time. As I told you, we train the model every 24 hours or 12 hours give. So it started with high probability of 100%, but then motion started to happen, and this probability kept on dwindling down. Then it went up. Something interesting might have happened. And today, as we speak, as we stay on probably this date and time, right, this probability has further gone down. So, a clear chart of this, and then finally allowing your people and giving them a nudge that, hey, this is what I want you to do. I want you to, give him a call. And this comes from reinforcement learning, that based on what they do after they receive these outcomes is very, very important. So now this guy has been, a call has been created, and we also use a bit of RPA to do it on the behalf of these admission teams. We send that email on their behalf. And finally, at any point in time, these people can go ahead and say that, yeah, this really makes sense. I would have really missed this construct. And we take these feedback back onto the model and feedback into it, and we go about it. So I think, dumping it down for them very, very clearly, like this is a prospect, and now they can go ahead and say that this really looks good or bad. I would want to make a call, or I would want to do whatever I want to do with this guy, right? But the score being very easily available for them and do it. And when the score is low, that's one situation. Score also might be very, very high, right, in this case, and then they could probably prioritize based on that. So in this case, email contributes a higher factor as compared to in this case where the lead's interest or propensity contributes a higher factor to it, right? And giving it very clearly for them, and so that they could consume this information is also very, very important. So I cannot further emphasize the importance of dumbing it down and making sure it's easy to understand. Small things like if somebody is coming new and using this particular feature, they really need to understand what this feature is all about, right? So giving some small indicators, some small nudges, some small recommendations, and telling them what this chart looks like. So it's like a historical chart of lead journey till now. It shows trend of conversion probably through time, and allowing them to consume this information along with that, and so on and so forth, right? So and doing some very small things like helping them and allowing them to sort that data by score. Now it's a very simple thing, but I want to know that who are the 10 people I should be calling today. I don't know that. I will sort them in the ascending or descending order, and quickly I'll start to make the call right away. So, your model and score needs to marry the life of your end user in every day, because she at the end of the day will send some people some text messages, some emails. She will call people, set up some video calls from here itself, and stuff like that. So she will end up doing kind of these things in the product itself. And it's very important that you allow those people to do that. So finally, at the end of the day, I will want to just make a call, or I will start a video call, or so on and so forth, right? So how do I do that? So I can just prioritize it based on the score, and I can go about it. So making it easier for them to go about it, right? And then finally, at every point in time, going back to your model and looking at your algos, increasing their connections or fully connected. Do you want to have multiple parameter, or you want to have parameter range to it, and providing them at any point in time? So tweaking this model, looking at your code on a regular basis is equally important. So you identify, and the good part about this is that at any point in time, you can also add code if you wish to. So I can probably, bring in any kind of a Python language module or any kind of thing here into it, and I could just, place into it one of those modules. So if there's a Python script to it, I can write the code, and then probably I can connect it to one of our data sets, that how the processing needs to be done, and so on and so forth. And a model can be built, and I can probably train that model going forward to it. So I think it's very, very important that you do this dry run, you write custom code, you build these scripts, you write out your code, and think about it, that how this kind of will make sense over a period of time, and so on and so forth, rather than just jumping onto on a writing code at the database level and prod level and doing it. So do your experiments with a small data set. And in this case, very important that we took a small generic CSV data set, and we wanted to look at that specific data set and go about it. So take a small data set just to give you a sense of it. So we took a very small data set, and we wanted to visualize that data set. And you see that all those columns that I was talking about, right? The name, city, activities of the counselors, the total, the scoring, gender, and so on and so forth, we all keyed that in, and we started to make sure that that's making sense and how this could be visualized. So take a small set, play with it, build it out, If you are getting the right score, evaluate your model. If it's satisfactory level to it, start getting it moving into a more scalable Jupyter notebook or probably a Python and so on and so forth, whatever is your choice of language, and start to align your backend. And instead of connecting a CSV, you can start connecting your backend and as a web input to it, and you can start building the model out, right? So that's what we kind of ended up doing. We ended up kind of building the model out, and going back to it. So again, we covered it. I think I have already taken 45 minutes. I'll kind of break for some questions. And before I end, I'll just, give you a sense of it. I think it's very important that whenever you are playing with any kind of machine learning use case for a business, your job as a builder of a model or even as a technical person is to spend your 40 to 50% time identifying the business use case, sitting with the business analysts, sitting with your end user, doing a lot of experiments out of it, and building a clear collaboration doc. So your first deliverable is not algorithm or code, but a collaboration doc, which you can keep on sharing over a period of time, and you can work on it, and then you can collaborate on it, and you can go ahead with that. And then you move on to identifying the right model, right inputs, right output, and building it out to it and cleaning it out. Do a small modeling exercise on any Azure model or ML model, see how the scores are coming, tweak the data, tweak the model, and then go about it from a backend or the front end perspective, and keep on iterating and sharing with your end user. Hey, look, this is what it looks like. What do you think about it? And involve design at every step to it. So with that, I'll take a pause and hand over to Satish, in case I could answer any questions. So.
Yes, hi Abhishek. Thanks a lot. Thanks a lot, Abhishek. And probably for this particular session, we haven't got any of the questions so far. I think it's more clear, so people are
Yeah.
very clear on the understanding. So
Yeah.
let's see. I have posted.
If there is some time, then I would love to kind of show the collaboration doc and the process, if that helps people, right? How we thought about the whole structure, because that's the
Absolutely,
first
Abhishek.
that people will again I will not to get into the main thing, but I will just want to show that how many times do we fail, and do we go through multiple iterations to come to a point where we really want to do what we want to do. And it's like we have failed so many times, and then we have gone from there to where we want to. So it's very important that we also understand and appreciate that, if that's okay.
Absolutely, Abhishek. That'll really helpful, because
Yeah,
instead
yeah.
of
So
hearing, yeah.
yeah, just give me a second. I'll just quickly open that up. So
Sure. Abhishek, I'm going on mute.
no problem, right? So let me again quickly share my screen. So what I'm going to show you guys is that we all talk about it when you start building it out, how the whole craziness looks like. So just give me a second. Yeah. So again, just not going to. So we started to build it out. We had roles identified. We identified the problem and so on and so forth. People started to comment on it. We identified the model, and exactly what I showed you right now, right? This is evident here. We chose what are we going to do about it? What's the index looks like? We started to define it out, right? We identified a company that will help us convert audio to text. Unfortunately, that got acquired by Flipkart. So we moved to somebody else, and so on and so forth. And we wrote a lot of material on what's the end objective looks like it's an oracle for an institute across a dimension. So we wrote these important metaphors, a lot of learnings, because a lot of people were working at different points in time, right? So we also embedded a lot of docs of how they could think about the whole process and assimilate these things. These are very small things, right? But they need to be somewhere written down, and then we looked at the data preparation, and as I showed you these parameters, right? We literally kind of nailed it down to the T, that what kind of parameters are we using, how are we defining them, what's the activity, is the indicator a symptom, a cause, what it is, right? So you could have two types of indicator. Either it could be a symptom, either it could be a cause, right? So either it's leading or lagging. So what was it? What was the qualification rate of it? Was it very important, critical, or not critical to it? So in this case, a number of calls was a very high indicator and qualifier, and it was a symptom to it. So, and then you keep on. So it's very interesting. This is how the UI used to look like in the early days, that how they will do that. And now you see it looks very, very different when I'm kind of showing it to you guys. So we went through this process. Then we started to go more deeper into it, that how the terms will look like, how we are going about it, how the model metrics will look like, what are these numbers or metrics mean to it, how the model is currently, how the data cleaning process will look like, right? First model to ninth model to the final model, And then we reached the model. We came across a very important case where we wanted to again do a two-class decision with kind of hyperparameterized optimization. We want to optimize the parameters that we were passing, right? We wanted to make it dynamic. So we worked on that. We worked on predictions, and we added more to it. So again, the reason I'm showing it to you that a lot of process goes through it, how the algorithm evolves, and then we structured like a sprint, that what we do in week 1, week 2, week 3, and some tutorials. Some of the new interns who came in also worked on the project, so they did some end-to-end courses, and we gone about it. So while we were doing it, we were not shipping the product, we were also training people how to use these things in a very articulate manner, and so that they could start working on it. And finally, again, we went on it. So it's like this is a very important part, because this becomes like a work doc for you for doing a lot of things, where so many people, I mean, like a lot of people collaborated here. I mean, some of the people to make this at least a shippable production level code and to go about it. So I wanted to show this to you, because a lot of times we believe that our code is a product. Yes, that's your product, but I think a collaboration doc in a world we live in is also your product, and that needs to be treated like a product along with the business cases. So yeah, I mean, I don't know if it's useful or not. I thought just I share this with you guys. Yeah, over to you.
Absolutely, Abhishek. It was really useful. And I hope the docs which you have shown, it was
Yep.
there on the reference slide, right? In case
Yeah.
people wants to.
Yeah, definitely. I'll share the slide with you. You can definitely look at it, and I'm more than happy to have a conversation with anybody who's trying to build these kind of models. And and a lot of times I am facing myself a lot of issues and problems, and still being a student side of it more than often. So more than happy to understand and see what other practitioners are doing.
Yes, definitely, Abhishek. Thanks a lot, and thanks a lot for your offering.
Yeah, I hope this was useful for the audience, and would love to hear the feedback, and hope that you also find it useful. Thank you very much.
Definitely, I really personally enjoyed it a lot, Abhishek, and I
And thank you
learned
for having
something
me
new.
here.
Yeah,
Cheers, guys.
and
Have a good yeah.
yeah, I have posted the feedback URL to the audience, and let's see the URL. Once we get the feedback, we'll probably share it with you.
Great. Okay, Satish, thanks for having me here. Okay, goodbye.
Okay, Abhishek. Yeah,
Bye.
thank you. Bye bye. Have a great day ahead. Hi, Askari.
Hello.
Hi, how are you today?
Very good, thank you. How are you?
Doing good, doing good. Excellent. And Askari, we have 10 minutes. Shall we wait for 10 minutes? Because I expect few of the other participants to join. They will be joining on time.
Yeah, absolutely. Let's do that. Wait for the 10 more minutes, and then I will kick off my presentation. So the way I've built this one is that I have about 50 minutes of talk, and then 10 minutes for Q&A at the end. So that would be the preferred structure.
Excellent, Askari. Okay, so I'm starting the timer.
All right.
Hello. Hi, Oskari.
Hello and good morning.
Good morning to you. Here it's good evening in Chennai.
Good evening.
I
Good
yeah, I think
afternoon for everyone else following, depending on the location.
yes. In Finland it's morning, I guess. Okay. So hi everyone. Oskari here from Finland, and he will be walking us through the best practices for building a data lake with Azure Databricks, more into an data platform, data side of the Azure. And Oskari is a Microsoft MVP in data platform, and he holds the MCT as well. And he holds a Azure Solutions Architect and Azure Data Engineer certifications. So I'm handing over to Oskari. Yeah, hi Oskari.
Hi, and thank you so much, Harish. And let's get started with today's agenda. So, best practices for building a data lake with Azure Databricks, as Satish kindly mentioned. He also kindly did a brief introduction of me, maybe a few words regarding myself before we get started. So currently I'm working on a company called DataBlink, where I'm helping Microsoft customers and partners to fully leverage their investments on Microsoft's data platform products. So all the Azure's data services and SQL Server, of course, is in the scope of my services currently. So working as an independent consultant currently. But other than that, let's get started with the agenda and data lakes best practices. And today we shall start off with the best practices from the storage layer perspective, because sure, you have the compute, Databricks, but it's good to lay out the foundations for storing the data as well. That's very, very significant part of it as well. Long story short, there are nowadays 3 different services on Azure available for that purpose. So the good old blob storage, which I would assume that most of us have been already using previously. Then around 5 years ago, also Data Lake Gen 1 was introduced, and now we've had Data Lake Gen 2 available a couple of years as well. And in a nutshell, I would say that the key learnings when building the Data Lake Gen 2 on top of blob storage have been that customers have really liked the hierarchical structure there, the hierarchical namespace, which from analytics perspective makes all the sense. So one of the first takeaways would from this perspective be that make sure to always use the Data Lake API on the Gen 2, because that will be faster for your workloads. Other than that, the customers of Microsoft have also really enjoyed the Azure AD authentication directly to the data lake. So luckily we have that natively supported by the Data Lake Gen 2 as well. So as a first best practice, I would say that always when building a data lake, I would go for the Data Lake Gen 2 option out of these. When diving deeper into how the data lake should be organized, we should have actually more than just one storage account where we have all the data. And the structure that I'm advising for my customers to use is as follows. So first, you should have the raw data area. And after that, when you process, cleanse, create the data, you would have a separate storage account for that. And depending on the business, you might have a separate storage account for different use cases available then. So this is also aligned with what Databricks recommends of having bronze, silver, and gold layers. So separating those into separate storage accounts makes sense due to the fact that there are actually limitations on the storage account level. So you have a limitation regarding the I/O operations per second as well as on network bandwidth. So when you have few gigabytes or few terabytes of data, it doesn't really matter. But when you get to the level of having 1 petabyte of data, I highly recommend you to have a look at this structure. And of course, the best way is to, when starting from scratch, already have this structure in place. And in order to grasp where some of the data lakeout best practices come from, when diving deeper, we need to understand how the distributed file systems work. So basically, the Data Lake Gen 2 is a distributed file system. I'll use the Hadoop's distributed file system as an example here, but these fundamentals hold true for all of the main distributed file systems as such. So the way HDFS works is it consists of name node, which is shown here on top, and then we have data nodes in the bottom. So the name node holds all the information regarding where are the files physically stored. So for instance, in this case, the first file named part-0 has a replication factor of 2, meaning there are 2 separate copies of the data, and then it consists of files or blocks 1 and 3, which are physically then located on the data node, so that the first block is here and it's replicated here, and then the block number with the ID 3 is here and here. So on the data nodes at the bottom, the yellow boxes would represent physical servers, and then the green boxes are blocks. So the way that HDFS and similar distributed file system work is that it actually splits the files into chunks and distributes them across different nodes on the data center. And by default, for instance, on HDFS, the block size is 128 megabytes, which means that it splits the files sequentially into blocks of so that the first file has the first 128 megabytes of the file, and the second one has the following 120, and so on and so on. So basically, for instance, in this example, if the file named part-0 would be a size of 140 megabytes, then it would mean that the first block is the 128 megabytes, and the second block is the rest, meaning 22 megabytes of size. And when it comes to when applying this information to Data Lake Gen 2, what it means that the replication factor has been hard-coded as 3, so you'll always have that there, and also the block size is 256 megabytes. And this is very important from the perspective of how the data processing works. So basically, from optimizing the data processing and reading the data, having a lot of small files creates a problem for you, because the way that will work is that you need to first connect to the name node just to get the metadata information of where the file is actually physically located. And after that, you can open the stream to actually fetch the data from the data node. So listing the files in the file systems as well as retrieving them takes a lot more time when you're used to using the SSD on your laptop, for instance. So that's one of the reasons why you should always aim for a file size that is higher than whatever your block size is on your distributed file system. So that's sort of the first point of optimization. And when it comes to the other data layout best practices, let's say we have 1 gigabyte of data coming in. Optimally, we would store that 1 gigabyte. Let's say if we have a batch processing workload, we could store that into a single file containing that 1 gigabyte. And from partitioning perspective, we would then partition that data on a month level so that our average partition size would be around 30 gigabytes. So that's how you should think about partitioning when storing the data in your data lake. So having quite large files and then being on the range of 10 to 50 gigabytes around per each partition. And obviously the Delta Lake is the format to go forward. So actually originally Delta Lake was developed as a format by Parquet. I'll show you a demo on that later on during the presentation. It still uses Parquet as a compression method. So at this point is also relevant to understand that the Parquet block size or row group, whatever you want to call it, is also by default 128 megabytes. So again, from optimization perspective, you shouldn't go less than to files that are less than 128 megabytes from Parquet perspective either. And also the Delta Lake supports other more advanced options when it comes to, for instance, sorting, which may or may be relevant depending on your actual workload and queries that you're running. So as a best practice, I would use Delta Lake today. And why is that? You could see this slide as a direct comparison to Parquet. So basically, these are the things that you get in addition when you use Delta Lake instead of Parquet as a format. And these are also functionalities that I'll be demonstrating next. So the Delta does not stand for an incremental way of loading data. The idea is that you can do both batch and stream processing using the same tables. So you can either do a batch write or stream simultaneously on the same table, and you can also read it both as a stream as well as batch mode at the same time. So there are no limitations when it comes to that, and that also makes it a lot easier to work with the tables from architecture perspective. So we'll have a look at that during the demo as well. You can also do commands like delete and update, which simply weren't possible with Parquet format. So with that being said, let's have the demo part of this presentation and have a look at how Delta Lake works. And before I'm diving into that, I will also show some of the other best practices when it comes to the Databricks workspace itself. So what I have here is I've already created the workspace, and the first takeaway is actually that I've used the premium pricing tier. So for instance, most of the security functionalities are only available on the premium tier. So whenever you have a larger team of developers other than yourself, you most likely actually need the premium tier. So let's launch the workspace that I've created. As you can see, it logs in using Azure AD credential, which is neat and exactly how I would want it to be built. And then, since you have just created the workspace for the first time, what you want to check is from settings and admin console that what are your actual workspace settings here, and to ensure that the security functionalities are enabled. So basically you need the premium tier to have these enabled in the first place. So workspace, access control, clusters, pools, jobs, and so on. The only thing that I haven't enabled is actually the personal access tokens, and those can be created within the Databricks workspace itself by the users. And the original idea behind this one was that the users can access Databricks APIs using, for instance, Data Factory and Power BI. But for both of those use cases, today there's a better way, a better option using the Azure AD authentication instead. So currently there are no actual use case where you would need a personal access token, because you can always use also managed identities and service principals when automating data processing. So personal access tokens shouldn't be enabled for added security. Other than that, this is definitely what you would want to have. How version control works today, rather a new feature called repos, and you can enable this from the same page. So make sure they have this enabled as well, so that you can integrate nicely with for instance, Azure DevOps and so on. So of course, having a proper version control is a very good best practice as well. The other things that I would like to point out from the Databricks workspace is definitely the compute. So one of the things you'll need when actually processing the data is, of course, the compute to run those queries on. And you can see that I've already created a cluster here for that specific purpose. The cluster creation is pretty simple nowadays. You can do it through here. And one of the options that I recommend for data analysis is that you can use the credential pass-through. So you saw that I logged in using my Azure AD account to Databricks, and what the pass-through does is that it actually sends my token further down to the data lake, so that actually there will be my permissions that will be checked on the data lake side to see if I have access and permissions to this data or not. So that's a proper way of doing the data security as well, and highly recommended option whenever you can use it for your end users. So that's definitely one of the things that I'd like to point out. And here we are actually, with the worker types and driver type, we're setting the VMs that we want to use for data processing. Later on during this presentation, I will also share my point of view, which VM types you should use and when, but these are configured under here. Then jobs, when should you use jobs and when you shouldn't? I think jobs are great for streaming use cases. When you need to run the stream 24/7, then you can use jobs for that. I would not use jobs to orchestrate batch processing, because the jobs actually enable you to automate the processing only in the context of Databricks. But usually your ETL process consists more than running just the Databricks job. It's more likely to include things such as fetching data from your on-premises data sources that are behind a firewall. That's going to be complicated with Databricks because you don't have the functionalities that Data Factory would provide you with that, and similarly with the other services and scenarios as well. So as a best practice, I would highly recommend using Azure Data Factory for the ETL batch processing workloads instead of jobs. Other than that, let's have a look at the workspace as well. So since we have enabled the access control, what I can do both actually on the clusters for the jobs, but also I can go actually into a single notebook and configure the permissions of that. So I can define which user group or which user has what type of access to this notebook. So can read, of course, can only see what the notebook contains. Can run means can also execute it. Can edit means can make changes to it. And can manage, obviously, then has the full permissions. So then the user can also even delete the notebook. So that's the basic way of configuring the access within Databricks workspace, and you have similar configuration options available for the clusters and jobs as mentioned. So moving over to the Delta Lake part of the presentation, just to highlight what I have done here already, is I fetched the data of these lending clubs. So this is basically data from lending and related transactions. So whether the loan has been already fully paid, partly paid, or otherwise categorized, being late for the payment and so on. So what I've done, I've downloaded this file, and then I've uploaded it to my storage account. So this is the data set that I'm going to be using in the demo. And to start off with the demo, I have attached the cluster that I've created for this purpose on the notebook, and then I can just basically start running the query. So what I've done is I've mounted a path on my data lake storage account to correspond to this specific location. And I'll show you how to do the mounting later on as well, because there are multiple ways of doing that, and some of them are a little better, some of them are not so good. So I'll give you different options depending on your actual use case. So let's load in the data into our data frame from the storage account. And we have the first job running, and you can see that what I'm doing is I'm just selecting basically two columns, address state and loan status from the file, and then I'm grouping by the address state, meaning I'm basically getting the number of loans in each state, and then I'm displaying that so we can visualize that how does the data frame look like. And indeed we have on the address state column, we have the name of the column, and then we have the number of loans on each US state. And this is what we'll be working with. And then on top of that, we will be creating a table named loan by state delta using the delta lake format. So this is the only configuration that you need to do these days. And actually the delta is the default format in the latest Databricks runtime version, so you don't even need this row if you're using the latest Databricks runtime. And then I'll be saving it to this location in my storage account. So perhaps it makes sense to have a look at the storage account as well at this point. So let's go a level higher. So under this folder, you can see I have some demo data sets, and under this folder, there will be a new folder created, which is named after or how I defined it on the notebook. So on the Delta Lake demo notebook, I run the first cell, and then next step is to create the table in the Delta format. And let's have a look at the results after that so that you can see what actually gets created and perhaps understand the Delta Lake as a format slightly better as well. And then we're doing a select star from that new table that we just created in this cell earlier, just to see and verify the results. So yes, of course, it's exactly the same data. And if we have a look at the folder, obviously I need to do a refresh for it to appear. So now it created the folder for me under here one. And this is basically how the Delta Lake format table looks like. So here you have the data still stored in Parquet format, as you can see. But in addition to that, what the Delta Lake brings is the transaction log. And the transaction log is found under the _delta log folder. So this JSON object here actually is the first transaction, which was the create table as select command that I ran. So that is how it works, and every single transaction will create a new file, new JSON file into this folder. Great. And then to demonstrate how the streaming works, let's read the new table. Forget to set some parameters. Let's read the new table as a stream, so you can see that in here I have defined a read stream. So even though this is just a regular table, I can define to read it as a normal batch type of read operation, or then I can read it as a stream. So whenever there's a new write happening, I will be immediately able to check the results. Okay, let's see. I have some specified path does not exist. All right, so that one worked. Okay, yes, I forgot to. That should do it. So obviously, if the path doesn't exist, then it's gonna be hard to process the data. But let's have a look, like so, and then let's rerun this command as well. We did create the table lending club delta, yes, and then we did this one, and let's see if the stream will initialize right now. Okay, so specified path does not exist. All right, perhaps we'll get back to that specific error later on. Maybe I'll continue with the rest of the commands for now. So let's not spend any time troubleshooting that one. It worked yesterday when I did a try run. So full DML support, the update and delete and merge into commands that work with the delta. So let's create a Parquet table first. All right, interesting. Let's have a look. All right, so, okay. Now I see what's the error. Yes, so what is currently missing is the delta lake table because of one of the commands that I ran. So let's recreate the table for now. One of the commands that I ran there actually deleted the table so that it's easy for me to recreate the demo from scratch, but obviously that's not good during the demo. So like that, we have that one recreated here. So yes, now we have the table back online, so we can continue with the demo as such. So let's start from this part, and let's rerun this command as well. So obviously all the commands were failing because one of the commands deleted the table at one point. And now obviously for the same reason the streaming should work as well. So let's start from that again. Great. So this is how our data actually looks like when we query it with this specific SQL command. So we get a nice visualization of how many loans are there per state. And to demonstrate the streaming, what I have here is basically I'm doing batch processing inserts. So here's my insert statement. What I'll be doing is I'll be adding values to the delta table. More specifically to Iowa, I'll be adding 450 loans on each transaction. So let's loop that through a total of 6 times to have some data to be visualized. So you can see that the loop is running. So pretty soon we should have some data for Iowa here as well. So that's just to demonstrate how the streaming works on Delta Lake tables, and you can actually query them or read them as a stream, even though it's basically a normal table. So you can see that the first insert with 450 came through, and now we have double the amount, so 900. And the fact that I'm actually running this loop a total of 6 times, then that means that the total is 450 times 6. So we should expect this to end up in a figure of 2700 here when it finishes. So like this. And while the stream is running, you can actually query the table in a batch processing mode just with a standard SQL, and it will produce the same results. So obviously Iowa 2700 here as well. So that's a short demo of the streaming. I can probably close the stream at this point, and let's move forward with the full DML support here. So with this cell, I'll be creating the table or in Parquet format. So you can see that the write happens in the Parquet format to this specific location and file. And then what I can do is because here I'm visualizing the data, you can see that, yes, I have the exact same data, both in Parquet table as well as in Delta Lake table, so it's easy to compare these two tables. And first, let's run the delete command to the Parquet table. So I have it with _PQ to identify that this is the Parquet table, and obviously deleting the Iowa rows now fails, but that should work on the Delta Lake table, and looks like it deleted a total of 6 rows, which we can of course confirm by rerunning the same query that we have used previously, and we can see that yes, Iowa is actually empty again. So delete works as expected. Then we can have a look at update command as well. So let's try to update the state of Washington to the value of 2700, and that one fails on Parquet, but again should work on the Delta table, and you can see that it affected a single row, so it updated the value for Washington. And of course, again, we can double check and verify by querying the data that the value for Washington was 2700. We can go back and look at the previous one just to check the original value, which was 293. So yes, actually the update went through and is producing the results that we expected here with the 2700. Then merge into is another super nice functionality. So obviously the deletes and updates are pretty much a must if you're doing data warehousing type of workloads on your data lake, and merge into, of course, simplifies that process quite a lot. So let us create a data frame for the merge operation. So what we did with the delete command was that we deleted all the data from Iowa. So the first row here for the Iowa, that should be an insert. And then for California and Oregon, these should be update operations. And here's my merge into command for that purpose. So when the address state matches, then we update the data, and if it doesn't match, then it's an insert operation. And again, from the results, we can see that 2 updates and 1 insert actually happened as is expected. And again, by querying the data, we can see that Oregon was set to null, and California to 2500 as expected, and Iowa to the number of 10, which is exactly what we defined here in the data frame. So good, merge into natively supported as a command. And then another great functionality of the Delta Lake is the schema evolution. So what I'm doing here with this SQL command is I'm creating a new column called amount. And the purpose of that, of course, is that I will try to write this into my Delta Lake table. So right now what the Delta Lake has in the table, it has two columns, the address date and count. What will happen when I try to insert a data frame that actually has also the amount column there? Let's see. And by running that command, we get the error message that there's a schema mismatch when trying that write operation. But what we can do is we can define an option merge schema and set that to true to define that, yes, actually, we do want to schema to evolve, and this is totally fine. So I can control whether or not I want the schema evolution for every single table, which is exactly how I hope that this would work. So I can force the schema if I would like to, and I also have the option of letting it to evolve. And you can see that this execution went just fine. So if we have a look at the results and we group by address date, of course, and order by the amount column, the sum of amount column to be more specific, we have the values there just exactly how we created them. And by the way, the rows that actually don't have any values in the data right now, meaning the first inserts that only have two columns, the third column for those rows will be shown as null, which is actually what I would expect as well and works just as I hoped for. The describe history command is also available for the table, and what that brings us is the entries in the transaction log. So every single command that was run from start. So you can see that the first command that I ran was to create table as select, and then we did a bunch of writes with the streaming and doing those inserts. Then we have the update, deletes, merge, and then as latest command we have the latest right here. So every single one is available here. And what this enables us to do, since we have all the data in the data lake and we have this information available in with the Delta log, means that we can actually go back to any single version of the data and of the table that is available here. That functionality is also known as time travel, and basically the difference in your query is that you just set version as of and then the version number you want to go back. So when you run the query like this, for instance, running the version as of 0 brings us back to the original state where Iowa didn't have any values. And as mentioned, you can have any of the versions there, and this will work and bring out that specific version in that point in time of the table. And of course, there's the version column that we're using in these queries. We have the timestamp column as well. So you can use this information too. So if I copy that timestamp there and have it here. And by the way, this does not need to be the exact same timestamp that I have in the history table. This can be anything. So if I just add here a little bit of randomness, you can be sure that this is not exactly any one of those entries in the table, but it will be still able to figure out what was the state at this point in time, of course, by querying that table as well. So that one works too. And the last thing I want to point out here is the optimize command, which is super beneficial, especially if you're doing a lot of small writes into the table, which would create a lot of small Parquet files. What the optimize command does for you, it creates a more optimized version of your table, and for instance, has less but larger files at the end of the day after running it. So when we run this command, it will actually, it tells us here that it has written a new file in the data lake folder. It has also made 2 files redundant, so those are it's no longer necessary to read those in at any point in time. Those are not physically removed, they are still there, they're just not used for the queries anymore. They're not relevant when you're querying the latest version of the table. There's a vacuum command that you can actually then use to force remove these unnecessary files if you would like to do some cleanup like that. And basically what we can do after running to verify the performance difference, if we go back to the describe history command to see what are the latest versions of our table, we can see that the latest version is 11, current version, and one before that is 10. So let's have a quick comparison between the two. So if I run the query by querying the version 10, it's quite quick. And then if I just query the latest version, you can see that already with this small data set, because it needs to fetch less files, the query for this exact same data is faster. So optimize, one very useful command when optimizing your Delta Lake tables if you have the small file problem occurring. So if you notice that your Parquet files are less than 128 megabytes, you're likely to benefit from running that command on your table. And there's also a way of doing that automatically during your processing. So let's see if I have that command in this workbook available as well. So you can set the parameters of the Spark session for optimize write to be true, and auto compact is the name of the other functionality. So you can define this for your session, and what that will do is that it will automatically try to write as big files, or at least files that are larger than 128 megabytes by default. And I think the optimize command nowadays, or optimize write, is the default on Databricks as well. If it's not, make sure that by default you are using that one. It creates a better file structure for you on the data lake side and results in faster queries for you. So that's it for Delta Lake. That's Delta Lake in a nutshell. Let's go back to the slides for a few more moments. So I showed some of the best practices during the demo. It's perhaps good to understand some of the common anti-patterns as well, what people that are using Databricks or Spark in general for the first time might be doing. They might be operating directly on RDDs or importing libraries that don't scale beyond a single machine. So historically, for instance, let's say the Pandas has been one of the most popular data science libraries, and because you can write Python on Databricks, you can actually import the Pandas library there as well. But with the default Pandas library, that actually doesn't scale. The code execution will happen on a single node of your cluster, so there's a huge limitation in terms of scalability, and thus the community has actually created a library called Koalas for that purpose. And now, obviously, with the latest version of Spark, there will be a new library, native Pandas library available as well. But that's a good example of a custom third-party library that wasn't originally intended to be used on Spark. So when using Pandas, be very mindful of which library you're using. There are libraries currently that scale for the same same use cases, and then there's the original library that does not. So that's a good example. There are many more. Just be mindful of which library you use and make sure that it actually will scale before starting to use it. Regarding the resilient distributed datasets, so what is ultimately often referred to as Spark Core is the primary abstraction of the data, called RDDs, or resilient distributed datasets. So RDD is a collection of records spread over one or many partitions, and nowadays it's highly unlikely that you would want to operate with RDDs directly. Spark has introduced abstractions called datasets and data frames. So the dataset and data frame APIs, on top of which you can directly build your logic on. They will make your life a lot easier when developing Spark applications. So for instance, RDDs do not have a schema. Data frames and datasets do. Also, when operating with data frames and datasets, Spark uses its own internal engine called Catalyst to optimize the logical and physical query plans. So that is something you probably don't want to overlook. You will need to understand really, really well what you're doing if you're operating with RDDs directly, because Spark cannot optimize the execution for you. You're switching from the declarative way of working when you're using data frames and datasets, for instance, and instead, when you're using data frames, you're telling it what to execute. So then you would really need to understand what you're doing, and there shouldn't be too many use cases today where it actually makes sense unless you're working on Facebook or similar. So why Databricks? What does it bring to us just instead of using Apache Spark? There are multiple optimization options that have been introduced there. I would also say that Databricks is ahead of the other services that you could use for the same purposes, such as HD Insight or Synapse when building a data lake. So Databricks' data lakehouse vision is entirely based on the storage account having the data in the data lake, and Spark, which is why they're also heavily investing into that. I would say that it's better in optimizing the data processing, and also the overall developer experience is better and it's easier to use when comparing to the other options. When it comes to choosing the right VM type, I have some good start-off suggestions. So depending on what kind of workload you want to do, there may be different VMs that are more optimal for you. So for instance, when you're doing typical big data batch ETL type of workload, then you more likely want to have memory optimized nodes, because you have a lot of data in a single, when you're doing a single data processing action. Whereas if you're doing streaming jobs, you have a lot less data in memory at once, and you're more likely to be CPU bound in terms of the resources that you have available. So then compute optimized VM makes much more sense for you. And regarding how to size the cluster, of course, the first thing to check, are we compute bound? You can check the CPU usage through Databricks' user interface. So there's the Ganglia available for that. And if you are CPU bound, then basically the only way to make the processing faster is to have more and faster CPUs. If you're network bound, you might have some high spikes before the heavy compute steps. And for that one, using fewer or bigger VMs would reduce the size of shuffle. So shuffle is an operation where the different nodes in the cluster exchange data between each other when you have an operation, such as a quite normal big join operation needs to shuffle data across the nodes as well, usually. So in that, if the network is your bottleneck, then bigger instances is a good way to go. Also, if you're spilling the disk or using the disk heavily, you can use the L series VMs there, or then just use VMs that has more memory available. So, as a summary, we identified some of the workspace best practices. I would like to add to that although there are the security functionalities available in the Databricks workspace, you should still have project and environment-based separation. So have a separate Databricks workspace per project and per environment, because to be honest, the granularity of that workspace access control still isn't quite enough for to have the whole organization in large companies in a single workspace. So that's another good point to make. And then you can deploy it using our templates or Bicep today. And there's also the APIs available so that you can actually deploy your solution, for instance, your libraries and notebooks directly through the APIs when you're doing your CI/CD pipelines, for instance. From security perspective, we also had some of these points already discussed. I would also like to point out that DBFS, which stands for Databricks File System, is tied to the workspace. So if you delete the workspace, you will also delete the DBFS. And every single one of your users that has access to the workspace has full access on the DBFS as well. So never store your production data on DBFS. I wouldn't use it, or I'm currently not using it for anything. I don't see a real purpose to have any of your real data sets there. And then, of course, storing those secrets to Azure Key Vault is the way to go instead of having them on your notebooks. And of course, injecting the clusters into a VNet makes it more secure from networking perspective. When it comes to tools, we didn't discuss this too much, but I previously worked with VS Code, and there's a good library called DB Connect, which you can use so that you are actually developing your code for Databricks in your VS Code, but actually then running it remotely on the Databricks clusters. So I think that makes sense, especially in larger projects where you don't want to have all your code in the notebooks. And of course, I would highly recommend that the code that you would otherwise need to repeat in for instance, most of your data pipelines, instead create libraries that you test well for that purpose and install the right libraries on your clusters so that you have a better code quality there when running it, and you're faster in developing new solutions as well. And there are the library utilities available for that purpose as well. So to deploy the library and install it to your cluster. Probably the last point I would like to make is that there are really good books available which I've used to study. So for instance, I've read this part, the definitive guide, so I can definitely recommend that one. It's by Bill Chambers and Mate Zaharia. So they work both at Databricks currently. So it's a good reference for those of you who like reading books to understand the entire Spark a little bit better. Also, the book on the right, Learning Spark, is actually available to download for free. So the URL is there. You can just input your own information and then download this entire 400 pages of Apache Spark version 3, MLflow, Delta Lake, structure streaming, and so on, nicely and conveniently to your computer. So here's a nice recommendation as well if you'd like not to spend any more money on books, but rather have them in digital format. Here's a good way of having one on Spark. So that's definitely recommended as well. With that being said, I would like to thank you for attending my session. This was all I had planned today, and more than happy to answer any of your questions at this point.
Yes, Oskari, thanks a lot, and thanks for the detailed explanations. And I have only one question, that too, it's a generic one. One
Yep.
of the audience was requesting, can I get the source file and the data on which it is used, the one which you showed for the demo?
Yeah, I'm more than happy to provide the links to all the material. So of course, the link that I showed for the book. Then of course, if you want, I can provide you a link to the notebook that I used during the demo, and also the Lending Club data link. That's a public data set, so I'm more than happy to provide you with the download link to that data as well. Yeah, will do.
Okay, perfect. So to answer that, then Arnab, we will get the links. Once we get the links, we will be posted. We'll send you over mail. Okay.
Yes.
Thanks, Oskari.
Thank you.
Cheers. Hi, James.
Hey, good morning over here. Sorry, it's evening over there.
Yes, James, it's good morning for you and good evening for us. And I hope this is the last session for the Indian audience.
Cool.
So how are you today?
I got my coffee. I'm halfway through my first cup, so I'm doing good.
Okay, good. So thanks for joining us, James. And let me give a quick intro for the audience, and the stage is all yours.
Okay.
And hi, everyone. James is going to discuss about data lakehouse and the data mesh and data fabric, everything related to the data today with us. And he wants to share his experience, and I'm sure that it will be more interesting, though it is a last session. But again, and James works for EY, and who's our sponsor, one of the major sponsor for this event, and as a data platform architecture lead. And before that, he worked for Microsoft for 7 years as a solution architect regarding, and he worked in various data warehousing projects. And his specialities are the business intelligence, data warehouse, big data, Hadoop, cloud, master data management, management especially, it's very interesting for me. We do a lot of MDMs nowadays, and the machine learning, solution architecture, etc. So uh, thanks, James. Once again, thanks for joining us, and the stage is all yours.
All right, awesome. Let me share my screen.
Yep.
Hopefully this comes up okay. All right.
Yep.
Good.
I hope everyone should be able to see that now.
Yeah, cool. So welcome everyone to the last session of the day. Last but not least. Oh, maybe it's least. We'll see. We'll see what the feedback is. As mentioned, thanks for the introduction. I'm a data platform architect lead at EY, one of the sponsors. I also worked for Microsoft for 7 years before that, the other sponsor. And we already went through the about me, but I'll just point out a lot of the things I talk about in the presentation today, I further expand on in my blog at jamesserra.com. So you want to check that out if you want more information. What we'll go through today in the next hour is we'll talk about what is a data warehouse, what is a data lake, what's the modern data warehouse, and then dive into what is a data fabric, what is a data lakehouse, and what is a data mesh. A lot of these buzzwords are out there, and I know there's a lot of confusion and what's the difference between these all. This is my opinion of what these all are. It's certainly not this industry consensus of there's a lot of this differences in what these can mean, and I'll try to point those out along the way. So when I think of trying to figure out all these buzzwords on my own, I feel like I'm passed out drunk in the Denny's in the parking lot. So I'm going to try to prevent that happening today by trying to clarify what all these terms are mean. And somebody had once asked when I've been presenting this slide for a while, and if that's me, and no, it is not me. I was never passed out drunk at a Denny's. So what is a data warehouse and why use one? So this is what I like to do to kind of level set of where somebody may ask, well, what's the whole point of a data warehouse? Why do we need one? Why can't we just continue doing things the way we have? And I point out there's a lot of reasons on there. Some of the bigger ones is reduce stress in the production system. If you have queries hitting that OLTP application on there, your chances are you're going to get a lot of complaints because those queries can take a long time and saturate the compute of that source system. You can optimize them for read, so the queries can be and reports can be a lot faster. You can integrate many sources of data, so it could be all sorts of ERP and CRM systems and homegrown apps are all put in that data warehouse. You can keep historical records, so you can do it so you don't have to create hard copy reports for every month, and instead you put it all into a data warehouse. You can have things like slowly changing dimensions to keep track of how things have changed over time. So it allows you to go back in history at any time without having to go and save things out like you do in an OLTP system usually. You can make things more easy to understand. If you look at some of the ERP systems, especially, they could use field names and table names like T116. Well, when you create a data warehouse and you move all that data into it, you can rename those fields to something meaningful. The point being, you're going to get self-service. You want self-service BI, so people can, end users can create their own reports without having to get IT involved. And one way to do that is to make the names a lot more understandable. It also protects if they upgrade the source system of the OLTP application in there. You're not breaking things if you don't use a data warehouse. So with a data warehouse, it kind of shields you from updates to the source system. You can add things like MDM, master data management. You can put hierarchies in a data warehouse, things that you couldn't put in the source systems. And to get that end user involvement, the BI on demand by an end user in there, if you set it up a data warehouse correctly, especially with the tools today like Power BI, it could be very easy for end users to create their own reports. And then you can improve the data quality because you'll find problems that with the data that need to be cleaned up as it's built in a data warehouse, and you can go back to the source system and say, hey, we've been getting this field of birth dates, and some of these birth dates are before, after today's date, or the people are 200 years old, and you need to go and fix those. So those things come out when you build a data warehouse. And you get one version of the truth on there. So if anybody has any questions about some of these reports or queries, it's very easy to go to the source system. It's one version of the truth because all the data is collected in one area, and that's your single source of the truth. And then it's very easy to build BI solutions on top of that, like analysis surface cubes or Power BI now. Anything that any reporting tool you want to use can just go to the data warehouse. They don't have to go and recreate all the connections to the source systems in there. So that's what a big benefit you get for data warehouse. And this was another one that's you find many people don't think through is if you have reports going against all the source systems, you have to give somebody access to all those source systems, and that could be a big pain. And they cannot be able to get security for some of those systems. So if you copy everything into a source system in a data warehouse, and you just got to give those people access to that one location, not all those source systems. And then finally, the whole point of a data warehouse is to make better business decisions by getting greater insights into your company. So this is the main focus of a data warehouse. And you're making that process a lot easier by collecting all the data in one location. Now, for those of you who are architects like I am, this is what you may think of as we need to go and build a data warehouse, and we have a bunch of tools. And we need to decide which of those tools we're going to use to build our data warehouse on there. So there's a lot to choose from. However, and I'm going to go over in this presentation, talk about some of these tools. However, there's a lot of tools are available that I'm not going to talk about. Here's a list of those. And you can see it. I could spend probably weeks going over all these different tools and options on there. So we're confined to the Microsoft world, and we're confined to certain products in the Microsoft world in this discussion. There's also a lot of concepts not covered on this deck on here. I don't get into things like comparing virtualization and going into high-availability disaster recovery. So there's a long list of stuff on here. So what makes our job as architects so tough is all these concepts and products out there. So our job is really more like this. We have so much to choose from. And when I'm with customers and trying to figure out what they need, there's a lot of questions I will ask to try to narrow down this large set of tools. And these are some of the questions I will ask. For example, what are your current skill sets on there? So I'm not going to go recommend Spark if nobody in the company knows what Spark even is. I'm going to ask what are your licensing requirements, because that could affect what products I recommend for you. Is it streaming the data? All these things come into play. So it's really important when to do discovery, when you're looking at building a data warehouse, and ask all these questions. And we'll make this deck available so you can use it as a takeaway on there. But this is where I see a lot of problems with new data warehouse projects. And a big reason why they fail is there was not enough time put in to ask a lot of these questions. So make sure you carve out that time. What is a data lake? This, fortunately, don't have to explain to customers for the most part nowadays. And I deal mostly with the larger customers. But there's plenty of smaller companies that may not know anything about a data lake. And so you want to point out why a data lake is in almost every case is going to be part of building out a data warehouse solution, no matter what concepts we're talking about. And the things I like to point out, especially if it's a company that has built a data warehouse or relational database solution, they may go, well, what's the point of a data lake? And the first thing I point out is think of a data lake at the very least as a staging area for your data. Instead of putting a staging area inside of your relational database, and you have the issue when you do that, you have to have a maintenance window, kick everybody off, you load data in there, and then you clean it, and then you make it available for end users. And so what happens if that maintenance window, you start bumping up against it, and you're just importing so much data and cleaning it, and you're running into issues where there's a problem, and now you have to keep people off of the relational database data warehouse until you fix it. So what you can do with a data lake is you copy all the data into a data lake, which is a schema on read, which is just a glorified file folder. I can copy data in there. I don't do anything up front. And then I can, within this data lake, which is just storage, I can put compute on top of that and clean it all in this data lake. And when it's all finished, I can then copy it into the relational database. And so instead of having this large maintenance window, I may only have a few minutes where I'm copying that. All that cleaning is done in the data lake. So moving that staging in there is a big one there. Plus, you can use as much compute as you want. If you want to pay more for extra compute to get the data cleaned faster because you're getting more and more data in there, you can do that. You're not limited on the compute in the relational database. You can also use it to explore data. I was a DBA for many years, and I had clients come to me and users say, hey, this data, I think we can use it. Can you put it into the data warehouse? So I would go into that relational database, I create a table and the fields and the schemas and write the ETL and copy it in there and do all this work, and then say, okay, it's ready. And they would look at it and come back and say, oh, actually, we don't need this data. It turns out it's not valuable. And you say, well, I wasted all this time. With the data lake, because it's schema on read, I can just copy it into a folder. And you can have an end user, especially with the tools nowadays, who can just query that and see if it has value. And maybe they just need a one-time report and you're done. Maybe they see it needs value and you can then copy it to a relational database. But you're avoiding all that wasted effort for something that turns out to be not important. So those are just a few of the things on here. So a lot of reasons to use a data lake. And we'll talk more through about some cases where you want to use just a data lake. And there's a very rare case when you wouldn't want to use a data lake anymore unless it's a very limited amount of data. But you also have to think about your future. Too often I've seen customers say, well, we can skip the data lake because we don't have that much data. And that's true today, but a few months from now, they get more and more requests. And they find out, well, we should have had a data lake because now that small data warehouse has grown tremendously. And it always happens. A data warehouse never ends. It's always growing. And people start using the data and they see the value in it and want more and more data on there. So always expect that your data warehouse is going to grow by leaps and bounds with requests to put more data inside of it. So if we have both a data lake and a data warehouse, what are the differences at a high level? And this is where I have this slide. So you can think of the data lake as the staging area and the prepping areas I talked about. And then the data warehouse will become your serving layer in security and compliance. And the reason why you have both is there's certain trade-offs that happen if you don't have a data warehouse, this relational solution, and just have a data lake. And we'll talk through some of those, but right away is you think of the security. In a data lake, it's a file and folder base. So there's no row of security or field level security in there. So you may want to have a data warehouse for that reason. It also could be for performance. A data lake can get you very fast queries, and it could be seconds, but that could be too slow if you're creating a dashboard and you need to slice and dice the data. And so you want to put it in a data warehouse for millisecond response. And sometimes it's just people are more used to the data warehouse in a relational format in there. So this is those top points I can think of why you want to have both. And we're starting to see a little bit of situations where you can go with a data lake and not with a data warehouse, and I'll talk more about those. But I would say in 99% of the cases, you're going to want to have both a data lake and a data warehouse and understand the difference between the two and the purposes of the two. The data maturity stages, this is what I like to cover with customers to see where they are in the journey. And most of them are in stage 2. In that stage 1, you have data all over the place. Stage 2, you're starting to collect and centralize this data. And this allows you to go and look at the rearview mirror and look for patterns, look for reasonings why, for example, my bicycle sales are not good in certain states. I need to collect all this data and centralize it and start running those queries and dashboards against it. And that's great, and that's where most people are now. Where you want to go, and it's important to know the additional benefits you can have by building out a data warehouse, is you get to the predictive and transformative stage, where I can start to apply machine learning. So instead of being able to just look where I've been, I want to look where I'm going, and I can do things like predict when parts are going to fail, or have machine learning models that help upsell people. And so all those come with collecting that data and then running those machine learning models, training them on that data. And then you get to the transformative, where I view it as part of this digital transformation you hear people talking about. And that is to be able to collect data, no matter what the size, the speed, or the type. And so you want to build a solution that you're not going to go 3 months, 6 months, a year later, oh, well, we can't handle this data. We have a request for streaming data, and we can't support that in our system, in our solution in there. So spend a lot of time up front thinking of the use cases that you're going to need, hence all those questions, and you can make sure you can build something out that's going to last for quite a while. Okay, let's start with the modern data warehouse concept. And this is sometimes where I whiteboard it. For saving some time, I just put the result of a whiteboard. I always break it out into 5 stages. You want to ingest data, store it, transform, clean that data, model it, put it into a format that's more conducive for an end user to run queries and reports off that, which usually involves a relational database. And then you can have some visualization on that. And I put machine learning at that phase. Machine learning can come earlier. That little guy with, or guy or woman with the hat on there is a data scientist. And they may have the skill set to access data when it's sitting in a data lake. So one of the complexities about data lake also is it's a file and format. So it's just could be essentially a bunch of CSV and Parquet files in there. So it could be difficult for end users to understand what all that means. But a power user, a data scientist, and especially the data scientists, sometimes want it in a file format. And so they're fine going against the data lake and not having to wait to get to the relational database. And when you look at this, some people may go, wow, this is extra work, extra ETL to copy the data along. It's extra cost. And it is, but the benefit is the data comes along and gets to a format that's very easy for self-service BI. So to explain that further, when we ingest the data, and I'm putting here Azure products, Azure Data Factory is usually that tool, we land it into a data lake in a raw format. And the data lake has a number of layers. And within each of these layers are file folders on there. So for raw, it may have file folders breaking out by source and then maybe by date. And then you need to clean that data. So once you do that, you put it into a clean layer, which could have its own file formats. Maybe it's by subject matter, like HR and finance. And then you could have another layer called presentation, where you maybe join some of that data together and make it to a point where people can start running queries and reports right off of that presentation layer. You could also have a sandbox layer where you copy the data, and maybe the data scientists want that. And this data lake design, I could spend a whole day just talking about that. So it's very important to have blueprints of what you want your data lake to look like, and you do that by understanding the source systems that you're going to pull from and how they would best fit in a data lake on there. And I see a lot of customers usually have at least 3 different layers in there. They may call them something different. I'm starting to see more layers in there called conform layers, because they may have data that's CSV and Parquet and JSON, and they conform it all into one format, usually Parquet, and they have that as a layer in there. And once you create these layers and you start copying data in there into the raw, and to get it to clean, well, now you have to have compute on top of that. So we use in Azure World, Azure Data Lake Storage Gen 2 to store the data. And to clean it, then we have a lot of options now. And this is where I'd say it can get confusing, and you have to really dive into the end users to find out what works best for them. Because you can use Azure Data Factory data flows. That's my abbreviation there, which is a very visual interface that once you create it behind the scenes, it when you go to run it, it takes that data and puts it into a Spark cluster and runs it. So I always say it's a pretty interface over Spark. You can also use Databricks, especially if you have end users who are used to Spark to clean the data. And you can now use Synapse Serverless. You can use T-SQL over that data. So that can be a more cost-effective solution and helps out those who love T-SQL, which are many. And you can even use Synapse Spark on that. So I didn't list all of them here, but usually I see customers use a combination of them. I always say go at Azure Data Factory Data Flows because it's easy, and do it until you can't, until you come in a situation where maybe you need faster performance or you need additional features that are not in Data Factory. Maybe you need to run some Spark library to convert data a special way or encrypt it a special way. And so you want to maybe for that use case go out into something like Databricks or Synapse Spark. And then in step 4 is you want to model the data in relational database, and you may move it into a third normal form in there. And that may be fine, especially if you're using Synapse with its MPP technologies. But you may then also want to copy it into a star schema. That's what SS is, because now you're getting faster performance when you query a star schema, and also you're defining all the relationships between the data. So the end user in step 5 in Power BI can easily drag and drop fields on a Power BI workspace in order to build the reports, because they don't need to know how all the data needs to be joined together. You did all that work for them. So to close out what I was saying before is, yeah, it costs more money and it takes more time to get it to this end format, which could be star schema, which could be in a Synapse dedicated pool, or it could be in a tabular model in Power BI. But you've made it much easier for the end user. And as opposed to just putting it in a data lake, you have to have a lot of extra skills to get the data in there. It could take longer to query things. You're just doing all the work up front, because somebody's got to do the work wherever it lands. If you're a data scientist going into data lake, you have to understand the data, and you have to write queries on top of that, and you have to create the metadata for it in that query or that view. IT can do all that work for other people. So think of all the trade-offs when you're looking at a modern data warehouse. Now, what this would look like in a prettier diagram, applying some more products on it, is like this. So each layer in here can have multiple tools. I even put on here, you can have like SQL database, SQL Server. That would be if you have a very small amount of data. You could start out with something like in SQL database, but be aware it's probably going to grow, and maybe you just don't want to have to convert later and just use something in Synapse, especially with Synapse having a serverless option that right now only goes against the data lake, but hopefully soon will go against a dedicated pool of relational database. So you can save a lot of costs by having that serverless and not have to go to the more drastic step of using something like SQL database to save costs. And these products span more one area in here, but I put in what they're mostly used for. And I'll also point out that with Power BI, you can use that for all of these steps on here. I view Power BI as a self-service ETL tool that is not for an enterprise solution, and it's not for IT to use, but rather for end users to maybe have a quick win. They can use Power BI to do all of this, all the cleaning in there, because it has its own data flows or Power Query in there. Or you can use Power BI to prototype. And this is what I think is going to get popular, is instead of IT going to an end user and saying, well, give me your requirements and I'll go and build something for you, they could just say, go and build it in Power BI. It's a pretty easy tool. I'll use that as requirements. And you can even take some of what they built and put it and copy it, the code, into a enterprise solution in there. But Power BI can be that way to prototype things and use for business requirements. All right, what's a data fabric? The modern data warehouse can be thought of as by adding additional features as a data fabric. So this is where I'm seeing some confusion. Some people are just calling the modern data warehouse a data fabric. And I'm seeing data fabric being used more often now, and maybe modern data warehouse term goes away. But I think of data fabric as an extension of a modern data warehouse where you're adding additional features to it. And you're doing things like master data management, MDM. You're having metadata catalogs with lineage on there. You're having data access policies on there. Maybe you're doing ABAC, attribute-based access control. Maybe you have data virtualization on there, and you do real-time processing, which you typically don't do in your typical modern data warehouse. You need real-time streaming in there. And it could be things like having data science tools and making all your data available through API calls instead of having to connect to the data. And then lastly, you may build out your data fabric in building blocks. And you can call those building blocks products too. The idea being is maybe I have this data fabric and I have a data ingestion piece and I have a storage piece and a master data management piece. And those could be used outside of data fabric. Somebody may come along and say, well, I can't use a data fabric, but you built this really good data ingestion piece. Can I use that? And if you built it where it's generic enough, you can have that code copied to that other group within your company, or maybe you create an instance of it and build it that way in there. But a data fabric could be built in a way that a lot of code reuse can happen outside of the data fabric. All right, let me take a coffee break so I don't lose my voice. So hopefully that level sets what a data fabric is. It's a glorified modern data warehouse. The other term you hear a lot about is a data lakehouse. What is that? If we look at the history of data warehousing, late 80s, that's kind of when I started, you just had a relational database in there. That was it. If you had a lot of data, you can use products with MPP, massive parallel processing technology like Teradata and Netezza. And eventually with Microsoft, it was the parallel data warehouse, which I first worked on when I came to Microsoft. Then in the late 2000s, only maybe 11, 12 years ago, came this idea of a data lake. And this was all on-prem at the time. And you could have this glorified file folder where you just dump everything in there. And some people went the route, well, we don't need a relational database anymore, we'll just put it in the data lake. And that failed spectacularly. I have some great examples of customers who came to me and tried to build a data lake and said, we don't need relational databases anymore, and it just didn't work out. So they learned from that and said, we'll have this cloud data platform that'll be a combination of a data lake and a data warehouse, as I've drawn out in this presentation. Now what you're hearing recently is the term data lakehouse. It's taking a data warehouse and a data lake and calling it a data lakehouse. And this is getting popularized by Databricks. The idea being, let's just go with the data lake, but we're going to learn from the mistakes of before by making the data lake more powerful. And the way we do that is by adding a Delta Lake on top of that. Think of a Delta Lake as an abstraction layer on top of a data lake. It's not storage in itself, it's just adding functionality to a data lake. And some of that functionality is things like ACID transactions, which you have in a relational database but don't have in a data lake. So it gives you support for that. Time travel, where you can version files, which help for auditing, but also having to roll back. So I can go in there and I can query data and I can put a date in there as of, and it will give me the data from that time and ignore what's happened after that time. It's kind of neat. It makes it easy to do streaming with a Delta Lake. It can enforce schemas in there, which is very important, as opposed to an open world where people can just throw all sorts of files in a folder and the schema could be way off. Delta Lake can enforce it, so you're not having queries that are blowing up. It also has better performance, especially when it comes to updates and deletes compared to a data lake. So by putting all of these features on top of a data lake, you can have your data lake at least in theory, have some of the features of a relational database, so you don't need a relational database. So those use cases for that, the reasons for that, that you can go with a Delta Lake and not a relational database is because of these four reasons, that these four issues that you can solve. One of them being reliability. If you have a data lake and a data warehouse, you have to keep them consistent because you copy one data from the other. So you can have problems if ETL blows up. Now the data lake could have data that's different than the data warehouse. You also have staleness when you have both of those, because maybe you only copy over once an hour. So the data lake could be newer compared to the data warehouse. If you're looking at analytics, and especially machine learning tools, they generally want to work with files. And so a data lake is better for them. And so you can have more possibilities when you're using machine learning tools on a data lake compared to a relational database. And then lastly, is total cost on there. I have 2 copies of data. It's going to cost me a lot more money than just having 1 copy of that. So these are the reasons why you could look at just going with a data lake and not a relational database. However, there are trade-offs, as everything in life. One is the speed. I touched on some of this before, but the idea is relational database, they have things like query plans and statistics that and indexing and a lot of things and features, especially when we get to MPP technology, that can just make it a lot faster than a data lake. Now, maybe your SLAs will say that's okay. If the queries take a few seconds, that's fine. I don't need the millisecond response. But there may be times when you just need that speed. So especially when you're doing slicing and dicing of dashboards and stuff. So keep that in mind, that performance will suffer. No security, security is not as good as I mentioned before. You don't have role security, COM level, dynamic data masking. These things are not in a data lake or a Delta lake. Now, there are workarounds. You could add additional products into a data lake or Delta lake to get some of this, but now you're adding more cost, more complexity. You're having additional copies of data inside of the data lake to do all this. So if you're going to do all that, why not just go from a relational database on there? The complexity, what I find is if you have a data lake and you have all these layers and these folders, if you start copying a lot of sources into there, you can have hundreds of folders, and it just gets very complex. And it's very hard for people to navigate a world where it's just files. So they want the work done to put it in a relational database, because in that case, the metadata is combined with, it overlays the data on there to make it much easier to find data and explore it, compared to a data lake, which has files which may have metadata inside the files, which makes it tougher to find out what those files are, or it may have a solution that keeps the metadata separate and other files in there, but you have to have a tool that knows that the metadata is separate, and there can be a disconnect that could happen at times on there. So it can just get so nearly impossible for people to manage and query a data lake when there's a lot of sources in there. And then the data lake, there's still missing features, even though you have Delta Lake on there, like things like reference integrity, workload management, certain encryption are just not into a relational database or into a data lake in there. And you're usually locked into Spark. So if you're using Delta Lake, it's Spark. So if you're a customer that doesn't want to deal with Spark, then you want to stay away from things like the Delta Lake. And then finally, people are used to a relational database. I had somebody point this out the other day, is that if I have end users and they've been spending years using a relational database, and now you're switching to this data lake or Delta Lake world, it could be a huge change for them, which may not be worth it. And it may be better to create a relational database. Now, this is where with Synapse is where I'm starting to see some exceptions to that. Because with Synapse, you can have T-SQL over the data in the data lake. And this was the big change, because in the past with a data lake, if you're using a tool on top of that, require you to maybe use Hive SQL or Spark SQL. And that is a big change for some end users compared to T-SQL. Even though it's pretty close, some people don't like change. And if you say you have to learn a new language that's different than what they're used to, you may get a lot of pushback. What Synapse did, one of the great things it did was it makes it so you can use T-SQL over data in the data lake. And I can create a view that points to that file and has the metadata in there. So the select statement will have here are the fields. And once you create that, an end user can use that view, and to them, they think they're using a relational database. But the reality is, behind the scenes, it's data sitting in a data lake. So that opens up a whole new world where you can create views on top of the data in a data lake, and that is your metadata layer, and that can make it much easier for end users to use data in a data lake. So you've done some of the work, but not to the point of building on a relational database. So that solves the problem of making it the complexity. And then if you're using Power BI, that can solve the problem of speed and security, because with Power BI, you can ingest the data into Power BI, and you can have a tabular model, you can use aggregation tables, and those will give you the millisecond response time, as well as in Power BI, you can have row-level security. So I'm starting to see customers now who are in the Microsoft world using Synapse and Power BI and getting away with not having a data lake or not having a relational database. And if you get to the point where you go, oh, well, actually, we do need a relational database, maybe we need faster speed, you can copy that data into a relational database, say the Synapse dedicated pool, and you can just use the same T-SQL, just point it now to that relational database on there. And as down the road with Synapse coming out with its next version, and it's going to have serverless, not only on the data lake, but into a relational database and multi-clusters. It's additional features that are going to make it even more popular to start putting solutions just in a data lake. So, which I never thought I'd say a few years ago, but now I can see the benefits with Synapse and the cost savings and the less complexity of using just a data lake in there. But I still think in the end, it's still going to have a large majority of customers are going to have both. All right, data mesh, which has been all the rage lately. So looking at that history that I showed you before, we're now adding one thing to it. All that history before was always centralizing the data. It was always copying it from all these source systems and locating it in one spot that IT controls and has ownership over, and IT cleans it. And where the data mesh is coming from is this decentralization approach. Instead of copying all the data into one location, we keep it in these various domains. And the way that works is if you have domains like HR and finance and payroll and operational data, those you break it out by domains, and those domains have ownership of the data, and you're not copying it to a central location. So IT is not getting ownership, it's those domains are kept with the ownership. So that's the first point. It's a mind shift where the domains have the data, they clean the data, and they make it available to everyone else, and they stay as the owner. Now, IT will have a say in how the data is cleaned. So you want to have what's called data infrastructure as a platform. It could be, here's the way, a framework for what you should do to clean the data. So you can't have somebody saying, well, I'm going to clean the data and I'm going to use abbreviations for states, and somebody's going to use the full name. You have to have these standards that are created so everybody's cleaning data the same way. And you can also provide to them certain pipelines that they can reuse, templates, all these things to make it easier for them to manage the data. Because you're giving them more responsibility now. And therefore, they're going to need more help. So this is where we now have cross-functional domain data teams. Instead of having all those people within IT, you essentially hire more people, and you hire those engineers to be within all the data and all those domains on there. There is less ETL because you're not having to copy all the data into a central location. So that's where we list the second point on here is the pipelines. Instead of the pipelines being this big concern, it's the domain data. And now we start thinking of as data as a product instead of data as a byproduct. So what you tend to do in a data mesh is you create these, IT will create these contracts that each domain has to abide by to make it easier for others to access their data. And therefore, they're treating it as a product by following that contract. And then you go from having a centralized data lake or data warehouse to all these data products that are separated out. And the use cases for data mesh, the problems that it solved are lack of ownership. Who owns the data if we're copying it to a central location? Is it IT or is it still the data source team? So now we make it clear it's the data source teams that own the data. Lack of quality meaning that instead of having IT clean the data, which they may not know very well, you're now having the data domains clean the data who know the data best. So it improves the quality of the data. It also improves scaling. Instead of IT being the bottleneck, everybody's going to copy it to a central location. If you want a new data source in there, you have to wait till IT has time to go and do that. Instead, you have all the domains who've hired people to do all that work, so you're able to scale. So if you have dozens or hundreds of domains, and each of them has their own team, they can go and clean all the data, do things to make it available, and not have to wait on IT. So IT is not the bottleneck. And then the last one being technical scaling, and that the current big data solutions are struggling with encapsulating all this data on there. They can't scale. So by having the data separated out and kept in the domains, as I add more domains, each of those domains get their own compute and storage, and you can scale out that way and not have to worry that by centralizing everything, those big data solutions can't keep up with that. That's the theory. That's the idea. And understand that data mesh is not a technical solution. If you read all the documentation on there, it's mainly an organizational change. It's a different way of thinking of things. There is no technology behind it. That's where one of the problems is something can sound great in theory, but is it viable to build this? And that's one of the concerns I have with the data mesh, as well with many other. So I'm gonna start bashing data mesh here. I will point out that I have seen some customers who could be good use cases for data mesh, and you just need to be aware of all these concerns. So if you go through these concerns and you go, hey, you know what, I'm aware of these, James, but I think it's still data mesh will work for us, then go for it. But don't jump into a data mesh and start building it without really going through all these concerns, because it's very likely it won't be for you. So some of the concerns which I've listed here, I have more of them on my blog. I didn't even put all of them in there because I could go on forever as I'm talking to more and more customers who are building data meshes and finding some of the issues they're having. One of them is no standard definition for data mesh. I say if you talk to 10 people and ask them what a data mesh is, you'll get 15 different answers. So how can you build out something that nobody has a consensus of what it actually is? The other big thing is it's a huge investment in organizational change. So the first thing I ask companies is your organization open to massive change? Because now you're going into domains and you're saying you need to clean your data, you need to aggregate it. You need to do all these things instead of IT doing it. You may get a lot of pushback from that because now you're telling them you need to build your own teams. They may go, well, I don't want to do all that. And you're pushing this contract on me, and I'm just focused on building out my solution and satisfying my needs. Why should I make all these changes, do this extra work? Because saying it's for the greater good of the company may not work. And you have to have incentive for them. So this is where it can get really challenging, especially if you have dozens or hundreds of domains in there. And all it takes is one to say, I'm not doing it. Now you have some outlier. Now you have, how are you going to incorporate their data? Because at some point you need to collect it all together for a lot of reporting, which is the next problem. Is if we have all this data and it's all separate in their own data lakes or relational databases, now we need to combine it. Then regardless of what you hear data virtualization companies say, is it's going to be a massive challenge performance-wise to combine all that data. And then where do you master the data? And so there are within a data mesh, they have ideas of taking domains and aggregating them together, which I find interesting because it's kind of goes against the point of, I thought of a data mesh is to have everything separate. Now you're saying, well, we need to, for performance reasons, aggregate that data together because now you have additional ETL pipelines. So there's some things that are just kind of inconsistencies in the data mesh approach. And what I find a lot of customers have exceptions to what the theory is. And they may not centralize, they may not have the data separate in different data lakes. They may create one data lake and just have different folders. And that could be your solution for ownership. I'll have separate folders and I'll just say each of the domains owns those folders, but it's all located in one data lake in there. So there's a lot on here, and I don't want to spend the rest of the time just going through all these concerns, but just be aware of all these. And I would say the final one too that I see is, well, two things. One is it takes a long time to build data mesh. This is not a shortcut. This is going to take a lot longer to build in a modern data warehouse or data fabric. So you have to be aware of that. And the other is, if you're going to combine all this data, which you always are, and each of those domains are thinking just in terms of what helps them in their domain. They're not thinking of the bigger picture. So they may do things to help their situation, but it hurts the enterprise view of all this data. And so you have to do this extra work to pull this data together because they didn't put it in the format that's conducive to joining with other data. So these things all start coming out when you have everybody going, kind of doing their own thing. Yeah, they're following the contract, but they're still focused on solving their own needs and not the enterprise needs. So that was the benefit of copying all that data into one. You can have central IT looking at the bigger picture and then putting that data in a format that makes it easy for others to query who need views of all the data and not just one domain. However, if you do go with a data mesh, just these are the keys to keep in mind in there. Have pain points. Don't say, I'm just going to use the data mesh and everything's working pretty good now. Is what are your challenges now? If you have problems with ownership and scaling and these other things in there, then maybe you want to look at a data mesh. You have to be very open to change. That this is going to be by far the biggest problem, is organizations that are not open to that. And you have to have people that can influence change in there. So that could be a lot of work. Just think of all the time and effort it could take to convince possibly hundreds of domains that they have to change the way they're doing things. Of course, you want to get experienced people, find somebody who's done this before, which is going to be a challenge because there's not many out there have built data meshes. The concerns I talked about, don't just say, well, this is a cool buzzword, it sounds great in theory, let's go and do it, without doing a lot of upfront work and research on a data mesh. The vendors have almost got to the point where they come out and say, we have data mesh in the box. So don't go by that. Understand data mesh more fully, realize it's not a technology thing, it's an organizational change. So I don't care how great your technology is, it's not going to help with this organizational change. And even virtualization software, which a lot of it is really good, but it has certain limits. You got to be aware of those limits if you're going to use virtualization software in a data mesh to say join all those domains together, adding extra complexity, extra cost, and there are situations where the performance will still suffer. And don't go by the book, meaning this is the theory that was proposed, I have to go by that. There will be exceptions to it, as I mentioned, like centralizing the data, and have a long runway, because you could build something in a modern data warehouse that may take a year. If you go to the data mesh, it may take 2 or 3 years. So be aware that you need to have that extra time to go out to the data mesh. Well, what does Microsoft think of this? Since we're talking I'm talking in an Azure conference today. So Microsoft, and this is my view of Microsoft, having worked there, and then they have groups within Microsoft who are building data meshes for customers. And then outside of Microsoft, just seeing how people are going about building data meshes using Azure. You tend to find, as I touched before, the data infrastructure is centralized, and the storage is part of that, and that's all centralized on there. So it allows you to have the data in one spot, and then you'll have access controls, because that's the other thing, security. If you keep that data separate in those domains, you're now relying on them to do the proper security on that. So that makes me queasy, because all it takes is one not to do it, because IT is now out of control of that. And as much as you tell them this is the way you should be doing it, you may not have people that follow those rules. So if I centralize the data, I can also centralize the security. And if we look at this in solving in Azure, there's links now that Microsoft has where they first called it a harmonized mesh instead of a data mesh, and now they're calling it enterprise scale analytics. So you can go to these links and you can see Microsoft's view on how to build a data mesh or enterprise scale analytics with Azure. And it's really good. They have ARM templates and GitHub and the link there, and you can go by this blueprint or framework to build out a data mesh in there. And you can see from this diagram, you have all these nodes, those are domains. Each of those domains have their compute on top of that, but the storage there is a data lake that's centralized but broken out into folders. And therefore, and you can see that on the top right, therefore you can, again, it's not fitting the theory, but it can be much more performant, and you can have IT focus on the security, and it could be a better option than trying to do the data mesh complete theory on there. So have a look at this to see if this will fit into your needs if you're building a data mesh and you're in the Azure world. And usually I'm going to ask, well, okay, we have a data fabric and a data mesh. What are the differences? Especially if I have a data fabric and I say, I'm going to use data virtualization in there. So I can keep all the data separate in these different domains. And what I found is that usually with data virtualization, customers are not keeping all the data separate. They're just having a few pieces here and there that are virtualized, and they're mostly copying everything into a centralized location. It could be that they keep it separate and use virtualization because they need to keep data in the country, is the big example on there. So that's a part that's like data mesh-like, but everything else is centralized. And if I'm using virtualization, it's still not where you're creating the data mesh full on way to go about it, where you have contracts with these domains. You're just still having IT have ownership and control of that data. They're just keeping it outside of central IT for security reasons and such. And usually you will still have that IT team, and you're not going out and saying, we're going to essentially reduce the IT staff and we have all the domains hire their own data engineering teams. That is not part of just the data virtualization in there. So it's not where I have data fabric and virtualization makes that a data mesh. Now, this is where we get confusion too, because I've seen Gartner say that a data fabric and data mesh are the same thing. And hopefully through this presentation, you see my view is that they are two different things. And it's just sometimes a matter of people using different using these buzzwords and have different definitions for them. And then I have this slide to try to help understand the differences between the two. And most customers are going to go through the data fabric solution in there, because the data fabric is going to focus on the consumption of all this data. And when we get to ontologies, it's the relationships of how all this data, creating relationships between all this data. So the other problem that data mesh struggles from is each domain is just concerned with their data, and they're not thinking about how this relates to other domains. With a data fabric, you can create a system, even a graph database that shows how all this data is related, these different domains on there. That's a lot easier to do if the data is centralized and you have one unified group looking at the data and defining those relationships on there. You also have, with a data mesh, multiple governance layers. You can recommend how they govern it, but all those domains are governing it. So you can have dozens of governance layers, which, as I mentioned before, with security can be a very scary thing, as opposed to IT collecting all the data and putting their own security on top of that. So that's the third point there. And then the consistency is, how do we apply that consistency across all of this? The issue I have, or another issue I have with the data mesh is, as I mentioned, you can have the states. I define states as abbreviation or full name. So you have a lot of that inconsistency that can happen with the way they go and they govern the data on there. And they can do it very differently than all the other domains. Think of languages. Each domain can say, I'm going to use my own language in there. Okay, great. Now, how are you going to join all that data together if all this data is in different languages? If you have a data fabric, you copy it all to one, you decide what that unified language, what one language is going to be, and you pull it all in there. So you don't have all this extra complexity of trying to join the data together. And then maybe the biggest point is, in implementation, it is extremely complex for a data mesh to build. And you can go out there and you can see there are use cases and videos of people who built out the data mesh, but nobody goes, oh yeah, we built a data mesh in a couple months. It's usually, we've been building a data mesh for 2 years now, and we just got it put in production in there. So it's a lot simpler with data fabric, especially if you have data virtualization tool. You can make it easier to keep data separate and pull it in on there. And you can have things like a metadata catalog. You can create, it's a lot easier to create things like master data management, which is the other big thing in data mesh is, if you have all these domains and they're all having customer data, and now you say, I need to combine that data, and you can have duplicate customers, well, where's the mastering of that data done? That's the whole point of master data management. You have to combine all that data to find the golden records. If it's all kept separate, how do you solve that? And the solution that data fabric, the data mesh people talk about is, to me, not good for MDM. So that's another big concern you have to have. So in the end, you have to think through all these concerns, and maybe you'll be okay with all those concerns and you'll go to data mesh route. But I think most people are going to go the other way of a data fabric. So it's going to be interesting to see in the next few years how popular data mesh becomes. And the concepts in data mesh are not new. They've been around for a long time, and they're just given a new name. And it's still, there's good work in understanding whether you use data mesh or data fabric. When people are talking about the data mesh, they are seeing the value of data. They're seeing, however you want to do it, where you can make better business decisions with data, where you can build machine learning models, and in the end, make those better business decisions. And so you can see the true value of data. And that's the whole point of whatever technology you choose is, in the end, you're going to have people who are going to be able to query that data and report out that data and see insights to things that they never knew before, and therefore make those better business decisions. All right. That is it. I want to thank everyone for attending. If you have further questions, I don't know if we'll ask any here, but I'm happy to have emails, questions to me. I expect I'll have some. Don't be afraid to shoot out an email with a follow-up. And then, as I mentioned on my blog, I talk about these topics too, and there's a lot of Q&A at the end of some of those blogs that you may want to look at to help you understand all these different terminologies. So thanks, everyone.
Thanks a lot, James. And as you really said, considering the timeline also, I'll consolidate all the questions and I'll post it over email. And
Sure.
Okay. Sure. Thanks, James. We have Annie. Hi, Annie.
Hi, Satish.
How are you?
Very good. Thanks. Did you have an
Yeah.
exciting day?
Yes, Annie. And it's been quite a long time we spoke.
Yes,
I
indeed.
hope it's a year about.
Yep. Very excited to be here.
Yep. Okay. So the stage is all yours, Annie. You can. I hope you're able to present it properly.
Yes, if you can see this.
Yes. The
Thanks, Satish.
new developer agenda. Yep.
All right. So 3 people are hired every minute on LinkedIn. That's good news for us. And software developer jobs are growing, but the top skills that companies want are changing. The last year definitely has changed the fabric of talent out there and what companies really need, because a lot changed for the organizations themselves and even for entrepreneurs. Definitely there was a recession, one of the biggest recessions that we had. Now, for a moment, think of the recession as a sharp curve on an auto racetrack. What is on a racetrack, what is the a driver actually doing when it reaches a turning point? She kind of decelerates, does not stop at a sharp curve. It only decelerates, right? So decelerates, changes direction to reach the apex, changes direction again, reaches the outside apex, and then accelerates. Now, why am I telling you about this? It's pretty much same in terms of organizations that have gone through recession and gone on to be leaders, front runners, or lagged behind in some sense. So a lot of study has been done on organizational behavior during recession and what are those decisions they make that actually transforms them into either that makes a huge gap between some of those front runners and followers. So interesting to note that the front runners, even while in recession, even while cash flow is trapped and things are changing and everything is ambiguous, is taking decisions on talent, on where to invest, on what markets, how to leverage the digital technology, and make the right investments, which pay out in the long run. Now, Karl Popper is a well-known poet, a kind of a scientific poet, and he's written a lot of essays, but there's one delightful essay on clouds and clocks. So he talks about everything being one of these two kinds. They're either clouds or clocks. Now, clocks, typically you can take them apart and put them back together and it'll work. But clouds are not typically like that. It's an emergent system, right? Much like digital transformation. So the various elements within the rain clouds, the atmosphere, water, the heat, all of that interacts to actually create those rain clouds. And then again, whether it rains or not depends on a lot of other things. So we look at digital transformation much in that lens. Now, considering the whole post-recession economic recovery that we are all in at various stages in various countries around the world, and considering that everything has gone digital, there is something new that developers need to pick up. And if you master the new developer agenda, you will lead yourself and your company to outperform the market. Let's take a look at this. Kerala, I come from Kerala, and this is the southernmost state in India. In 2017, there were some really humongous flash floods, which literally brought the whole state to a standstill. It was a huge calamity. Now, there was the small team who tried to create the disaster recovery plan around using software. And you can look up Bodhish Thomas on GitHub. And he has all his repos there. Go check it out. But that small team kind of did something very amazing, bringing a lot of voluntary organizers to voluntary coders, literally, and designers to come together and create the software to manage those floods. Cut to 2020, February 4th, COVID emergency was declared in Kerala. By 4th March, they had a preliminary digital war room ready. It just took them 21 days to the libraries. What was going on here? So Sanjay Vijayakumar is the CEO of Pupil First. He's a big open source proponent in the sense that he promotes a lot of those open source communities. So he got together with Bodhish, brought in the government, private organizations like Microsoft, like many others, and got together this little software, which then grew into what you're seeing now in the picture, which is a complete digital war room, which is triaging not just the police and public services, but healthcare, as well as all the people-related issues of change management. So all of this came together in a digital war room where if you contract or you think you have COVID, you can just call into the war room and everything till you get to the hospital and you go back home is covered here. So amazing traceability as well. So it's interesting that that small open source group of people actually created it. So this is one of the new skills that you need in this new world, which is about bringing together with very disparate elements and able to create synergy. Here you see Mel Gibson and Danny Glover. If you can guess the movie, Lethal Weapons, very unlikely partnership, right? But they went on to do something amazing. And of course, Lethal Weapon is almost at the 5th series. So creating that synergy is super important. Now cut to this other thing that happened during the pandemic. In the whole retail industry, there was so much of transformation that happened, so many challenges because all the physical stores went away. Everything was dependent on online transactions. Now, ASOS actually found that people were buying, but a lot of it's being returned. So their net, they were not able to really move their business along. But somewhere along the way, Tim Carey and his team had actually been working with AR technology. And so now, because they had been experimenting and it was almost ready, they brought it out quickly onto their website. So consumers were actually to go online, use the See My Fit application and check it out on your own personality before you buy. And needless to say, that immediately reduced the number of returns they were getting. And another one that actually happened only because of the rapid experimentation. And something closer to home in India, Myntra. So Myntra used to have, much like all the other retail commerce and the real retail stores, you have 2 fashion seasons, one in the summer and one in the fall. And Myntra similarly had a few fashion seasons. But suddenly, once the COVID hit, they were not able to figure out what fashion is in play now. Because people suddenly changed from, I'm having a formal job, but I'm wearing pajamas at the bottom. Kids were not going to school. Everybody was home. So what is it that people want? There's still an element of fashion in there. So they kind of started putting out a fashion new season every week. Now, the amount of data that flowed in from that allowed them to actually figure out which markets to focus on, which stores, which segment is going after, which products, and they were able to completely revitalize their business using that. Now, Amar Nagaram, the CEO of Mantra kind of says that very well, that the data went up to about 6 to 7 times pre-COVID. And because they had already been working on Azure Machine Learning, it enabled them to scale up overnight. So this is about complex problem solving and deep skills that you need. So all of the digital transformation, and Satya talks about this very well. He talks about it that it's not just about technology, it's about cultural synergy and a lot of other factors. And what does this mean? He's talking about rapid experimentation on one hand, business plus technology skills, the urgency to get things done, experiment and figure out what works, transparency, fluidity of network, growth mindset, and moving from a know-it-all to a learn-it-all mindset. And biggest of all, I think, diversity and inclusion, because you don't know what you don't know in situations like this. And your common biases will kick into play. And the only tool, or rather way to address that bias, the human bias, is diversity. So yes, that brings it down to what are you learning today? What are the deep skills that you're developing? How much of learning and then experimentation are you doing? So I want to invite you to join the Microsoft Dev community. The QR code is here. You can join. What that does, it gives you a monthly newsletter as well. So you keep up with the regular trends. What are the learning? What are those amazing projects that are happening? What are communities talking about? And it's not just the Microsoft community. Go and find all the other open source communities where you're part of a group which is learning, hacking, and growing together. This is another skill that is going to be super important because of the plain fact that technology is growing at such a rapid pace. And it's hard to know everything. Everyone cannot know everything. But you do need to know what technology to use when and who to rope in to kind of build it out further. And the best place is communities. And the one skill you need to have for the future is learning to learn. I spoke about diversity and inclusion. This is a topic very close to my heart. We recently launched Code Without Barriers in the ASEAN and Korea countries. What this does is tackle the problem of developer diversity, especially in the areas of AI. We know that AI runs on trust. If users don't trust AI solutions, that industry is not going to grow. Now, if it runs on trust, that means you have to remove bias. And to remove bias, human bias is very different. You are very difficult. Really, there are so many blind spots. So the only way to really get over the human bias or the unconscious biases that we carry is to have diversity. Diversity in your solution design, diversity in coders, diversity in your data, and diversity all around. So the teams and the solutions that you're building is actually reflecting the users that are going to use it. So diversity and inclusion is not just a feel-good skill to have, but something that you need to actively think about, reflect on, and pursue. And if you are a product manager or a team manager, this is crucial in figuring out how do you help your teams actually unlock potential, removing the shackles of bias, because it does make business sense as well. So bringing that together, we're talking about creating synergy. So it's not enough to just write code, but actually to solve problems. And to solve problems, you need to find where the right problems are. So talking to other people, creating coalitions to identify the right problems, and then solving it through coding and related stuff. Rapid experimentation and complex problem solving. This is a critical skill to have because you don't know when you're going to need these things. So you always have a pipe of experimentation that you're running. on the sidelines, and suddenly it comes really useful. And how do you really do that experimentation and complex business problem solving? Make sure you're continuously upskilling, leveraging communities, just-in-time learning. Microsoft Learn, for example, has a lot of modular learning. So go learn, but also learn through doing and hacking, and with the communities. Of course, inclusion and diversity is core to everything, because it'll ultimately decide also the quality of solutions and teams that you have. So that brings us back to digital transformation, and it's all about the culture of innovation. So real transformation sits at the center of people, process, technology. That used to be the mantra earlier, but today also data. And who do you think is sitting at the center of all this? Having access to the data, the technology, the processes, and the technical people, or even business people who can make this happen. It's you, the developers. Developers, the data scientists, the data engineers. You are the folks who can actually make real culture of innovation and real transformation happen. So wherever you are, the organizations you work with, or the startups that you're running or you're working at, you are very critical to the transformation of your organization and even your nation. So my call to you is to trust yourself and take a seat at the table. If you do not have a voice at the table where business, technology, finance, leadership, all of them are sitting, then it's hard to help them with the skills and the technology and the insights that you have from the data. And it's also difficult for your work to be recognized. So it's super important that you take a seat at the table, that you're no longer waiting for a project to be given to you, but you're actually experimenting on with data that you have, gaining insights and giving it a voice. Especially in today's world, where with the pandemic, your business leaders are actually struggling to figure out which is the new market, which is that store we should keep open, which should be shut down, which is the new product, what's the consumer wanting, why is the consumer not engaging with us. So all of those problems actually have insights sitting with you. Now, when you're sitting at the table, look around and see who else is sitting with you. And that's where inclusion and diversity also comes into play, because now that you're sitting at the table, you have a voice and you can think about what's the diversity of thoughts that should be around the table and bring them in. So I hope you will think about a few of these things. Are you solving the right business problems? Are you driving for insights? What are you measuring and what are you learning? Take your seat at the table, look around and see who else is at the table. So go ahead and master the new developer agenda. Thank you.
Hi, Annie.
Hi,
Yeah,
Satish.
yeah. Thanks a lot for the closing note kind of stuff, Annie. And it was a really exciting day, as you mentioned. From the morning onwards, loads and loads of information. And we would like to thank all our attendees, speakers, and volunteers who joined us today. You are all an important part of the conference, and we sincerely appreciate your attendance one day. We hope you learned something new and had fun, and can't wait to see you all back tomorrow for the sessions. Like tomorrow, again, there are hundreds of sessions tomorrow planned. So until then, bye from the AZConf team.
I
Bye-bye.
just want to give a shout out to the AZConf team. You've been doing this for many years now. And I think this year has been just amazing in the lineup of speakers, a variety of topics. And you've gone beyond technology to cover core topics, which actually uplift human beings as well, like DNI and the other
DMI.
Yes. So kudos to the team. Satish, thank you for having me.
Thanks a lot, Annie. Thanks a lot for your support. Bye-bye.
Bye.